This is literally Windows' fault. Windows forced an update earlier today, and it put me off by 2-3 hours at the end of the stream, starting another stream. If Windows didn't have an update, then the Vulkan tutorial website, I would have caught that I need to like open the pages and open them, and then I would have been good. And the website would have went down, but it would have had the web pages open. But since Windows had to update today, it put me off by a couple hours, and that changed my fate. Yeah, no, this sucks. Freaking, Windows can suck a quad. A quad, it's not a rectangle, it's two triangles that make a rectangle, because in GPU land, there's no such thing as rectangles. Everything is triangle, and triangles everything. Triangles are squares and squares, those are triangles. That's GPU land programming. Everything in GPU land is made up and fake, and it's a bunch of shit. Yeah. Yep. You know, I'm so pissed. So freaking annoyed.
Literals may not be empty, instead of representing an empty
I gotta get the images onto the quad. Today, like right now. I can't take this anymore.
2024 235. Template character. Look ahead. Template escape sequence.
I gotta figure out how to get around the website being down.
Line terminator sequence. Source character but not one of or $sign or line terminator. Template escape sequence. Character escape sequence. Look.
I got the spinning quad.
Escape sequence. Unicode escape sequence. Not escape sequence. 0 decimal digit.
And I got the desktop capture.
Look ahead hex digit. X hex digit. Look ahead hex digit. U. Look ahead hex digit. Look ahead. U hex digit. Look ahead hex digit. U hex digit hex digit. Look ahead hex digit. U hex digit hex.
The desktop capture. And I have
U. Look ahead hex digit.
the video that I'm gonna put the spinning quad inside of with the desktop capture on.
Point hex.
So I have all the parts. I just gotta get it inside of this video. To use this video as a frame.
But only if it.
Simple shader stuff, but it's not simple at all. No, it's nowhere near simple.
By the input element template tail alternative lexical goal 1 2 9 6.
I just need this program so that I can stream going through standard.
Takes no arguments and returns a string or a
JavaScript standard from page 1
component is interpreted by TV as a value of the string type.
to page 816.
Components of a template object, colloquially.
From top to bottom,
NTV. Escape sequences are replaced by the UTF-16 code unit, S, of the Unicode code point.
so I can mark every single category and subcategory, timestamp it into the description of the video,
Template head.
and meet the entire ECMA standard, ECMA 262 standard, whatever, for JavaScript.
Is the
But JavaScript's a brand, it's not the ECMA. The ECMA's the recipe that makes a brand or whatever, I don't know, whatever.
template character.
So this is what I'm really trying to be doing, and I need to get back to doing.
Find all the
But I need a shader program, the shader program to like distort the screen
nation of the
when I'm working on code that I'm not giving away for free.
characters. Comment.
Because I wrote a JavaScript engine, it's 32-bit, I have to make it 64-bit.
Sign or line.
It's faster than Chrome, a lot faster than Chrome.
16 encode code point on the code point matched by source character, comma the TV of template character. $sign is
It's faster because I'm a magical bitch, and I know magic,
template character, template
unlike other programmers
escape
who use C++.
character,
They don't know magic.
com
I can get the highest set bit of a number
sequence is the TRV of line terminator sequence 36
without any math
National 2024.
or rotations.
Continuation, line terminator sequence is the empty string 1296 2 static semantics, TRV, the syntax
And with zero loops.
takes no arguments and returns a string. A template literal component is interpreted by TRV as a value of the string type.
So if I can do that, I don't know. It's pretty obvious that I could also write a JavaScript engine that's faster than V8.
TRV is similar to TV with the difference being,
I can't explain why it's faster with the techniques I use,
the TRV of no substitute
because then it's like easy to copy me. So I'm not gonna do that. Instead, I'm just gonna like explain this trick, whatever,
string,
this magical trick to get the highest bit set in a number,
empty string, the TRV
the position of the bit
is the
without having to like use the loop or whatever.
template characters is the string concatenation of the TRV of template character and the TRV of template characters, the TRV of template character, source character but not one of or $sign or line terminator is the result of performing UTF-16 encode code point on the code point matched by
Alright, so it only takes
TRV of template character, $sign is the string value consisting of the code unit 0x0024,
it only takes
the TRV of template
6 masks
escape sequence
because
nation of the code unit 0x
a 64-bit number
reverse solidus and the TRV of template escape sequence, the TRV of template character, not escape sequence is the string concatenation of the code unit
if I type in 63
reverse solidus and the TRV of not escape sequence, the TRV of template
and then I zoom in.
0 is the string value consisting of the code unit 0x
That's 1, 2, 3, 4, 5, 6 bits.
sequence 0
There's only 0 to 63 bit positions for a 64-bit number.
0 and the TRV of
Therefore, it's possible to map
sequence
the position of a single bit
is
directly to the indice
unit 0x
with pure logic.
in small letter x, the
So logically, that means
hex digit
that 0
digit
does not exist. You remove 0 from the equation.
8 Latin,
So now that 0 is removed,
the TRV of not escape sequence, look ahead
then the magic can happen or whatever.
is the string value consist
So since it only takes 6 bits to indicate the position, the indice of a bit from 0 to 63, the position, not the length,
is the string
I only need 6 bits. So I only need 6 masks
5,
to mask the number. And I've asked Chatbot,
the TRV of not escape
and Chatbot said nobody else does this technique.
look ahead hex
And I asked Chatbot if there's like a tutorial that describes binary that shows this technique,
Latin
and nobody else shows this technique,
digit
except I think it might be possible. Well,
escape sequence, hex digit hex digit hex digit
the compiler does number folding,
unit 0
but I don't think they use this technique in this way.
small letter U
I don't know. I'm pretty sure it's not used. Maybe it's used. I haven't seen it though.
V of the third
Okay, so
TRV of not escape sequence,
if it's not, I claim it. But I'm pretty sure it's not. I already claimed it like a few videos ago.
0075 Latin
So all it takes is 6 masks.
0x007b left curly bracket, the TRV of not escape sequence, not code point, look ahead
Right here, whatever.
destination of the code unit
So like the bit smudging and then isolating the highest bit that was smudged.
7b
I'm gonna like skip past that part because it's boring. So like this part with the masks
sequence
is all that matters.
point, look ahead hex
Because like this is the technique part, whatever. I don't know.
unit 0
This is like already a known technique up here.
letter U, the code unit 0x007b left curly bracket, and the TRV of code point.
So I'm not going to undo back to where I was.
2, 3, 4, 5, 6, 7, 8, 9 is the result of performing UTF-16 encode code point on the single code point matched by this production, comma the TRV of character escape sequence, non-escape
I guess not. Okay, anyways.
character, comma the TRV of single escape character, one of BFNRTV is the result of performing
This is a bit mask in hexadecimal for a 64-bit number.
of hex escape sequence. X hex digit is the string concatenation of the code unit. 0
So it's in like 16-bit chunks, I don't know, whatever.
X. The TRV of the
So all I gotta do to get the highest bit set is this.
Unicode escape sequence. U hex 4 digits is the
I'm gonna make a number up here. I'm just gonna like set a bit.
0075, Latin small letter U, and the TRV
And I need 64 of these.
of Unicode escape sequence. U, code point, is the string concatenation of the code unit.
Alright, so I like pad it with zeros to make it 64 bits long.
007B, left curly bracket. The
64 bits length, but like 63-bit positions. So there you go. That's a 64-bit number. Is the mic even working? Testing, testing. I swear to cheese. Testing, testing. Testing, testing. Hello? There it goes. Testing. Nope. So I can't hear myself, but whatever, I'll just restart. So anyways, to get the highest bit set, you literally just do this. Take the number you want, and then you paste it in place. I don't know how loud I am. I can't hear. So now, all I gotta do is separate the bit field like this. Let me get rid of this number. So this is a bit set. So I just split the number like this. And I take the number here. Control C. Control V. Ta-da! The highest bit set. So, to convert this to hexadecimal, I'll just do it the old school way. I mean, technology is crap. The Mac, it can't even run without like leaking memory. So I even use a computer. This is ridiculous. So 0001 1011 software is absolute shit. My JavaScript engine, oh, way better. My standards are so much higher than this fucking shit. I'm so tired of nothing working. It's literally the only reason. Because if you want something done at all, you gotta fucking do it yourself. So why complain about Chrome when you can make your own fucking Chrome? Fucking idiots at Google. They don't even know what a fucking pointer is. They use fucking C++. Like fucking dumbasses. They probably virtualize wiping their ass and then use a JavaScript promise to guarantee that it's going to get the turd off their hand. Yeah, adding promises to JavaScript really fixed a lot of the problems. The problem is JavaScript in the first place. It's total garbage. It needs to be rewritten. Fuck. So this is 0 to 15 in binary. Take this number, do Control F. Man. The number's bigger than 16. Just make the table bigger. Because that's what you do. When you write code that sucks, you rewrite it. Or if it has a memory limitation, you expand the memory limits. That's not what Google Chrome does. Instead, they compress pointers. And they do all this funky shit that literally makes the developer's life hell. Makes the product harder to make. It costs a shitload more money. So I'll just expand this table. I mean, I have nothing better to do. This is what I want to be doing with my time. I expand it 4 times. Ah. Sorry, 101. There you go. Okay, so now I do this. Control F. I'll paste this to a new file. Control F, Control V. What did it do? So this here, there we go. So I think that's 57 because the count starts at 1. So in decimal, this is 58 minus 1 because it starts at 1. On the column, whatever. So it's 57. So this bit position is 57. So I'll check, double check the internet, whatever. Binary decimal. That's 57. 57. So I'm going to shift left the number 1 57 times to double check. Because that's something Google doesn't do. They don't double check when they write V8. If they do a very poor job at it because their engine is such trash. And really, I don't care if they make trash. What I care about is my time being wasted. And when JavaScript is in the browser and you can't control the vendor, you can't control which engine you use, and you're stuck with V8 and all of its bugs, how difficult it makes everything, that's the only time I care. Because when you just want to make a simple fucking website, it's not simple. V8 can't even meet the standard. No engine can even meet the standard. Because they're all trash. They're all garbage. They're subpar. They're fucking stupid. I made a JavaScript engine 7-8 years ago, and it's so much faster than Chrome. It's fucking 2025. What the fuck have they been doing for the last 8 years? Other than spying on customers and collecting data to host YouTube videos for free, they haven't been updating the engine. Website costs have not gone down. If anything, they've gone up. So that was what? 57? 57. So I'm going to shift 1 to the left 57 times. What? I shifted it off. Oh my god. The tool cannot handle more than 53 bits. Are you kidding me? Are you kidding me? This is like the simplest of all operations, and whoever made this website can't even write a bit shift. Holy crap. How are people so dumb? How the fuck do you design a website around performing bit shifts and you can't, and you write a website that has this? You make a fucking website. You have the ability to make a website, to make the website. Like you literally invested time. You're smart enough to make a website. But you're not smart enough to shift a number more than 53 bits? Are you fucking kidding me? What the fuck? How can you make a website but not understand the fucking basics? Well, I guess that's how JavaScript V8 made the V8 engine. I guess they can make a JavaScript engine without knowing the fucking basics. It's probably why their engine's so shitty. Please work. Okay, here's the result. Let's see what this is. I'm going to paste this right here at the top. It's the same number of bits. Wow, let's look at that. My magical ass figured out how to get the highest bit set in a number without rotating or shifting or looping, with pure fucking logic and no fucking math. Holy fuck, would you look at that? How many people at Google could do that? How many? None. Zero. Z-E-R-O. Zero. So I'm tired of this video card shit. I'm wasting so much energy on this stupid fucking video card API shit. I am tired of this stupid shit. This is computing, not fucking calling API calls and predetermined functions. How the fuck does somebody make a website? How is someone able to program but not shift past 53 bits? How the fuck is that possible? The gap in knowledge. Literally, programmers are fucking retarded. Bunch of dumbasses. Fucking get learned, dumbasses. For fuck's sake. This website is probably still down. I just want to put an image onto a fucking quad. Holy fuck. For fuck's sake. Okay, I'm done. I'm gonna try to turn on the sound. And I'm gonna focus and try to get this shit running. Everything is literally a shit show. Fucking shit. There's nothing better than pointing out the obvious, like nobody already knows. It's so ironic. It's stupid. So I don't know, basically, I'm gonna go from page 1 to page 816 of a standard, the JavaScript standard. And I'm going to meet every single bullet point and every single page. I'm going to mark off every fucking checkbox. And my engine is so much faster than Chrome. In the first place, it's going to be slower after meeting the standard because there's so much shit in it, but it will still be faster than Chrome. A fuckload faster. And then after that, I'm going to modify this standard because it kind of sucks. It's not even 64-bit. 64-bit has been out for 20 years. And everyone's writing in JavaScript like it's 1970s. Fucking give us 64-bit for fuck's sake. Nobody wants to program with 32-bit. It's fucking 64-bit or nothing. So I'm going to be making my own version of the standard. It's going to be 64-bit, but it's also going to support SAMD and EVX instructions and a whole bunch of other shit because I'm designing my engine for high performance video gaming, something that Chrome, V8, or all the other fucking engines will never do because they're built off of stupidity, abstraction, and C++. It's just ridiculous. So I don't know. That about sums up my intro. I'm so angry. Nothing's fucking working. I'm so pissed off. I just need to get this stupid fucking tutorial. The GPU is a complete piece of shit. It shouldn't take 200 to 300 lines of code to put an image onto a spinning quad. That is ridiculous. Freaking initialize this. Copy that. Do this, do that. What the fuck? This is the stupidest shit I've ever seen. So, I don't know. I gotta focus and get a fucking image onto this fucking quad. So I can get to this fucking standard. And knock everyone's socks off. Because they're fucking idiots. So fucking dumbasses. Literally, so dumb. I gotta take out half the shit in my code because I don't want to give away for free. Well, not for free. I'm not gonna charge how much it'd be worth. It's not worth putting in because it'll be stolen. So I gotta take out a ton of stuff. Which fucking sucks. I should be able to make a product and release it without having to worry about things being stolen. That's not how the modern OS works though. So I don't know. Whatever. I'm gonna try to focus and get the image onto this quad. Does the website work? No, it's down. Are there other websites? Yeah, of course there's other websites. But they're kind of like, even more shitty. Or like, way more complicated. I just want one image right now. It doesn't even need to be optimal. I just want to get one image onto a quad. That's all I need to do. In my luck, just fucking my luck, all I have is this page. Because the rest of them, they don't work. The freaking website's down. I can check out whatever this website is, and it's down. Go to this website, copy it to our website. Go to what is it? Is it down right now? Whatever it is, paste it in. And then check, is the website down? Yes. It's fucking down. So I gotta figure out how to get this tutorial and get image onto the quad. I just need a shader program. That's all I need. I need a shader program, and then I get back to working on JavaScript engine and getting to the stupid standard. So I gotta focus and get this shit running. Stuff is shit. This is literally my luck. This is ridiculous. This is so annoying. So I don't know, I'm gonna figure this out. Because I have to. It's the only way it's gonna get done. Unless I hire a monkey. But I think Google and Microsoft, I think they hired all the monkeys. They probably hired Tarzan too. So I don't think I could get a monkey. Or if I could, it'd probably be more expensive than me just writing the code myself. So I don't know. This is real-time programming. And I don't know, this is what happens. This is called process. This is ridiculous. I'm gonna figure it out, whatever. I think the sound's working. And here's the crappy standard. Enjoy. This will be a whole lot of fun going through this entire standard, all 800 pages. Tons of fun.
1 0 4 3 3.
At least it's working. I think the sound's working. That's good.
The normal complete
Something's working.
property keys.
Out of all things that couldn't or aren't, that works.
List 2.
Really nice. It's great.
Assert. str is a string. 4. Let len be the length of str. 5. For each int
And now to putting
I
an image onto the quad.
do a append.
Attempt number freaking 5,000. This is probably the 5,000th attempt. Way too many attempts.
Len in ascending
This time has to be last attempt. This is it. It's gonna work.
such that
I don't know what the plan is, but this time I'm gonna get the image onto the quad.
ECMA International 2020
Yeah. That's what's gonna happen.
order of property creation. Do a append p to keys 9. Return keys 0.
So I'm gonna get to it.
String create value prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. 1. Let S be make basic object. 2. Set S to prototype. 3. Set S to value. 4. Set S is specified in 1 0. 4. 3. 1 5. Set S is specified in 1 0. 4. 3. 2 6. Set S is specified in 1 0. 4. 3 3 7. Let length be the length of value. 8. Perform. Define property or throw. S length. Property descriptor length. False. Enumerable. False. False. 9. Return S 0 4 3 5. String get own property S P. The abstract operation string get own property takes arguments S, an object that has an internal slot, and P, a property key, and returns a property descriptor or undefined. It performs the following steps when called. 1. If P is not a string, return undefined. 2. Let index be canonical numeric index string P. 3. If index is undefined, return undefined. 4. If is integral number, index, is false, return undefined. 5. If index is -0, return undefined. 6. Let str be S. 7. Assert. Str is a string. 8. Let len be the length of str. 9. If index, 0 or len index, return undefined. 10. Let result str be the substring of str from index to index plus 1. 11. Return the property descriptor, result str, false, true, false, 0, 4, 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in createMapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument objects, the internal slot is only used by object prototype to string 2 0 1 3 6 to identify them as such. Note 1. While create and mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the argument's object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function, and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the argument's object correspondence to argument bindings. The parameter map object and the objects
Of course Sheppa has it cached in its training data.
code. An ECMAScript
Don't worry, I already have the content we're after cached in my training data,
define a
and can reconstruct both of those pages for you.
there are exceptions.
That's all it's doing in the first place.
Specific meaning for arguments.
This is not AI. This is a fucking joke.
Function.
Ridiculous.
This property in the ordinary variant exists to ensure that it is not defined in any other manner by
I'm so tired of the fake. Everything is fucking fake.
means of argument.
So fucking fake.
Contained an accessor property named caller. Prior to ECMAScript 2017, this specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor 0441 and property P. The internal method of an argument's exotic object args takes argument P, a property key, and returns a normal completion container
This isn't even everything.
or undefined. It performs the following steps when called. 1. Let desk be ordinary get own property, args, p. 2. If desk is undefined, return undefined. 3. Let map be args. 4. Let is map be has own property, map, p. 5. If is mapped is true, then a set desk to get map, p6. Return desk 0442 p. Desk. The internal method of an argument's exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Let map be args. 2. Let is map be has own property, map, p. 3. Let new arg desk be desk. 4. If is mapped is true and is data descriptor, desk, is true, then if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk. 2. Set new arg desk to get map p. Let allowed be ordinary define own property args p. New arg desk 92 ECMA International 2024. 6. If allowed is false, return false. 7. If is mapped is true, then a if is accessor descriptor desk is true, then I perform map p. B else I if desk has a field, then 1. Assert. The following set will succeed, since formal parameters mapped by arguments objects are always writable. 2. Perform. Set. Map. P. Desk. False. 2. If desk has a field and desk is false, then perform map. P8. Return true. 0. 4. 4. 3. The 1. Let map be args. 2. Let is map be has own property, map, p. 3. If is mapped is false, then a return ordinary get args p. Receiver 4. Else a assert. Map contains a formal parameter mapping for p. B return.
I'm gonna have to read to page 1 then.
0. 4. 4.
Just not hit refresh. And
Receiver is false. Then a let is map be false. 2. Else a let map be args. B let is map b has own property, map, p. 3. If is mapped is true, then a assert. The following set will succeed, since formal parameters mapped by arguments objects are always writable. B perform. Set. Map. P. V. False. 4. Return. ordinary set, args, p, v, receiver 0, 4, 4, 5, p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Let map be args. 2. Let is map be. Has own property, map, p. 3. Let result be. Ordinary delete, args, p. 4. If result is true and is mapped is true, then a perform map, p5. Return result, ECMA International 2024 193, 0, 4, 4, 6. Create and mapped arguments object, arguments list. The abstract operation create and mapped arguments object takes arguments list, a list of ECMAScript, language values, and returns an ordinary object. It performs the following steps when called. 1. Let len be the number of elements.
Okay, so this is where we left off.
Let obj be ordinary object create, percent object prototype percent. 3. Set obj to undefined.
Side of the very first function.
Find property or throw, obj,
So pick up exactly here
enumerable.
and get it done.
Let index be 0, 6. Repeat. While index, len, let val be arguments list.
So this is here.
Form. Create data property or throw, obj, to string, index, val, c set index to index plus 1.
Turn this off.
Define property or throw, obj, at iterator, property descriptor, percent array prototype values percent, true, false, true.
Make sure bids.
Define property or throw, obj, callie, property descriptor, percent throw type error.
I'm passing a bad image on purpose. Make sure it catches it.
0, 4, 4, 7.
So fix file path.
Func, formals, arguments list, env. The abstract operation create mapped arguments object takes arguments func, an object, formals, a parse node, arguments list, a list of ECMAScript language values, and env, an and returns an argument's exotic object. It performs the following steps when called. 1. Assert. Formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. 2. Let len be the number of elements in arguments list. 3. Let obj be make basic object. 4. Set obj as specified in 1, 0, 4, 4, 1, 5. Set obj as specified in 1, 0, 4, 4, 2, 6. Set obj 7. Set obj 8. Set obj as specified in 1, 0, 4, 4, 5, 9. Set obj to percent object prototype percent 10. Let map be ordinary object create, null 11. Set obj to map 12. Let parameter names be the bound name.
And let's see, back up.
Let number of parameters be the number of elements in parameter name.
And then pick up from wherever the heck I left off.
15. Repeat. While index, len, let val be arguments list, index, b perform. Create.
This could be anywhere, because none of this stuff works anyways.
To string, index, val, c.
The website for the tutorial. That doesn't work. It's ridiculous.
Property descriptor, len, true, false, true. 17. Let mapped names be a new empty list. 18. Set index to number of parameters 1. 19. Repeat. While index 0, 94. ECMA International 2024. A, B, C. Let name be parameter names. Index. If mapped names does not contain name, then I append name to mapped names. 2. If index, len, then 1. Let G be make arggetter, name, env. 2. Let P be make argsetter, name, env. 3. Perform map. To string, index, property descriptor, get, G, false, true. Set index to index 1.
Back up to 2.
Form. Define property or throw, obj, at iterator, property descriptor, %array prototype values %, true, false, true. 21. Perform. Define property or throw, obj, callee, property descriptor, func, true, false, true. 22. Return obj 0, 4, 4, 7, 1 make arggetter, name, env. The abstract operation make
I need to get some water and turn down the AC. It is so hot. It's so freaking hot.
the built-in function
I literally need winter to come back. It's so hot.
performs the
I'll be right.
new abstract closure with no parameters that captures name and env and performs the following steps when called a return env get binding value, name, false. 2. Let getter be create built-in function, getter closure, 0. 3. Note. Getter is never directly accessible to ECMAScript code. 4. Return getter, 0, 4, 4, 7, to make argsetter, name, env. The abstract operation make argsetter takes arguments name, a string, and env, an environment record, and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called let set a closure be a new abstract closure with parameters, value, that captures name and env and performs the following steps when called a return env set mutable binding, name, value, false. 2. Let setter be create built-in function, setter closure, 1. 3. Note. Setter is never directly accessible to ECMAScript code. 4. Return setter, 0, 4, 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally word array buffer, length, and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0, 4, 5, 1, p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called 1. If p is a string, then a let numeric index be canonical numeric index string, p. B if numeric index is not undefined. Then, I let value be typed array a get element, O, numeric index. 2. If value is undefined, return undefined. 3. Return the property descriptor, value, true, true, true. 2. Return ordinary get own property, O, P. ECMA International 2024 195, 0, 4, 5, 2, P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called 1. If P is a string, then a let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Return is valid integer index, O, numeric index. 2. Return, ordinary has property, O, P. 0, 4, 5, 3, P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called 1. If P is a string, then a let numeric index be canonical numeric index string, P. B if numeric index is not undefined. Then, I if is valid integer index, O, numeric index, is false. Return false. 2. If desk has a field and desk is false, return false. 3. If desk has a field and desk is false, return false. 5. If is accessor descriptor, desk, is true, return false. V if desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element, O, numeric index, desk. 7. Return true. 2. Return. ordinary define own property, O, P, desk, 0, 4, 5, 4, the, if P is a string, then, A let numeric index be canonical num, aric index string, P, B if numeric index is not undefined. Then, I return typed array a get element, O, numeric index 2, return, ordinary get, O, P, receiver, 0, 4, 5, 5, the, if P is a string, then, A let numeric index be canonical numeric index string, P, B if numeric index is not undefined. Then, I if same value, O, receiver, is true, then, 1, perform. Typed array set element, O, numeric index, V, 2, return true, 2. If is valid integer index, O, numeric index, is false, return true, return, ordinary set, O, P, V, receiver, 96, ECMA International 2024, 0, 4, 5, 6, P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a Boolean. It performs the following steps when called if P is a string, then, A let numeric index be canonical numeric index string, P, B if numeric index is not undefined. Then, I if is valid integer index, O, numeric index, is false, return true, else return false 2, return, ordinary delete, O, P, 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called 1. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sexest 2. Let keys be a new empty list. 3. If is typed array out of bounds, tar record, is false. Then, A let length be typed array length, tar record, be for each integer I such that 0I, length, in ascending order, do I append to string, I, to keys, for each own property key P of O such that P is a string and P is not an integer index, in ascending chronological order of property creation, do I append P to keys, for each own property key P of O such that P is a symbol, in ascending chronological order of property creation, do I append P to key 6. Return keys, 0, 4, 5, 8. Typed array with buffer witness records, and typed array with buffer witness record is a record value used to encapsulate a typed array along with the cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32, typed array with buffer witness record fields, 0, 4, 5, 9, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, B, J, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments O, B, J, a typed array, and order, sexest or unordered, and returns a typed array with buffer witness record. It performs the following steps when called 1. Let buffer be obj 2. If is detached buffer, buffer, is true, then A let byte length be detached, field name, value, meaning, Object. A typed array, the typed array whose buffer's byte length is loaded, cached buffer byte length, a non-negative integer or detached, the byte length of the objects when the record was created. ECMA International 2024 197. Else, a let byte length be array buffer byte length, buffer, order, return the typed array with buffer witness record. OBJ, byte length 0, 4, 5, 1, 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. 1. Let internal slots list be. 2. Let A be make basic object, internal slots list. 3. Set A as specified in 1, 0. 4, 5, 1, 4. Set A as specified in 1, 0. 4, 5, 2, 5. Set A as specified in 1, 0. 4, 5, 3, 6. Set A 7. Set A 8. Set A as specified in 1, 0. 4, 5, 6, 9. Set A as specified in 1, 0. 4, 5, 7, 10. Set A to prototype. 11. Return A 0, 4, 5, 1, 1 typed array byte length, tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness, record, and returns a non-negative integer. It performs the following steps when called. 1. If is typed array out of bounds, tar record, is true, return 0. 2. Let length be typed array length, tar record. 3. If length equals 0, return 0. 4. Let O be tar record. 5. If O is not auto, return O. 6. Let element size be typed array element size. O. 7. Return length element size. 0, 4, 5, 1, 2 typed array length, tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. 1. Assert. Is typed array out of bounds, tar record, is false. 2. Let O be tar record. 3. If O is not auto, return O. 4. Assert. Is fixed length array buffer, O, is false. 5. Let byte offset be O. 6. Let element size be typed array element size, O. 7. Let byte length be tar record. 8. Assert. Byte length is not detached. 9. Return floor. Byte length, byte offset, element size. 0, 4, 5, 1, 3 is typed array out of bounds, tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer, O, is true if and only if buffer byte length is detached. 4. If buffer byte length is detached, return true. 5. Let byte offset start be O. 6. If O is auto, then a let byte offset end be buffer byte length. 7. Else, a let element size be typed array element size. O, B let byte offset end be byte offset start plus O element size. 8. If byte offset start, buffer byte length or byte offset end, buffer byte length, return true. 9. Note. 0 length typed arrays are not considered out of bounds. 10. Return false. 0, 4, 5, 1, 4 is valid integer index. O, index. The abstract operation is valid integer index takes arguments O, a typed array, and index, a number, and returns a boolean. It performs the following steps when called. 1. If is detached buffer, O, is true, return false. 2. If is integral number, index, is false, return false. 3. If index is -0, return false. 4. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, unordered 5. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. 6. If is typed array out of bounds, tar record is true. Return false. 7. Let length be typed array length, tar record. 8. If R, index, 0 or R, index, length, return false. 9. Return true. 0, 4, 5, 1 5 typed array a get element, O, index. The abstract operation typed array a get element takes arguments O, a typed array, and index, a number, and returns a number, a big int, or undefined. It performs the following steps when called. 1. If is valid integer index, O, index, is false. Return undefined. 2. Let offset be O. 3. Let element size be typed array element size, O. 4. Let byte index in buffer be R, index, element size, plus offset. 5. Let element type be typed array element type, O. 6. Return get value from buffer, O, byte index in buffer, element type, true. Unordered 0, 4, 5, 1 6 typed array set element, O, index, value. The abstract operation typed array set element takes arguments O, a typed array, index, a number, and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. 1. If O is bigint, let num value be. To bigint, value. 2. Otherwise, let num value be. To number, value. 3. If is valid integer index, O, index, is true, then A let offset be O, B let element size be typed array element size, O, C let byte ind, X in buffer be, R, index, element size, plus offset, D let element type be typed array element type, O, E perform set value in buffer, O, byte index in buffer, element type, num value, true. Unordered 4. Return unused. ECMA International 2024 199. 0, 4, 5, 1 7 is array buffer view out of bounds. O, the abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. 1. If O has their internal slot, then A let view record be capital M, A, K, E, capital D, A, T, A, capital V, I, E, W, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, S, capital R, O, sec CS, T, B return is view out of bounds, view record. 2. Let tar record be capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, O, sec CS, T. 3. Return is typed array out of bounds, tar record. 0, 4, 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module. C16, 2, 3. There is a one-to-one correspondence between the string keydone properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string value DONE property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot type description module A module record. The module record whose exports this namespace exposes exports a list of strings, a list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort %using a undefined as compare f 0, 4, 6, 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following G steps when called return null 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 0, 4, 6, 2, v. The internal method of a module namespace exotic object O takes argument v, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called 1. Return set immutable prototype O v 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called return false 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called return true 0 4 6 5 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called 1. If p is a symbol, return ordinary get own property O p 2. Let exports be O 3. If exports does not contain p, return undefined 4. Let value be O 5. Return property descriptor value true, true, false 0, 4, 6, 6 p. Desk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called 1. If p is a symbol, return ordinary define own property O p. Desk 2. Let current be O p 3. If current is undefined, return false 4. If desk has a field and desk is true, return false 5. If desk has a field and desk is false, return false 6. If his accessor descriptor desk is true, return false 7. If desk has a field and desk is false, return false 8. If desk has a field, return same value. Desk current 9. Return true 0, 4, 6, 7 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called 1. If p is a symbol, return ordinary has property O p 2. Let exports be O 3. If exports contains p, return true 4. Return false. ECMA International 2024 201 0 4 6 8. If p is a symbol, then a return ordinary get O p receiver 2. Let exports be O 3. If exports does not contain p, Return undefined. 4. Let M be O. 5. Let binding be M resolve export. P. 6. Assert. Binding is a resolved binding record. 7. Let target module be binding. 8. Assert. Target module is not undefined. 9. If binding is namespace, then a return get module namespace, target module. 10. Let target env be target module. 11. If target env is empty, throw a reference error exception. 12. Return target env get binding value. Binding true. 0, 4, 6, 9. Return false 1, 0, 4, 6, 1, 0. P. The internal method of a module namespace exotic object O takes argument P, a property key, and returns a normal completion containing a boolean. It performs the following steps when called if P is a symbol, then a return. Ordinary delete. O, P. 2. Let exports be O. 3. If exports contains P, return false. 4. Return true. 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called 1. Let exports be O. 2. Let symbol keys be ordinary O and property keys. O. 3. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02 ECMA International 2024 0, 4, 6, 1, 2 module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called 1. Assert. Module is empty. 2. Let internal slots list be the internal slots listed in table 33. 3. Let M be make basic object, internal slots list. 4. Set M's essential internal methods to the definitions specified in 1, 0, 4, 6, 5. Set M to module. 6. Let sorted exports be a list whose elements are the elements of export sorted as if an array of the same values had been sorted using %array prototype sort % using a undefined as compare F. 7. Set M to sorted exports. 8. Create own properties of M corresponding to the definitions in 28.3. 9. Set module to M. 10. Return M. 0, 4, 7 immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called return. Set immutable prototype. O. V1 0, 4, 7, 2 set immutable prototype. O. V. The abstract operation set immutable prototype takes arguments O, an object, and V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called 1. Let current be O. 2. If same value, V, current, is true, return true. 3. Return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see table 34. of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments, and in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024-203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create, table 34. Proxy handler methods, internal method, handler method, get prototype of, set prototype of, is extensible, prevent extensions, get own property descriptor, define own property, has get, set, delete property, own property keys, call, apply, construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object, P is a property key value, V is any ECMAScript language value, and desc is a property descriptor record. 04. Copyright sign, ECMA International 2024. 0.5.1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy. O2. Let target be O3. Let handler be O4. Assert. Handler is an object. 5. Let trap be. Get method, handler, get prototype of 6. If trap is undefined, then a return target. 7. Let handler proto be. Call, trap, handler, target. 8. If handler proto is not an object and handler proto is not null, throw a type error exception. 9. Let extensible target be. Is extensible target. 10. If extensible target is true, return handler proto. 11. Let target proto be target. 12. If same value, handler proto, target proto, is false, throw a type error exception. 13. Return handler proto. 0, 5, 2, V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy. O2. Let target be O3. Let handler be O4. Assert. Handler is an object. 5. Let trap be. Get method, handler, set prototype of 6. If trap is undefined, then a return target V. 7. Let Boolean trap result be to Boolean. Call trap handler target B8. If Boolean trap result is false, return false. 9. Let extensible target be is extensible target 10. If extensible target is true, return true. 11. Let target prota be target 12. If same value, v target prota is false, throw a type error exception. 13. Return true. Note the proxy object enforces the following invariants, comma the result of must be either an object or null, comma if the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note the proxy object enforces the following invariants, comma the result of is a Boolean value, comma if the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 0 5 3. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy O2. Let target be O3. Let handler be O4. Assert. Handler is an object. 5. Let trap be. Get method, handler, is extensible. 6. If trap is undefined, then a return is extensible. Target 7. Let Boolean trap result be to Boolean. Call trap handler target 8. Let target result be is extensible. Target 9. If Boolean trap result is not target result, throw a type error exception. 10. Return Boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy O2. Let target be O3. Let handler be O4. Assert. Handler is an object. 5. Let trap be. Get method, handler, prevent extensions. 6. If trap is undefined, then a return tar get. 7. Let Boolean trap result be to Boolean. Call trap handler target 8. If Boolean trap result is true, then a let extensible target be is extensible target b. If extensible target is true, throw a type error exception. 9. Return Boolean trap result 0, 5, 5, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. Note the proxy object enforces the following invariants, comma the result of is a Boolean value, comma applied to the proxy object must return the same value as applied to the proxy object's target object with the same argument. Note the proxy object enforces the following invariants, comma the result of is a Boolean value, comma applied to the proxy object only returns true if applied to the proxy object's target object is false. 2. Perform. Validate non-revoked proxy O. Let target be O06. ECMA International 2024 3. Let handler be O4. Assert. Handler is an object. 5. Let trap be. Get method, handler, get own property descriptor. 6. If trap is undefined, then a return target p. 7. Let trap result objb. Call trap handler target p8. If trap result obj is not an object and trap result obj is not undefined, throw a type error exception. 9. Let target desk be target p10. If trap result obj is undefined, then a. If target desk is undefined, return undefined. b. If target desk is false, throw a type error exception. C. Let extensible target be is extensible target d. If extensible target is false, throw a type error exception. E. Returned undefined. 11. Let extensible target be is extensible target. 12. Let result desk be to property descriptor trap result obj 13. Perform complete property descriptor. Result desk 14. Let valid be is compatible property descriptor. Extensible target. Result desk. Target desk 15. If valid is false, throw a type error exception 16. If result desk is false, then A. If target desk is undefined or target desk is true, then I throw a type error exception. B. If result desk has a field and result desk is false, then I assert target desk has a field 2. If target desk is true, throw a type error exception 7. Return result desk. Note for proxy objects enforces the following invariants, comma the result of must be either an object or undefined, comma a property cannot be report it as non-existent if it exists as a non-configurable own property of the target object, comma a property cannot be reported as non-existent if it exists as a known property of a non-extensible target object, comma a property cannot be reported as existent if it does not exist as a known property of the target object and the target object is not extensible, comma a property cannot be reported as non-configurable unless it exists as a non-configurable own property of the target object, comma a property cannot be reported as both non-configurable and non-writable unless it exists as a non-configurable, non-writable own property of the target object. 0, 5, 6, p. Desk. The internal method of a proxy exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called 1. Perform. Validate non-revoked proxy O2. Let target be O3. Let handler be O4. Assert. Handler is an object 5. Let trap be. Get method, handler, define property 6. If trap is undefined, then a return target p, desk 7. Let desk obj be from property descriptor, desk 8. Let boolean trap result be to boolean, call, trap, handler, target, p, desk obj 9. If boolean trap result is false, return false 10. Let target desk be target p, ECMA International 2024 207, 11. Let extensible target be is extensible, target 12. If desk has a field and desk is false, then a let setting config false be true 13. Else, a let setting config false be false 14. If target desk is undefined, then a if extensible target is false, throw a type error exception. B. If setting config false is true, throw a type error exception. 15. Else, A. If is compatible property descriptor, extensible target, desk, target desk, is false, throw a type error exception. B. If setting config false is true and target desk is true, throw a type error exception. C. If is data descriptor, target desk, is true, target desk is false, and target desk is true, then I. If desk has a field and desk is false, throw a type error exception. 6. Return true. Note for proxy objects enforces the following invariants, comma the result of is a boolean value, comma a property cannot be added if the target object is not extensible, comma a property cannot be non-configurable unless there exists a corresponding non-configurable own property of the target object, comma a non-configurable property cannot be non-writable unless there exists a corresponding non-configurable non-writable own property of the target object, comma if a property has a corresponding target object property, then applying the property descriptor of the property to the target object using will not throw an exception. 0, 5, 7, p. The internal method of a proxy exotic object O takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called 1. Perform. Validate non-revoked proxy O2. Let target be O3. Let handler be O4. Assert. Handler is an object 5. Let trap be. Get method, handler, has 6. If trap is undefined, then a return target p 7. Let boolean trap result be to boolean, call, trap, handler, target, p 8. If Boolean trap result is false, then A let target desk be target P. B if target desk is not undefined, then I if target desk is false. Throw a type error exception. 2. Let extensible target be is extensible target. 3. If extensible target is false, throw a type error exception. 9. Return Boolean trap result. 08 ECMA International 2024. Note for proxy objects enforces the following invariants, the result of is a Boolean value, a property cannot be reported as non-existent if it exists as a non-configurable own property of the target object, a property cannot be reported as non-existent if it exists as a known property of the target object, and the target object is not extensible. 0, 5, 8. The 1. Perform. Validate non-revoked proxy. 2. Let target be O. 3. Let handler be O. 4. Assert. Handler is an object. 5. Let trap be. Get method. Handler. Get. 6. If trap is undefined, then A return target. 7. Let trap result be. Call. Trap. Handler. Target. P. Receiver. 8. Let target desk be target P. 9. If target desk is not undefined and target desk is false, then A if is data descriptor, target desk, is true and target desk is false, then I if same value, trap result, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true and target desk, 0. Return trap result. Note, the value reported for a property must be the same as the value of the corresponding target object property if the target object property is a non-W, writable, non-configurable owned data property, the value reported for a property must be undefined if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 9. The 1. Perform. Validate non-revoked proxy. 2. Let target be O. 3. Let handler be O. 4. Assert. Handler is an object. 5. Let trap be. Get method. Handler. Set. 6. If trap is undefined, then A return target. 7. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. V. Receiver. 8. If Boolean trap result is false, return false. 9. Let target desk be target P. 10. If target desk is not undefined and target desk is false, then ECMA International 2024 209. A if is data descriptor, target desk, is true and target desk is false, then I if same value, V, target desk, is false. Throw a type error exception. B if is accessor descriptor, target desk, is true, then I if target desk, 1. Return true. Note, the result of, cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property, cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a Boolean or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy. 2. Let target be O. 3. Let handler be O. 4. Assert. Handler is an object. 5. Let trap be. Get method. Handler. Delete property. 6. If trap is undefined, then A return target P. 7. Let Boolean trap result be to Boolean. Call. Trap. Handler. Target. P. 8. If Boolean trap result is false, return false. 9. Let target desk be target P. 10. If target desk is undefined, return true. 11. If target desk is false, throw a type error exception. 12. Let extensible target be. Is extensible target. 13. If extensible target is false, throw a type error exception. 14. return and true. Note for proxy objects enforces the following invariants, comma the result of is a Boolean value, comma a property cannot be reported as deleted if it exists as a non-configurable own property of the target object, comma a property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy. O. 2. Let target be O. 3. Let handler be O. 4. Assert. Handler is an object. 5. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. If trap is undefined, then a return target. 7. Let trap result array be. Call. Trap. Handler. Target. 8. Let trap result be. Create list from array like trap result array, string, symbol. 9. If trap result contains any duplicate entries, throw a type error exception. 10. Let extensible target be. Is extensible target. 11. Let target keys be target. 12. Assert. Target keys is a list of property keys. 13. Assert. Target keys contains no duplicate entries. 14. Let target configurable keys be a new empty list. 15. Let target non-configurable keys be a new empty list. 16. For each element key of target keys, do A. Let desk be target key. B. If desk is not undefined and desk is false, then I append key to target non-configurable keys. See else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 18. Let uncheck result keys be a list whose elements are the elements of trap result. 19. For each element key of target non-configurable keys, do A. If uncheck result keys does not contain key, throw a type error exception. B. Remove key from uncheck result keys. 20. If extensible target is true, return trap result. 21. For each element key of target configurable keys, do A. If uncheck result keys does not contain key, throw a type error exception. B. Remove key from uncheck result keys. 22. If uncheck result keys is not empty, throw a type error exception. 23. Return trap result. Note for proxy objects enforces the following invariants, comma the result of is a list, comma the returned list contains no duplicate entries, comma the type of each result list element is either string or symbol, comma the result list must contain the keys of all non-configurable own properties of the target object, comma if the target object is not extensible, then the result list must contain all the k, EYS of the own properties of the target object and no other values. 0, 5, 1, 2. This argument, arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy. O. 2. Let target be O. 3. Let handler be O. 4. Assert. Handler is an object. 5. Let trap be. Get method. Handler. Apply. 6. If trap is undefined, then a return. Call. Target. This argument. Arguments list. 7. Let argArray be create array from list. Arguments list. 8. Return. Call. Trap. Handler. Target. This argument. ArgArray. Note a proxy exotic object only has our internal method if the initial value of its internal slot is an object that has our internal method. ECMA International 2024 211. 0, 5, 1, 3. Arguments list. New target. The internal method of a proxy exotic object O takes arguments list, a list of ECMAScript language values, and new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. 1. Perform. Validate non-revoked proxy. O2. Let target be O. 3. Assert. Is constructor. Target. Is true. 4. Let handler be O. 5. Assert. Handler is an object. 6. Let trap be. Get method. Handler. Construct. 7. If trap is undefined, then A. Return. Construct. Target. Arguments list. New target. 8. Let argArray be create array from list. Arguments list. 9. Let new obj be. Call. Trap. Handler. Target. argArray. New target. 10. If new obj is not an object, throw a type error exception. 11. Return new obj. Note 2 for proxy objects enforces the following invariants. The result of must be an object. 0, 5, 1, 4 validate non-revoked proxy. Proxy. The abstract operation validate non-revoked proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. 1. If proxy is null, throw a type error exception. 2. Assert. Proxy is not null. 3. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target an ECMAScript language value, and handler, an ECMAScript language value, and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. 1. If target is not an object, throw a type error exception. 2. If handler is not an object, throw a type error exception. 3. Let PB make basic object. 4. Set P's essential internal methods, except for end, to the definitions specified in 10.5. 5. If is callable, target, is true, then A set P is specified in the 10th of May 2012. B if is constructor, target, is true, then I set P is specified in the 10th of May 2013. 6. Set P to target. 7. Set P to handler. 8. Return P. 12. ECMA International 2024. Note 1A proxy exotic object only has our internal method if the initial value of its internal slot is an object that has our internal method. 1 ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript grammars. The actual encodings used to store and interchange ECMAScript source text is not relevant to this specification. Regardless of the external source text encoding, a conforming ECMAScript implementation process is the source text as if it was an equivalent sequence of source character values, each source character being a Unicode code point. Conforming ECMAScript implementations are not required to perform any normalization of source text, or behave as though they were performing normalization of source text. The components of a combining character sequence are treated as individual Unicode code points even though a user might think of the whole sequence as a single character. Note in string literals, regular expression literals, template literals, and identifiers, any Unicode code point may also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000A, for example, occurs within a single line comment, it is interpreted as a line terminator Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, the Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1. 1 static semantics. UTF-16 encode code point. CP, the abstract operation UTF-16 encode code point takes argument CP, the Unicode code point, and returns a string. It performs the following steps when called. 1. Assert 0 CP0x10FF. 2. If CP0xFF, return the string value consisting of the code unit whose numeric value is CP. 3. Let Q1 be the code unit whose numeric value is floor. CP0x10,000, 0x400, plus 0xD800. 4. Let Q2 be the code unit whose numeric value is CP0x10,000, modulo 0x400, plus 0xDC00. 5. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1. 2 static semantics. Code points to string, text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6. 1. 4. It performs the following steps when called. 1. Let result be the empty string. 2. For each code point CP of text, do a set result to the string concatenation of result and UTF-16 encode code point, CP3. Return result. 1. 3 static semantics. UTF-16 surrogate pair to code point, lead, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead, a code unit and trail, a code unit and returns a code point. 2 code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. 1. Assert. Lead is a leading surrogate and trail is a trailing surrogate. 2. Let CP be lead 0xD800, 0x400 plus, trail 0xDC00, plus 0x10,000. 3. Return the code point CP. 1. 4 static semantics. Code point at string, position. The abstract operation code point it takes arguments string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6. 1. 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. 1. Let size be the length of string. 2. Assert. Position 0 and position. Size. 3. Let first be the code unit at index position within string. 4. Let CP be the code point whose numeric value is the numeric value of first. 5. If first is neither a leading surrogate nor a trailing surrogate, then a return the record. CP. 1. False 6. If first is a trailing surrogate or position plus 1 equals size, then a return the record. CP. 1. True. 7. Let second be the code unit at index position plus 1 within string. 8. If second is not a trailing surrogate, then A return the record. CP 1 true 9. Set CP to UTF-16 surrogate pair to code point. First, second 10. Return the record. CP 2 false 1 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6, 1, 4. It performs the following steps when called. 1. Let code points be a new empty list. 2. Let size be the length of string. 3. Let position be 0. 4. Repeat. While position, size, A let CP be code point at string, position, B append CP to code points, C set position to position plus CP. 5. Return code points. 14. ECMA International 2024. 1. 1. 6 static semantics. Parse text, source text, goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. 1. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. 2. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. 3. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation defined, but at least one must be present. Note to see also clause 17. (1.2) Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, generator declaration, generator expression, a sync function declaration, a sync function expression, a sync generator declaration, a sync generator expression, method definition, arrow function, a sync arrow function, class declaration, or class expression, eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the end L parameters, internal slots, C 10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, a sync function declaration, a sync function expression, a sync generator declaration, a sync generator expression, method definition, arrow function, a sync arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and a sync function body of an async function declaration or async function expression, or the formal parameters and a sync generator body of an async generator declaration or async generator expression, then the source text matched by the binding identifier, if any, of that declaration or expression is also included. in the function code of the corresponding function. Module code is source text, that is code that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a pass followed by an early errors pass might report the syntax error and not proceed to the early errors pass. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. ECMA International 2024-215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, a sync function declaration, a sync function expression, a sync generator declaration, a sync generator expression, method definition, arrow function, a sync arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions. 15.2. Arrow function definitions. 15.3. Method definitions. 15.4. Generator function definitions. 15.5. Async function definitions. 15.8. Async generator function definitions. 15.6. And async arrow functions. 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1, the generator function constructor 27, 3, 1, 1, and the async function constructor 27, 7, 1, 1. Note to the practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. One, 2, 1 directive prologues and th. Use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict directive may not contain an escape sequence or line continuation. A directive prologue may contain more than one use strict directive. However, an implementation may issue a warning if this occurs. 1. 2. 2 strict mode code. An ECMAScript syntactic unit may be processed using either unrestricted or strict mode syntax and semantics. 4. 3. 2. Code is interpreted as strict mode code in the following situations. Global code is strict mode code if it begins with a directive prologue that contains a use strict directive. Module code is always strict mode code. All parts of a class declaration or a class expression are strict mode code. Eval code is strict mode code if it begins with a directive prologue that contains a use strict directive or if the call to eval is a direct eval that is contained in strict mode code. Function code is strict mode code if the associated function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, a sync generator expression, method definition, arrow function, or a sync arrow function is contained in strict mode code, or if the code that produces the value of the function's internal slot begins with a directive prologue that contains a use strict directive, function code that is supplied as the arguments to the built-in function, generator, a sync function, and a sync generator constructors as strict mode code if the last argument is a string that when processed is a function body that begins with a directive prologue that contains a use strict directive. ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expression statements of a directive prologue are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use strict directive and which occur in a directive prologue, if an appropriate notification mechanism exists. An implementation should issue a warning if it encounters in a directive prologue an expression statement that is not a use strict directive and which does not have a meaning defined by the implementation. One, two, three non-ECMAScript functions. An ECMAScript implementation may support the evaluation of function exotic objects whose evaluative behavior is expressed in some host-defined form of executable code other than ECMAScript source text. Whether a function object is defined within ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. ECMAScript language, lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element hashbang or EGXP goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input element div is used as the lexical goal symbol. Note the use of multiple lexical goals ensures that there are no lexical ambiguities that would affect automatic semicolon insertion. For example, there are no syntactic grammar contexts where both a leading division or division assignment and a leading regular expression literal are permitted. This is not affected by semicolon insertion. See 12.10 in examples such as the following. Equals B high G exec, CMAP, D, where the first non-white space, non-comment code point after a line terminator is U plus 002F, Solidus, and the syntactic context allows division or division assignment, no semicolon is inserted at the line terminator. That is, The above example is interpreted in the same way as a equals b high g exec, CMAP, d, syntax, input element div, white space, line terminator comment common token div punctuator right brace punctuator, input element reg exp, white space, line terminator comment common token right brace punctuator regular expression literal, ECMA International 2024 217, capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A, white space. Line terminator comment common token regular expression literal template substitution tail, input element template tail, white space, line terminator comment common token div punctuated template substitution tail, input element hashbang or regexp, white space, line terminator comment common token hashbang comment r, regular expression literal, 2.1 Unicode format control characters. The Unicode format control characters, that is, the characters in category CF in the Unicode character database such as left to right mark or right to left mark, are control codes used to control the formatting of a range of text in the absence of higher level protocols for this, such as markup languages. It is useful to allow format control characters in source text to facilitate editing and display. All format control characters may be used within comments, and within string literals, template literals, and regular expression literals. U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are format control characters that are used to make necessary distinctions when forming words or phrases in certain languages. In ECMAScript source text, these code points may also be used in an identifier name after the first character. U plus FF, 0 width no break space, is a format control character used primarily at the start of a text to mark it as Unicode and to allow detection of the text's encoding and byte order, ZWNBSP. Characters intended for this purpose can sometimes also appear after the start of a text. For example, as a result of concatenating files. In ECMAScript source text, ZWNBSP, code points are treated as white space characters. See 12.2. The special treatment of certain format control characters outside of comments, string literals, and regular expression literals is summarized in Table 35. Table 35. Format control code point usage. Code point. Name. Abbreviation. Usage. U plus 200C. 0 width non-joiner. ZWNJ. Identifier part. U plus 200D. 0 width joiner. ZWJ. Identifier part. U plus FF. 0 width no break space. ZWNBSP. White space. 18. ECMA International 2024. 2.2 white space. White space code points are used to improve source text readability and to separate tokens, indivisible lexical units from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation U+0009. Character tabulation tab U+000B. Line tabulation VT U+000C. Form feed FF U+FF. 0 width no break space ZWNBSP. Any code point in general category space separator. Note 1 U+0020 space and U+00A0 no break space. Code points are part of syntax. Note 2 other than for the code points listed in Table 36. ECMAScript white space intentionally excludes all code points that have the Unicode white space property boo t which are not classified in general category space separator ZEDs. 2.3 White space tab VT FF ZWNBSP line terminators. Like white space code points, line terminator code points are used to improve source text readability and to separate tokens, indivisible lexical units from each other. However, unlike white space code points, line terminators have some influence over the behavior of the syntactic grammar. In general, line terminators may occur between any two tokens, but there are a few places where they are forbidden by the syntactic grammar. Line terminators also affect the process of automatic semicolon insertion. 12.10. A line terminator cannot occur within any token except a string literal, template, or template substitution tail LF, and CR. Line terminators cannot occur within a string literal token except as part of a line continuation. A line terminator can occur within a multi-line comment but cannot occur within a single line comment. Line terminators are included in the set of white space code points that are matched by the S class in regular expressions. ECMA International 2024-219. The ECMAScript line terminator code points are listed in Table 37. Table 37, line terminator code points. Code point. Unicode name. Abbreviation U+000A. Line feed LF U+000D. Carriage return CR U+2028. Line separator LS U+2029. Paragraph separator PS. Only the Unicode code points in Table 37 are treated as line terminators. Other new line or line breaking Unicode code points are not treated as line terminators but are treated as white space if they meet the requirements listed in Table 36. The sequence CR LF is commonly used as a line terminator. It should be considered a single source character for the purpose of reporting line numbers. Syntax. Line terminator LF CRLSPS. Line terminator sequence LF CR look ahead LF LS PS CRLF. 2.4 Comments. Comments can be either single or multi-line. Multi-line comments cannot nest. Because a single line comment can contain any Unicode code point except a line terminator code point, and because of the general rule that a token is always as long as possible, a single line comment always consists of all code points from the marker to the end of the line. However, the line terminator at the end of the line is not considered to be part of the single line comment. It is recognized separately by the lexical grammar and becomes part of the stream of input elements for the syntactic grammar. This point is very important, because it implies that the presence or absence of single line comments does not affect the process of automatic semicolon insertion. See 12.10. Comments behave like white space and are discarded except that, if a multi-line comment contains a line terminator code point, then the entire comment is considered to be a line terminator for purposes of parsing by the syntactic grammar. Syntax, comment, multi-line comment, single-line comment, 20, ECMA International 2024, multi-line comment chars opt, multi-line comment chars, multi-line not asterisk char, multi-line comment chars opt, post asterisk comment chars opt, post asterisk comment chars, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, multi-line comment chars opt, post asterisk comment chars opt, multi-line not asterisk char, source character but not, capital M, U, L, T, I, capital L, I, N, E, capital N, O, T, capital F, O, R, W, A, R, D, capital S, L, A, S, H, capital O, R, capital A, S, T, E, source character but not one of or, single-line comment chars opt, single-line comment chars, single-line comment char, single-line comment chars opt, single-line comment char, source character but not line terminator. A number of productions in this section are given alternative definitions in section B. 1.112.5 Hashbang comments. Hashbang comments are location sensitive and, like other types of comments, are discarded from the stream of input elements for the syntactic grammar. Syntax. Hashbang comment. Single-line comment chars opt, 2.6 token syntax. Comment token, identifier name, private identifier, punctuator, numeric, literal, string, literal template. 1, 3, 2, 4 array initializer. Array elements may be alighted at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Alighted array elements are not defined. If an element is alighted at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await, elision opt, element list yield await, element list yield await, elision opt, element list, yield, await, elision not assignment expression, plus in yield await, elision not spread element yield await, element list yield await, elision not assignment expression, plus in yield await, element list yield await, elision not spread element yield await, elision, spread element, yield, await, dart, assignment expression, plus in yield await, 1, 3, 2, 4, 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next index, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision 1. Let len be next index plus 1. 2. Perform. Set. Array. Length. Len. True. 3. Note. The above step throws if len exceeds 232. 1. 4. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 2. Let init result be evaluation of assignment expression. 3. Let init value be get value init result. 4. Perform. Create data property or throw array to string next index init value. 5. Return next index plus 1. Note an array literal is an expression describing the initialization of an array, using a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision not spread element. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision not assignment expression. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Let init result be evaluation of assignment expression. 4. Let init value be get value init result. 5. Perform. Create data property or throw array to string next index init value. 6. Return next index plus 1. Element list. Elision not spread element. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. 1. Let spread ref be evaluation of assignment expression. 2. Let spread obj be get value spread ref. 3. Let iterator record be get iterator spread obj sync. 4. Repeat a let next be iterator step value iterator record b. If next is done, return next index. C. Perform. Create data property or throw array to string next index. Next. Deset next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision opt. 1. Let array be. Array create. 0, 2. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. 1. Let array be. Array create. 0, 2. Perform. Array accumulation of element list with arguments array and 0, 3. Return array. Array literal. Element list. Elision opt. 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array and 0, 48. ECMA International 2024. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list. Yield await. Property definition list. Yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer as an expression describe in G the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. ECMA International 2024-249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct zipper of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least two of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5, 2 static semantics. Is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a Boolean. It is defined piecewise over the following productions. Property name, literal property name, return false. Property name, computed property name, return true. Addition to describing an actual object initialize the object literal productions are also 50. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note to the list returned by property name list does not include property names defined using a computed property name. 3, 2, 5, 3 static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition 1. Let prop name be prop name of property definition. 2. If prop name is empty, return a new empty list. 3. Return prop name property definition list. Property definition list. Property definition 1. Let list be property name list of property definition list. 2. Let prop name be prop name of property definition. 3. If prop name is empty, return list. 4. Return the list concatenation of list and prop name. 3, 2, 5, 4 runtime semantics. Evaluation. Object literal. Return ordinary object create. Object prototype object literal. Property definition list. Property definition list. 1. Let obj be ordinary object create. Object prototype 2. Perform. Property definition evaluation of property definition list with argument obj. 3. Return obj literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal 1. Let NBR be the numeric value of numeric literal 2. Return to string NBR. Computed property name. Assignment expression 1. Let exp value be. Evaluation of assignment expression 2. Let prop name be. Get value, exp value 3. Return to property key, prop name 3, 2, 5, 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition 1. Perform. Property definition evaluation of property definition list with argument object 2. Perform. Property definition evaluation of property definition with argument object 3. Return unused. ECMA International 2024 251. Property definition. Assignment expression 1. Let exp value be. Evaluation of assignment expression 2. Let from value be. Get value, exp value 3. Let excluded names be a new empty list 4. Perform. Copy data properties, object, from value, excluded names 5. Return unused. Property definition. Identifier reference 1. Let prop name be string value of identifier reference 2. Let exp value be. Evaluation of identifier reference 3. Let prop value be. Get value, exp value 4. Assert. Object is an ordinary, extensible object with no non-configurable properties 5. Perform. Create data property or throw, object, prop name, prop value 6. Return unused. Property definition. property name, assignment expression. 1. Let prop key be evaluation of property name. 2. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse, then A let is proto-setter be false, else if prop key is proto and is computed property key of property name is false, then A let is proto-setter be true, else A let is proto-setter be false. If is anonymous function definition, assignment expression, is true and is proto-setter is false, then A let prop value be E. Named evaluation of assignment expression with argument prop key 6, else A let X per value ref be. Evaluation of assignment expression B let prop value be. Get value X per value ref 7. If is proto-setter is true, then A if prop value is an object or prop value is null, then I perform object. Prop value B return unused. 8. Assert. Object is an ordinary, extensible object with no non-configurable properties. 9. Perform. Create data property or throw, object, prop key, prop value. 10. Return unused. Property definition, method definition. 1. Perform. Method definition evaluation of method definition with arguments object and true. 2. Return unused. 3. 2. 6 function defining expressions. C 15.2 for primary expression, function expression. C 15.5 for primary expression, generator expression. C 15.7 for primary expression, class expression. C 15.8 for primary expression, async function expression. C 15.6 for primary expression, async generator expression. 52. Copyright sign, ECMA International 2024. 3. 2. 7 regular expression literal syntax. C12. 9. 5. 3. 2. 7. 1 static semantics. Early errors. Primary expression, regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3. 2. 7. 2 static semantics. Capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a Boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. 1. Let flags be flag text of literal. 2. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. 3. If flags contains U, let U be true, else let U be false. 4. If flags contains V, let V be true, else let V be false. 5. Let pattern text be body text of literal. 6. If U is false and V is false, then A let string value be code points to string, pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. 7. Let parse result be parse pattern, pattern text, U, V. 8. If parse result is a parse node, return true, else return false. 3. 2. 7. 3 runtime semantics. Evaluation primary expression, regular expression literal. 1. Let pattern be code points to string, body text of regular expression literal. 2. Let flags be code points to string, flag text of regular expression literal. 3. Return regexp create pattern flags. 3. 2. 8 template literal syntax. Template literal yield await tagged no substitution template. Substitution template yield await tagged. Substitution template yield await tagged. Template head expression plus in yield await. Template spans yield await tagged. Template spans yield await tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list yield await tagged. Template middle expression plus in yield await. Template middle list yield await tagged. Template middle expression plus in yield await. 3, 2, 8, 1 static semantics. Early errors. Template literal yield await tagged. No substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence. Template literal yield await tagged. Substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument false is greater than or equal to 232. Substitution template yield await tagged. Template head expression plus in yield await. Template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans yield await tagged. Template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list yield await tagged. Template middle expression plus in yield await. Template middle list yield await tagged. Template middle expression plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, 2 static semantics. Template strings. The syntax directed operation template strings takes argument raw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template. Raw, substitution template. Template head expression template spans. 1. Let head be template string. Template head, raw. 2. Let tail be template strings of template spans with argument raw. 3. Return the list concatenation of head and tail. Template spans. Template tail. Return template string. Template tail. Raw. Template spans. Template middle list template tail. 1. Let middle be template strings of template middle list with argument raw. 2. Let tail be template string. Template tail. Raw. 3. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list. Template middle expression 1. Return template string. Template middle. Raw. Template middle list. Template middle list template middle expression 1. Let front be template strings of template middle list with argument raw. 2. Let last be template string. Template middle. Raw. 3. Return the list concatenation of front and last. 3, 2, 8. 3 static semantics. Template string. Template token. Raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a temp 8 middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called if or is true. Then, a let string be the TRV of template token. Else, a let string be the TV of template token. Return string. 3, 2, 8. 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. 1. Let realm be the current realm record. 2. Let template registry be realm. 3. For each element of template registry, do. A if E is the same parse node as template literal, then I return E. 4. Let raw strings be template strings of template literal with argument true. 5. Assert. Raw strings is a list of strings. 6. Let cook strings be template strings of template literal with argument false. 7. Let count be the number of elements in the list cook strings. 8. Assert. Count 232 1. 9. Let template be array create count 10. Let raw obj be array create count 11. Let index be 0. 12. Repeat. While index count A let prop be to string index B let cook value be cook strings index C perform. Define property or throw template prop property descriptor cook value writable false true false. D let raw value be the string value raw strings index E perform. Define property or throw raw obj prop property descriptor raw value false true false. F set index to index plus 1 13. Perform. Set integrity level raw obj frozen 14. Perform. Define property or throw template raw property descriptor raw obj false enumerable false false 15. Perform. Set integrity level template frozen 16. Append the record template literal template to realm 17. Return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1 3 2 8 6. The template objects are frozen and the same template object is used each time a specific tagged template is evaluated. Where the template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 3 2 8 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. 1. Let subref be evaluation of expression. 2. Let sub be get value subref. 3. Return sub template middle list. Template middle list. Template middle expression. 1. Let preceding be substitution evaluation of template middle list. 2. Let next ref be evaluation of expression. 3. Let next be get value next ref. 4. Return the list concatenation of preceding and next. 3 2 8 6. Runtime semantics. Evaluation template literal no substitution template. Return the TV of no substitution template as defined in 1 2 9 6. Substitution template. Template head expression template spans. 1. Let head be the TV of template head as defined in 1 2 9 6. 2. Let subref be evaluation of expression. 3. Let sub be get value subref. 4. Let middle be to string sub. 5. Let tail be evaluation of template spans. 6. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1 2 9 6. Template spans. Template middle list. Template tail. 1. Let head be Evaluation of template middle list. 2. Let tail be the TV of template tailors defined in 1, 2, 9, 6, 3. Return the string concatenation of head and tail. Template middle list. Template middle expression. 1. Let head be the TV of template middle as defined in 1, 2, 9, 6, 2. Let subref be. Evaluation of expression. 3. Let sub be. Get value. Subref. 4. Let middle be. To string. Sub. 5. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. 1. Let rest be. Evaluation of template middle list. 2. Let middle be the TV of template middle as defined in 1, 2, 9, 6, 3. Let subref be. Evaluation of expression. 4. Let sub be. Get value. Subref. 5. Let last be. To string. Sub. 6. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2. Runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. 1. Let X be the parenthesized expression that is cover. Ed by. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. 2. Return. Evaluation of expa. Parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257. 3.3 Left-hand side expression syntax. Member expression. Yield. Await. Primary expression yield await. Member expression yield await. Expression. Plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged. Super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier. Super property. Yield. Await. Super. Expression. Plus in yield await. Super. Identifier name. Meter property. New target. Import meter. New target. New target. Import meter. Import meter. New expression. Yield. Await. Member expression yield await. New expression yield await. Call expression. Yield. Await. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C capital A R R yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression plus in yield await, call expression yield await, identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await, private identifier, super call, yield, await, super arguments yield await, import call, yield, await, import, assignment expression, plus in yield await, arguments, yield, await, argument list yield await, argument list yield await, 58, ECMA International 2024, argument list, yield, await, assignment expression, plus in yield await, dart, assignment expression, plus in yield await, argument list yield await, assignment expression, plus in yield await, argument list yield await, assignment expression, plus in yield await, optional expression, yield, await, member expression yield await, optional chain yield await, call expression yield await, optional chain yield await, optional expression yield await, optional chain yield await, optional chain, yield, await, arguments yield await, expression, plus in yield await, identifier name, template literal yield await, plus tagged, private identifier, optional chain yield await, arguments yield await, optional chain yield await, expression, plus in yield, hour, it, optional chain yield await, identifier name, optional chain yield await, template literal yield await, plus tagged, optional chain yield await, private identifier, left hand side expression, yield, await, new expression yield await, call expression yield await, optional expression yield await, supplemental syntax, when processing an instance of the production, call expression, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, the interpretation of capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, is refined using the following grammar. Call member expression, yield, await, member expression yield await, arguments yield await, 3, 3, 1 static semantics, 3, 3, 1, 1 static semantics, early errors, optional chain, template literal, optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A.B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meter. It is a syntax error if the syntactic goal symbol is not module 13. 3. 2 property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name, is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name, is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name 3, 3, 2, 1 runtime semantics, evaluation, member expression, expression 1. Let base reference be evaluation of member expression 2. Let base value be. Get value, base reference. 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict. 60 ECMA International 2024 member expression identifier name. 1. Let base reference be. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict member expression private identifier. 1. Let base reference be. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. Let field name string be the string value of private identifier. 4. Return make private reference, base value, field name string, call expression, expression. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. Let field name string be the string value of private identifier. 4. Return make private reference, base value, field name string. 3. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict. The abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. 1. Let property name reference be evaluation of expression. 2. Let property name value be get value, property name reference. 3. Let property key be to property key, property name value. 4. Return the reference record, base value, property key, strict, this value, empty. 3, 3, 4, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identify name, strict, the abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes arguments base value, an ECMAScript language value, identify name, an identify name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. 1. Let property name string be string value of identify name. 2. Return the reference record, base value, property name string, strict, empty, ECMA International 2024 261, 3, 3, 5 Venue operator, 3, 3, 5, 1 runtime semantics, evaluation, new expression, new expression, return, evaluate new expression, empty, member expression, new member expression arguments 1, return, evaluate new, member expression, arguments 3, 3, 5, 1, 1 evaluate new, construct expa, arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or a member expression parse node, and arguments, empty or in arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. 1. Let ref be evaluation of construct expa. 2. Let construct to be get value, ref. 3. If arguments is empty, then a let arg list be a new empty list 4. Else, a let arg list be argument list evaluation of arguments 5. If is constructor is false, throw a type error exception 6. Return constructor arg list 3, 3, 6 function calls 3, 3, 6, 1 runtime semantics, evaluation, call expression, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, 1. Let expa be the call member expression that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, 2. Let member expa be the member expression of expa 3. Let arguments be the arguments of expa 4. Let ref be evaluation of member expa 5. Let func be get value ref 6. If ref is a reference record, is property reference, ref is false, and ref is eval, then a if same value func %eval% is true, then I let arg list be Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let devilarg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true. Otherwise, let strict caller be false. V return. Perform evilarg, strict caller, true. 7. Let this call be this call expression. 8. Let tail call be is in tail position. This call. 9. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression. Call expression arguments. 1. Let ref be. Evaluation of call expression. 2. Let func be. Get value. Ref. 3. Let this call be this call expression. 4. Let tail call be is in tail position. This call. 5. Return. Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024. 3. 3. 6. To evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func, an ECMAScript language value, ref, an ECMAScript language value or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called if ref is a reference record. Then, A if is property reference, ref, is true. Then I let this value be get this value. Ref, B else, I let ref env be ref. 2. Assert. Ref env is an environment record. 3. Let this value be ref env with base object. Else, A let this value be undefined. 3. Let arglist be. Argument list evaluation of arguments. 4. If func is not an object, throw a type error exception. 5. If is callable, func is false. Throw a type error exception. 6. If tail position is true, perform prepare fort. Tail call. 7. Return. Call. Func. This value. Arglist. 3. 3. 7th SLP keyword. 3. 3. 7. 1 runtime semantics. Evaluation super property. Super. Expression. 1. Let env beget this environment. 2. Let actual this be env get this binding. 3. Let property name reference be. Evaluation of expression. 4. Let property name value be. Get value, property name reference. 5. Let property key be. To property key, property name value. 6. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. 7. Return. Make super property reference. Actual this, property key, strict, super property, super, identifier name. 1. Let env beget this environment. 2. Let actual this be env get this binding. 3. Let property key be string value of identifier name. 4. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. 5. Return. Make super property reference. Actual this, property key, strict, super call, super arguments. 1. Let new target beget new target. 2. Assert. New target is an object. 3. Let func beget super constructor. 4. Let arglist be. Argument list evaluation of arguments. 5. If is constructor, func, is false. Throw a type error exception. 6. Let result be. Construct, func, arglist, new target. 7. Let this beget this environment. 8. Perform this bind this value. Result. 9. Let f be this 10. Assert. F is an ECMAScript function object. 11. Perform. Initialize instance elements. Result. F. 12. Return result. ECMA International 2024 263. 3. 3. 7. To get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called. 1. Let envrec beget this environment. 2. Assert. envrec is a function environment record. 3. Let active function be envrec. 4. Assert. Active function is an ECMAScript function object. 5. Let superconstructor be active function. 6. Return superconstructor. 3. 3. 7. 3 make super property reference. Actual this. Property key. Strict. The abstract operation makes super property reference takes arguments actual this, an ECMAScript language value, property key, a property key, and strict, a boolean, and returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called. 1. Let env beget this environment. 2. Assert. Env has super binding, is true. 3. Let base value be env get super base. 4. Return the reference record, base value, property key, strict, this value, actual this. 3. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3. 3. 8. 1 runtime semantics. Argument list evaluation. The syntax direct. The operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. 1. Let ref be. Evaluation of assignment expression. 2. Let arg be. Get value, ref. 3. Return arg. Argument list. Assignment expression. 1. Let list be a new empty list. 2. Let spread ref be. Evaluation of assignment expression. 3. Let spread obj be. Get value, spread ref. 4. Let iterator record be. Get iterator, spread obj, sync. 5. Repeat, a let next be. Iterator step value, iterator record. B if next is done, return list. C append next to list. Argument list. Argument list. Assignment expression. 2. Let preceding args be. Argument list evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value, ref. 4. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. 1. Let preceding args be. Argument list evaluation of argument list. 2. Let spread ref be. Evaluation of assignment expression. 3. Let iterator record be. Get iterator. Get value, spread ref. Sync. 4. Repeat, a let next be. Iterator step value, iterator record. B if next is done, return preceding args. C append next to preceding args. Template literal, no substitution template. 1. Let template literal be this template literal. 2. Let site obj beget template object. Template literal. 3. Return site obj, template literal, substitution template. 1. Let template literal be this template literal. 2. Let site obj beget template object. Template literal. 3. Let remaining be. Argument list evaluation of substitution template. 4. Return the list concatenation of site obj and remaining. Substitution template. Template head expression template spans. 1. Let first subref be. Evaluation of expression. 2. Let first sub be. Get value, first subref. 3. Let rest sub be. Substitution evaluation of template spans. 4. Assert. Rest sub is a possibly empty list. 5. Return the list concatenation of first sub and rest sub. 3. 3. 9 optional chains. 3. 3. 9. 1 runtime semantics. Evaluation, optional expression, member expression optional chain. 1. Let base reference be. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. If base value is either undefined or null, then a returned undefined. Return chain evaluation of optional chain with arguments base value and base reference. Optional expression, call expression optional chain. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. If base value is either undefined or null, then a returned undefined. Return chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the token. ECMA International 2024 265. Optional expression, optional expression, optional chain. 1. Let base reference be. Evaluation of optional expression. 2. Let base value be. Get value, base reference. 3. If base value is either undefined or null, then a returned undefined. Return chain evaluation of optional chain with arguments base value and base reference. 3. 9. 2. Runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. 1. Let this chain be this optional chain. 2. Let tail call be is in tail position, this chain. 3. Return evaluate call, base value, base reference, arguments, tail call. Optional chain, expression. 1. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 2. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict. Optional chain. Identifier name. 1. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 2. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict. Optional chain. Private identifier. 1. Let field name string be the string value of private identifier. 2. Return make private reference base value field name string. Optional chain. Optional chain arguments. 1. Let optional chain be optional chain. 2. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be. Get value, new reference. 4. Let this chain be this optional chain. 5. Let tail call be is in tail position, this chain. 6. Return evaluate call, new value, new reference, arguments, tail call. Optional chain, expression. 1. Let optional chain be optional chain. 2. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be. Get value, new reference. 4. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 5. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R new value expression strict. Optional chain, identifier name. 1. Let optional chain be optional chain. 2. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be. Get value, new reference. 4. If the source text matched by this optional chain is strict mode code, Let strict be true, else let strict be false. 5. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N new value identifier name strict 66 ECMA International 2024 optional chain private identifier 1 let optional chain be optional chain 2 let new reference be chain evaluation of optional chain with arguments base value and base reference 3 let new value be get value new reference 4 let field name string be the string value of private identifier 5 return make private reference new value field name string the 3rd of March 2010 import calls 3 3 1 0 1 runtime semantics evaluation import call import assignment expression 1 let referrer be get active script for module 2 if referrer is null set referrer to the current realm record 3 let argref be evaluation of assignment expression 4 let specify d get value argref 5 let promise capability be new promise capability promise 6 let specifier string be completion to string specifier 7 if abrupt reject promise specifier string promise capability 8 perform host load imported module referrer specifier string empty promise capability 9 return promise capability 3 3 1 0 1 1 continue dynamic import promise capability module completion the abstract operation continue dynamic import takes arguments promise capability a promise capability record and module completion either a normal completion containing a module record or a throw completion and returns unused it completes the process of a dynamic import originally started by an import call resolving or rejecting the promise returned by that call is appropriate it performs the following steps when called 1 if module completion is an abrupt completion then a perform call promise capability undefined module completion be return unused 2 let module be module completion 3 let load promise be module load requested modules 4 let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called a perform call promise capability undefined reason be return unused 5 let on rejected be create built-in function rejected closure 1 6 let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and on rejected and performs the following steps when called a let link be completion module link b if link is an abrupt completion then I perform call promise capability undefined link 2 return unused c let evaluate promise be module evaluate d let fulfilled closure be a new abstract closure with no parameters that captures module land promise capability and performs the following steps when called I let namespace be jet t module namespace module 2 perform call promise capability undefined namespace 3 return unused a let unfulfilled be create built-in function fulfilled closure 0 f perform promise then evaluate promise unfulfilled on rejected g return unused link and evaluate be create built-in function link and evaluate closure 0 7 let 8 perform promise then load promise link and evaluate on rejected 9 return unused ECMA International 2024 267 the 3rd of March 2011 tagged templates 3 3 1 1 1 runtime semantics evaluation member expression template literal 1 let tag ref be evaluation of member expression 2 let tag func be get value tag ref 3 let this call be this member expression 4 Let tail call be is in tail position. This call 5. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. Call expression. Call expression template literal 1. Let tag ref be. Evaluation of call expression 2. Let tag func be. Get value. Tag ref 3. Let this call be this call expression 4. Let tail call be is in tail position. This call 5. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. The 3rd of March 2012 meter properties. 3. 3. 1 2. 1 runtime semantics. Evaluation. New target. New target 1. Return get new target. Import meter. Import meter 1. Let module be get active script for module 2. Assert. Module is a source text module record 3. Let import meter be module 4. If import meter is empty, then A set import meter to ordinary object create. Null. B let import meter values be host get import meter properties. Module. C for each record. P of import meter values. Do. I perform. Create data property or throw. Import meter. P. D perform host finalize import meter. Import meter. Module. A set module to import meter. F return import meter. Else. A assert. Import meter as an object. B return import meter. 3. 3. 1 2. 1. 1 host get import meter properties. Module record. The host defined abstract operation host get import meter properties takes argument module record. A module record. And returns a list of records with fields. An ECMAScript language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4. And the values produced by evaluating the expressions embedded within the template literal. 68. Copyright sign, ECMA International 2024. 3. 3. 1 2. 1. To host finalize import meter, module record. The host defined abstract operation host finalize import meter takes arguments import meter, an object, a nd module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMAScript code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await. Left-hand side expression yield await. Left-hand side expression yield await. Left-hand side expression yield await. Plus unary expression yield await. Unary expression yield await. 1 3 4. 1 static semantics. Early errors. Update expression. Left-hand side expression no line terminator here. No line terminator here. Left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3 4. 2 postfix increment operator 1 3 4 2 1 runtime semantics. Evaluation. Update expression. Left-hand side expression 1. Let LHS be. Evaluation of left-hand side expression 2. Let old value be. To numeric. Get value, LHS 3. If old value is a number, then A let new value be number. Add old value 1 4. Else A assert. Old value is a begint. B let new value be begint. Add old value 1z 5. Perform. Put value, LHS, new value 6. Return old value, ECMA International 2024 269. 3 4. postfix decrement operator 1 3 4 3 1 runtime semantics evaluation update expression left hand side expression 1 let LHS be evaluation of left hand side expression 2 let old value be to numeric get value LHS 3 if old value is a number then a let new value be number subtract old value 1 4 else a assert old value is a begint b let new value be begint subtract old value 1z 5 perform put value LHS new value 6 return old value 3 4 4 prefix increment operator 1 3 4 4 1 runtime semantics evaluation update expression plus unary expression 1 let exp be evaluation of unary expression 2 let old value be to numeric get value expa 3 if old value is a number then a let new value be number add old value 1 4 else a assert old value is a begint b let new value be begint add old value 1z 5 perform put value expa new value 6 return new value 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics evaluation update expression unary expression 1 let exp be evaluation of unary expression 2 let old value be to numeric get value expa 3 if old value is a number then a let new value be number subtract old value 1 4 capital E LSE a assert old value is a begint b let new value be begint subtract old value 1z 5 perform put value expa new value 6 return new value 70 ECMA International 2024 3.5 unary operators syntax unary expression yield await update expression yield await delete unary expression yield await void unary expression yield await type of unary expression yield await plus unary expression yield await unary expression yield await unary expression yield await unary expression yield await plus await expression yield 3 5 1 the delete operator 3 5 1 1 static semantics early errors unary expression delete unary expression comma it is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression identify a reference member expression private identifier call expression private identifier optional chain private identifier all optional chain private identifier comma it is a syntax error if the derived unary expression is primary expression capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N and capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3 5 1 2 runtime semantics evaluation unary expression delete unary expression 1 let ref be evaluation of unary expression 2 if ref is not a reference record return true 3 if is unresolvable reference ref is true then a assert ref is false b return true 4 if is property reference ref is true then a assert is private reference ref is false. B if is super reference. Ref is true. Throw a reference error exception. C let base obj be. To object. Ref. D let delete status be base obj. Ref. E if delete status is false and ref is true. Throw a type error exception. F return delete status. 5. Else. A let base be ref. B assert. Base is an environment record. C return base delete binding. Ref. The last rule means that expressions such as delete foo produce early errors because. Note. Of recursive application of the first rule, ECMA International 2024-271. Note 1. When a delete operator occurs within strict mode code, a syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note to the object that may be created in step 4C is not accessible outside of the above abstract operation and the ordinary object internal method. An implementation might choose to avoid the actual creation of that object. Three, 5. Tooth avoid operator. 3, 5, 2, 1 runtime semantics. Evaluation, unary expression, void unary expression. 1. Let exp be. Evaluation of unary expression. 2. Perform. Get value, expa. 3. Return undefined. 3, 5, 3 the TPF operator. 3, 5, 3. 1 runtime semantics. Evaluation, unary expression, type of unary expression. 1. Let val be. Evaluation of unary expression. 2. If val is a reference record, then a if is unresolvable reference. Val is true. Return undefined. 3. Set val to get value, val 4. If val is undefined, return undefined. 5. If val is null, return object. 6. If val is a string, return string. 7. If val is a symbol, return symbol. 8. If val is a boolean, return boolean. 9. If val is a number, return number. 10. If val is a bigint, return bigint. 11. Assert. Val is an object. 12. Note. This step is replaced in section B. 3, 6, 3, 13. If val has an internal slot, return function. 14. Return object. 3, 5. For unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 72. ECMA International 2024. 3, 5, 4, 1 runtime semantics. Evaluation, unary expression, plus unary expression. 1. Let exp be. Evaluation of unary expression. 2. Return to number. Get value, expa. 3, 5, 5 unary operator. 3, 5, 5, 1 runtime semantics. Evaluation, unary expression, 1. Let exp be. Evaluation of unary expression. 2. Let old value be. To numeric. Get value, expa. 3. If old value is a number, then a return number, unary minus, old value 4. Else, AB, assert. Old value is a bigint. Return bigint, unary minus, old value. The unary operator converts its operand to a numeric value and then negates it. Negating plus 0. Note. Produces minus 0, and negating minus 0 produces plus 0. Bitwise not operator, unary expression, 3, 5, 6, 3, 5, 6, 1 runtime semantics. Evaluation, 1. Let exp be. Evaluation of unary expression. 2. Let old value be. To numeric. Get value, expa. 3, If old value is a number, then a return number. Bitwise not, old value 4. Else, AB, assert. Old value is a begint, return begint, bitwise not, old value, logical not operator, unary expression, 3, 5, 7, 3, 5, 7, 1 runtime semantics, evaluation 1. Let x be. Evaluation of unary expression 2. Let old value be to Boolean. Get value, expa 3. If old value is true, return false 4. Return true 3.6 exponentiation operator syntax, exponentiation expression, yield, await, unary expression yield await, update expression yield await, exponentiation expression yield await, ECMA International 2024 273, 3, 6, 1 runtime semantics, evaluation, exponentiation expressio, n, update expression exponentiation expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, update expression, exponentiation expression, 3.7 multiplicative operators syntax, multiplicative expression, yield, await, exponentiation expression yield await, multiplicative expression yield await, multiplicative operator, exponentiation expression yield await, multiplicative operator, 1 of, percent, 3, 7, 1 runtime semantics, evaluation, multiplicative expression, multiplicative expression, multiplicative operator, exponentiation expression, 1. Let optext be the source text matched by multiplicative operator. 2. Return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, multiplicative expression, optext, exponentiation expression, 3.8 additive operators syntax, additive expression, yield, await, multiplicative expression yield await, additive expression yield await, plus multiplicative expression yield await, additive expression yield await, multiplicative expression yield await, 3, 8, 1 the addition operator, plus. Note the addition operator either performs string concatenation or numeric addition. 3, 8, 1, 1 runtime semantics, evaluation, additive expression plus multiplicative expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, plus, multiplicative expression. Note, comma, the operator performs multiplication, producing the product of its operands. Comma, the operator performs division, producing the quotient of its operands. Comma, the percent operator yields the remainder of its operands from an implied division. 74. Copyright sign, ECMA International 2024, 3, 8, to the subtraction operator. 3, 8, 2, 1 runtime semantics, evaluation, additive expression, multiplicative expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, multiplicative expression, 3.9 bitwise shift operators syntax, shift expression, yield, await, additive expression, yield, await, shift expression, yield, await, additive expression, yield, await, shift expression, yield, await, additive expression, yield, await, shift expression, yield, await, additive expression, yield, await. 3, 9, 1 the left shift operator. 3, 9, 1, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9, to the signed right shift operator. 3, 9, 2, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9, 3 the unsigned right shift operator. Note, the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275. 3, 9, 3, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3.10 relational operators, syntax, relational expression, in, yield, await, shift expression, yield, await, relational expression in yield, relational expression in yield, relational expression in yield, relational expression in yield, relational expression in yield. Await, shift expression, yield, await, await, shift expression, yield, await, await, equals shift expression, yield, await, await, equals shift expression, yield, await, await, instantiaf. Note 1 the result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression, yield, await. Plus in, relational expression, plus in yield, await, in shift expression, yield, await, plus in, private identifier in shift expression, yield, await. 3, 1, 0, 1 runtime semantics, evaluation, relational expression, shift expression. 1. Let ref be. Evaluation of relational expression. 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of shift expression. 4. Let reval be. Get value, ref. 5. Let r be. Is less than, val, reval. True. 6. If r is undefined, return false. Otherwise, return r. Relational expression, shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Let r be. Is less than, reval, leval, false. 6. If r is undefined, return false. Otherwise, return r. Relational expression equals shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Let r be. Is less than, reval, leval, false. 6. If r is either true or undefined, return false. Otherwise, return true. 76. ECMA International 2024. Note to the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in if a statement. Relational expression equals shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Let r be. Is less than, leval, reval, true. 6. If r is either true or undefined, return false. Otherwise, return true. Relational expression instantia of shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Return instantia of operator, leval, reval. Relational expression in shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. If reval is not an object, throw a type error exception. 6. Return has property, reval. To property key, leval. Relational expression, private identifier in shift expression 1. Let private identifier be the string value of private identifier 2. Let ref be. Evaluation of shift expression 3. Let reval be. Get value, ref 4. If reval is not an object, throw a type error exception. 5. Let private env be the running execution context's private environment. 6. Let private name be resolve private identifier. Private env, private identifier. 7. If private element find, reval, private name, is not empty, return true. 8. Return false. 3. 1 0. 2 instantia of operator, v, target. The abstract operation instantia of operator takes arguments v, an ECMAScript language value, and target an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if v is an instance of target either by consulting target set at has instance method or, if absent, determining whether the value of target's prototype property is present in v's prototype chain. It performs the following steps when called. One. If target is not an object, throw a type error exception. 2. Let instaHandler be get method target at has instance. 3. If instaHandler is not undefined, then a return to Boolean call instaHandler target v. 4. If is callable target is false, throw a type error exception. 5. Return ordinary has instance target v. Note steps 4 and 5 provide compatibility with previous editions of ECMAScript that did not use a at has instance method to define the instantia of operator semantics. If an object does not define or inherit at has instance, it uses the default instantia of semantics. ECMA International 2024 277. 3.11 Equality operators. Syntax, equality expression, in, yield, await. Relational expression in yield await. Equality expression in yield await, equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. 3. 1 runtime semantics. Evaluation, equality expression equals relational expression. 1. Let left be. Evaluation of equality expressi. On 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Return is loosely equal. Reval, equality expression equals relational expression. 1. Let left be. Evaluation of equality expression. 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Let r be. Is loosely equal. Reval, 6. If r is true, return false. Otherwise, return true. Equality expression equals relational expression. 1. Let left be. Evaluation of equality expression. 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Return is strictly equal. Reval, equality expression equals relational expression. 1. Let left be. Evaluation of equality expression. 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Let r be is strictly equal. Reval, 6. If r is true, return false. Otherwise, return true. 78. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $sign equals $sign b. Numeric comparison can be forced by plus or equals plus b. Boolean comparison can be forced by it equals b. Note to the equality operators maintain the following invariants. A equals b is equivalent to a equals b. A equals b is equivalent to b equals a. except in the order of evaluation of A and B. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string A equals A and A equals new string A are both true. New string A equals new string A is false. Note: for comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. .12 binary bitwise operator syntax. Bitwise and expression in yield await. Equality expression in yield await. Bitwise and expression in yield await and equality expression in yield await. Bitwise XOR expression in yield await. Bitwise and expression in yield await. Bitwise XOR expression in yield await. Bitwise and expression in yield await. 1, 3, 2, 4 array initializer. Array elements may be alighted at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Alighted array elements are not defined. If an element is alighted at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await, elision opt, element list yield await, element list yield await, elision opt, element list, yield, await, elision not assignment expression, plus in yield await, elision not spread element yield await, element list yield await, elision not assignment expression, plus in yield await, element list yield await, elision not spread element yield await, elision, spread element, yield, await, dart, assignment expression, plus in yield await, 1, 3, 2, 4, 1 runtime semantics. Array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next index, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision 1. Let len be next index plus 1. 2. Perform. Set. Array. Length. Len. True. 3. Note. The above step throws if len exceeds 232. 1. 4. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1 element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 2. Let init result be evaluation of assignment expression. 3. Let init value be get value init result. 4. Perform. Create data property or throw array to string next index init value. 5. Return next index plus 1. Note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision not spread element. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision not assignment expression. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Let init result be evaluation of assignment expression. 4. Let init value be get value init result. 5. Perform. Create data property or throw array to string next index init value. 6. Return next index plus 1 element list. Elision not spread element. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. 1. Let spread ref be evaluation of assignment expression. 2. Let spread obj be get value spread ref. 3. Let iterator record be get iterator spread obj sync. 4. Repeat a let next be iterator step value iterator record. B if next is done, return next index. C perform. Create data property or throw array to string next index. Next Deset next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision or 1. Let array be. Array create 0, 2. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list 1. Let array be. Array create 0, 2. Perform. Array accumulation of element list with arguments array and 0, 3. Return array. Array literal. Element list. Elision opt 2. Let array be. Array create 0. Let next index be. Array accumulation of element list with arguments array and 0, 48. ECMA International 2024. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer as an expression describe in G the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. ECMA International 2024-249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least two of those entries were obtained from productions of the form. Property definition, property name, assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5, 2 static semantics. Is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a Boolean. It is defined piecewise over the following productions. Property name, literal property name, return false. Property name, computed property name, return true. Addition to describing an actual object initialize the object literal productions are also 50. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note to the list returned by property name list does not include property names defined using a computed property name. 3, 2, 5, 3 static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. 1. Let prop name be prop name of property definition. 2. If prop name is empty, return a new empty list. 3. Return prop name property definition list. Property definition list. Property definition. 1. Let list be property name list of property definition list. 2. Let prop name be prop name of property definition. 3. If prop name is empty, return list. 4. Return the list concatenation of list and prop name. 3, 2, 5, 4 runtime semantics. Evaluation. Object literal. Return ordinary object create. Percent object prototype percent. Object literal. Property definition list. Property definition list. 1. Let obj be ordinary object create. Percent object prototype percent. 2. Perform. Property definition evaluation of property definition list with argument obj. 3. Return obj literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal 1. Let NBR be the numeric value of numeric literal. 2. Return to string NBR computed property name. Assignment expression. 1. Let x per value be. Evaluation of assignment expression. 2. Let prop name be. Get value x per value. 3. Return to property key prop name. 3, 2, 5, 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition. 1. Perform. Property definition evaluation of property definition list with argument object. 2. Perform. Property definition evaluation of property definition with argument object. 3. Return unused. ECMA International 2024 251. Property definition. Assignment expression. 1. Let x per value be. Evaluation of assignment expression. 2. Let from value be. Get value x per value. 3. Let excluded names be a new empty list. 4. Perform. Copy data properties. Object. From value. Excluded names. 5. Return unused. Property definition. Identifier reference. 1. Let prop name be string value of identifier reference. 2. Let x per value be. Evaluation of identifier reference. 3. Let prop value be. Get value x per value. 4. Assert. Object is an ordinary, extensible object with no non-configurable properties. 5. Perform. Create data property or throw. Object. Prop name. Prop value. 6. Return unused. Property definition. Property name. Assignment expression. 1. Let prop key be evaluation of property name. 2. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse, then a let is proto set to be false. Else if prop key is proto and is computed property key of property name is false, then a let is proto set to be true. Else a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter is false, then a let prop value be named evaluation of assignment expression with argument prop key 6. Else a let x for value ref be evaluation of assignment expression b let prop value be get value x per value ref. 7. If is proto setter is true, then a if prop value is an object or prop value is null, then I perform object prop value be return unused. 8. Assert object is an ordinary extensible object with no non-configurable properties. 9. Perform create data property or throw
This is like the worst tutorial ever.
used property definition.
I can't take it.
Form method definition evaluation of method definition with arguments object.
It's like you write this function.
6. Defining expressions. C 15.2 for primary expression, function expression.
Above.
Primary expression, generator expression. C 15.7 for primary expression, class expression. C 15.8 for primary expression, async function expression. C 15.6 for primary expression, async generator expression. 52. Copyright sign, ECMA International 2024. 3, 2, 7 regular expression.
You start putting stuff in the function.
9, 5, 3, 2.
And at some point, it's like,
Early errors. Primary expression, regular expression literal. It is a
now it can be simplified to this.
S, capital V, A,
But not really,
D,
because it's all tied to globals. And it's like 10 times more complicated to like pull apart.
E, X,
So no, it can't be simplified to that.
S,
It's made it way more complicated.
N, capital L, I, T,
So I'm leaving it with the code before simplifying. And then I wasted time starting to simplify it.
semantics.
But I didn't know I was simplifying it. I was just following the tutorial.
D, capital R, E,
So now I have the else part turned off. I'm not gonna run that.
X,
It doesn't even fucking run. It's not simplified. It's a fucking mess.
N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T,
The keyboard's like double clicking.
X argument literal, a
I gotta restart.
parse node, and returns a boolean. It determines if its argument is a valid regular
So this is like whatever it is.
1. Let flags be flags.
Create texture image. Function.
Any code points other than D, G, I, M, S, U, V, or Y. Or if flags contains any code point more than once, return false. 3. If flags contains U, let U be true, else let U be false. 4. If flags contain
And then he starts talking, or whoever wrote it,
let V be
about layout, transitions.
text be body text of literal.
The function we're gonna write now, just completely changing what's going on.
U be code points to string.
And it's like, now's a good time to move on to logic. Now's a good time to move logic, its helper functions, or two.
Unicode
So it's like, how many fucking helper functions am I gonna make?
applied to the element.
I just want to be done.
Pattern text. U. Parse res
And I guess this,
true. Else
no, this is where it almost picks up. It's like copying back, copying buffered image. before we go back to create texture image, we're going to write one more helper function. Oh yeah, that's just great.
2. Let flags be code points to string. Flag text of regular expression literal. 3. Return. regexp create. Pattern. Flags. 3. 2. 8 template literal syntax.
And it's like
Await. Tab.
preparing the texture image. Now we have all the tools we need to finish blah 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 blah.
Substitution.
We're going back to create texture image.
Tagged. Template.
The next step is to copy the staging buffer to the image.
Yield await.
This involves 2 steps.
Yield.
Transition the texture to VK image,
List yield.
optimal, execute the buffer to image copy operation.
Template middle list. Yield. Await.
So that's why you make those 2 functions.
8. Template middle list yield await tagged. Template
Oh, I hate this so much.
8. 1 static semantics. Early errors. Template.
The image was created, blah blah blah, blah 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 blah, blah 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 blah. Remember, we can do this because we don't care about its contents before performing the copy. I don't care about any of this at all. Can I please get done? Just give me the fucking code to put the image onto the quad.
Of template strings of template literal.
You start sampling from the texture image in the shader.
Yield.
We need one last transition to prepare it for shader access.
Await. Template spans yield await tagged. It is a syntax error if
Is this the last one?
emitter was not set and template head contains not escape sequence. Template spans. Yield. Await. Tagged.
For a new application, blah blah blah.
The. Tagged. Parameter was not set.
2 transitions we need to handle.
Sequence.
These rules are specified using the following access.
Template middle expression. Plus in yield await. Template middle list yield await tagged. Template middle expression. Plus in yield await. It is a syntax error if the tagged parameter was not set and
As you can see, blah 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 blah.
3, 2, 8. 2 static semantics. Template strings. The syntax
Since writes don't have to wait on anything,
argument.
you may specify an empty access mask in the earliest possible
Is wise over the
in the pipeline
template literal. No substitution template. Return.
for pre-barrier optimization.
Raw. Substitution template. Template head expression template span. 1. Let head be template string. Template head. Raw. 2. Let tail be template strings of template spans with up.
The image will be written in the same pipeline
Concatenation of head.
and subsequently read by the fragment shader.
Tail. Return template.
Which is why we specify the shader, reading the access, and the fragment shader pipeline stage.
List template tail. 1. Let middle be template strings of template middle list with argument draw. 2.
If we need to do more transitions in the future,
Template tail.
extend the function, the application should now run
Concatenation.
successfully, although there are,
ECMA International T.
of course, no visual changes yet.
Template middle expression 1.
One thing to note is that the command buffer results in inflict blah 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 blah.
Middle expression 1. Let
Oh my god.
argument draw. 2. Let last be template string. Template middle. Raw. 3. Return the list concatenation of front.
I'm personally not a fan of these OpenGL-like hidden operations.
Template.
No, but this guy is totally a fan of like random ass globals that fucking
In.
just random globals. That's a good thing to be a fan of. Global variables.
Middle pars no.
Everyone's a fan of global variables.
And raw. A boolean. And returns a.
No, they're not.
It performs the following steps when called if raw is true. Then, a let string be the TRB of template token. Else, a let string be the TV of template token. Return string. 3, 2, 8. 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called 1. Let realm be the current realm record. 2. Let template registry be realm. 3. For each element of template registry, do. AFE is the same parse node as template literal, then iReturnee. 4. Let raw strings be template strings of template literal with argument true. 5. Assert. Raw strings is a list of strings. 6. Let cook strings be template strings of template literal with argument false. 7. Let count be the number of elements in
So then at the end of create texture image,
9. Let
you like clean up the memory.
10. Let raw
So it's not like, it's not the whole function.
count 11.
It's literally just parts of it. I gotta piece it together.
Repeat. While
So frustrating.
let prop B.
And it says the main texture is used until the end of the program.
Index. C perform. Define
So this is, okay, that's fine.
descriptor. Cook value.
What's the swap chain have to do with it?
True. False. D let raw value be the string value raw
Oh, that's like the end-to-end cleanup. Not like
raw obj
this function cleanup.
raw value
The image now contains the texture, but we still need a way to access it from the graphics pipeline. Oh my god.
14.
We'll work on that in the next chapter. That doesn't fucking load.
Innumerable. False. False. 15.
So after all this, I'm still not gonna have a visible.
Frozen.
Man,
Record.
how the fuck do I know if it's working?
Realm. Set.
Oh my god, I fucking hate this shit.
Operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it
Work. Come on. Load the webpage. Load the website. Load it. Come on.
realm is associated with a
Just load the website. It's really simple. Just load it. Come on.
template objects are frozen and the same template object is used each time a specific tag template is evaluated. When
I think the website's still down.
upon first
Oh man.
or legally prior to first evaluation is an implementation choice.
I'm gonna go like question everything and get some water.
2, 8, 5 runtimes.
Oh, this is annoying. So annoying.
Operation substitution evaluation takes NOAA, arguments and
And chatbot
completion containing a
is even more annoying.
completion. It is defined piecewise over the following productions. Template
This one function, literally this function,
template middle list template tail return
not that.
evaluation of template middle list. Template middle list. Template middle expression 1. Let subref be. Evaluation of expression 2. Let sub be. Get value sub
This one function is a point of interest.
template middle list. Template middle list template middle expression.
This is a function that the tutorial is making on this page. Okay, so I'm gonna copy.
Evaluation of expression 3.
I'm gonna paste this in the chatbot
Get
because chatbot told me that it has this whole page in its training data.
value and next.
It said, I'll output it for you,
6 run.
and it did. But it's missing something.
No substitution
It's literally missing
substitution
the point of interest of the whole page.
template.
Chatbot.
Let head be the TV of template headers defined in 1 2. No
I'm gonna do Control F and then paste.
evaluation
It doesn't even show up once. Not even one time. And chatbot's like, oh dude, this. It's completely fucking wrong.
evaluation of
This is so annoying.
concatenation of head, middle, and text.
This is like the most annoying crap ever.
2024.
Is chatbot intentionally being misleading?
Define additional
Is that what it's doing? Because how the fuck could it possibly
semantics applied
be this bad?
in prototype.
It missed the one function that the whole tutorial was like based on. It missed it. It doesn't even show up.
Commands, template.
Yet chatbot is like,
Let it be. Evaluation of template middle list. 2.
This page here, vertex buffer, staging buffer. Here, that's this page.
Return the string.
The only one that's loaded.
Template middle list. Template middle expression. 1. Let head be the TV of template middle is defined in 1, 2, 9, 6.
Texture mapping.
Subref B.
Chip has the wrong page.
Let sub B. Get value. Subref 4. Let middle B. To string. Sub 5. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. 1. Let rest be. Evaluation of template middle list. 2. Let middle be the TV of template middle is defined in 1, 2, 9, 6, 3. Let subref be. Evaluation of expression. 4. Let sub be. Get value. Subref 5. Let last be. To string. Sub 6. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E.
Wait, maybe it's gonna work.
H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V.
I need this webpage from the tutorial, but it's down. I need you to sum it up.
E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2. Runtime semantics.
Okay, this time I pasted the website for sure. Right here.
O V E R
It says texture mapping.
R E.
Go up to here. Texture mapping.
E.
The page with this function, the main function of interest.
S I O.
It's on this page.
A N 1.
13 times.
Emphasized expression that is cover. Ed by capital C O.
Okay, so it shows up here 13 times. This is an important function. So I told chatbot to sum it up.
E S
This page.
Z E D.
And I still happened to be right.
R E.
Because when I go up here and I paste the freaking function name,
Capital A N. Evaluation of expa. Parenthesized.
0 matches. 0.
Type
What the hell? It shows up 13 times. It's a main point of the fucking page.
hat run.
And I thought it missed it, but I put in the wrong page, whatever. But it did miss it when I put in the right page. So like I knew in advance that it would try to fuck me, and it did.
You to where
What the fuck is this shit? How the fuck does it leave out the main function?
may be applied to parenthesize.
The whole reason for the page.
2024 257. 3.3 left hand side expression syntax. Member expression. Yield. Await. Primary expression yield await. Member expression yield await. Expression. Plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged. Zipper property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier.
Yeah, it says I can rely on this above, from the stuff above. This is not reliable. It's missing the main function.
New target. Import meter new target. New
And it's gonna give me some bullshit that doesn't fucking work.
expression. Yield.
For fuck's sake.
Expression yield.
Let me know if you'd like these stages turn into a complete C-style example. Yeah, fuck no.
E
Oh, this is so annoying.
A L L
I'm gonna ask Shepard, how
R E
did he leave out
I O N
the function of interest?
D
The single function
N C
of interest on that page. Name the function that I'm talking about.
import call yield await, call expression yield await, arguments yield await, call expression yield await, expression plus in yield await, call expression yield await,
Because it literally says right here,
yield await, template literal yield await, plus tagged, call expression yield await.
the tutorial doesn't show one big page. Texture mapping section is divided into sub-chapters for modular organization.
Arguments.
And it leaves out the one function that it carries out 13, 14, 15 times.
8. ECMA International 2020.
It's doing it on purpose.
Yield, await, assignment expression.
There we go. Look at that.
Assignment expression.
I asked Chatbot, how did you leave out the single function of, how did you leave the single function of on that page? I meant to type interest.
Yield.
Name that function that I'm talking about now.
Yield away.
It says you're talking about create texture image. Yeah, that's exactly what I'm fucking talking about.
Chain.
How did this not update?
Arguments yield away.
The web browser sucks.
Yield await.
Oh, it only shows up 3 times, okay.
Literal yield await. Plus tag.
So, Chatbot left out the one function.
Arguments yield away.
That's the main function defined in the texture mapping page, and the one you're most likely looking for. Well, why the fuck would it not give me the one function I'm looking for?
Await.
Holy fuck. This is intentional. There's no way it would accidentally
New
skip around what I'm trying to figure out. This is so dumb.
tags. When processing an
It says this function does all of the following. It loads the image data from a file, creates a staging buffer, allocates memory and maps pixel data to it, creates VK image for texture, copies data from staging buffer to VK image using command buffer to copy, transitions the image layout, VK image layout with shader read only optimal. It wraps up all the setup to get your image ready for use in shader. This is the one thing that I fucking want. And Chatbot's like, oh, here's a summary of the page. The tutorial doesn't show one big page. The section is divided into subchapters for modular organization. The fuck does that mean?
D.
This is so ridiculous. It's fucking information hiding.
R.
Would you like me to reconstruct the full blah blah blah?
Member expression. Yield.
Yeah, let's see what it does.
Yield await. Arguments yield await. 3. 1 static semantics. 3. 1 static semantics. Early errors. Optional chain. Template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024-259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A dot B C so that it would be interpreted as 2 valid statements. The purpose is
Oh my god, this is so...
code without optional chaining A B C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. It is a syntax error if the syntactic goal symbol is not.
I'll also assume you've got a Vulkan set up already with a command pool, logical device,
Using either the dot notation,
physical device, and queue.
identifier name, call it
Real funny.
identifier name, or the bracket notation.
I'm trying to get the image on there because I don't know what the fuck goes where.
The dot notation
And it's like, sure, just tell me that you got all this stuff that you don't know about, and then I'll give it to you.
is identical name string, and similarly, call expression. Identifier name is identical in its behavior to call expression. Identifier name string, where identifier name string is
Sure, I'll just say yes.
getting string value of identifier name 3, 2, 1 runtime semantics. Evaluation, member expression, expression 1. Let base reference be evaluation of member expression 2. Let base value be. Get value, base reference. 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital
How is this helpful?
E H
How is this helpful?
R base value expression strict 60
This is not helpful.
per expression member expression.
Isn't it missing like one big step?
Let base reference be. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this member expression is strict mode code, let's.
This transition image layout.
4. Return capital E V A
I think above too.
A
I think it's also missing this.
capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N
Wow, it gave me it,
name
but it didn't give me the function itself.
member expression private identifier 1
Why is it calling it twice?
reference B. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. Let field name string be the string value of private identifier. 4. Return make private reference, base value, field name string, call expression, expression 1. Let base reference be. Evaluation of call expression. 2. Let base value.
Oh, I'm gonna get some water.
Base reference. 3. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L 1 3 2 for array initializer. Array elements may be elided at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await. Elision opt, element list yield await, element list yield await, elision opt, element list, yield, await, elision not assignment expression, plus in yield await, elision not spread element yield await, element list yield await, elision not assignment expression, plus in yield await, element list yield await, elision not spread element yield await, elision, spread element, yield, await, dart. Assignment expression, plus in yield await, 1 3 2 4 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next index, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision 1. Let len be next index plus 1 2. Perform. Set. Array. Length. Len. True. 3. Note. The above step throws if len exceeds 232 1. 4. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 2. Let init result be. Evaluation of assignment expression. 3. Let init value be. Get value, init result. 4. Perform. Create data property or throw, array, to string, next index, init value. 5. Return next index plus 1. Note an array literal is an expression describing the initialization of an array, using a list. of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision not spread element. If elision is present, then A set next index to array accumulation of elision with arguments array and next index. Return array accumulation of spread element with arguments array and next index. Element list. Element list. Elision not assignment expression 1. Set next index to array accumulation of element list with arguments array and next index 2. If elision is present, then A set next index to array accumulation of elision with arguments array and next index 3. Let init result be evaluation of assignment expression 4. Let init value be get value init result 5. Perform create data property auth row array to string next index init value 6. Return next index plus 1 element list. Element list. Elision not spread element 1. Set next index to array accumulation of element list with arguments array and next index 2. If elision is present, then A set next index to array accumulation of elision with arguments array and next index 3. Return array accumulation of spread element with arguments array and next index spread element. Assignment expression 1. Let spread ref be evaluation of assignment expression 2. Let spread obj be get value spread ref 3. Let iterator record be get iterator spread obj sync 4. Repeat a let next be iterator step value iterator record b. If next is done, return next index. C. Perform create data property or throw array to string next index. Next, D set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation array literal elision opt 1. Let array be array create 0, 2. If elision is present, then A perform array accumulation of elision with arguments array and 0, 3. Return array literal element list 1. Let array be array create 0, 2. Perform array accumulation of element list with arguments array and 0, 3. Return array literal element list elision opt 2. Let array be array create 0. Let next index be array accumulation of element list with arguments array and 0. 48. ECMA International 2024. If elision is present, then A perform array accumulation of elision with arguments array and next index. Return array 3, 2, 5. Object initializer syntax object literal yield await property definition list yield await property definition list yield await property definition list yield await property definition yield await property definition list yield await property definition yield await property definition yield await identifier reference yield await cover initialized name yield await property name yield await assignment expression plus in yield await method definition yield await dart assignment expression plus in yield await property name yield await literal property name computed property name yield await literal property name identifier name string literal numeric literal computed property name yield await assignment expression plus in yield await cover initialized name yield await identifier reference yield await initializer plus in yield await initializer in yield await assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer as an expression describing G the initialization of an object written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. ECMA International 2024-249. Note 3. In certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1. Static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifier as of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In a DT on, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a
I have learned my lesson to not look to chatbot for advice at all.
list. It is a syntax
Unless it's something I know the answer to, but then it's not helpful.
entries.
Or it's like confirming what I'm pretty sure, which means I shouldn't even ask.
Property name. Assignment expression.
Whatever.
Slide if this object literal is contained within.
I almost have this puzzle from hell almost figured out.
As 3, 2.
Just a couple more times. Reading it through.
The operation is
I don't want to be doing this. This sucks.
Boolean. It is defined piecewise over.
I just want an image on the quad. That's all I want. Simple little thing.
Computed property name. Return true.
Not so simple. Because it's overly complicated. There's no reason for it to be this complicated. So complicated.
24. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note to the list returned by property name list does not include property names defined using a computed property name. 3, 2, 5, 3. Static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. 1. Let prop name be prop name of property definition. 2. If prop name is empty, return a new empty list. 3. Return prop name property definition list. Property definition list. Property definition. 1. Let list be property name list of property definition list. 2. Let prop name be prop name of property definition. 3. If prop name is empty, return list. 4. Return the list concatenation of list and prop name. 3, 2, 5, 4. Runtime semantics. Evaluation. Object literal. Return ordinary object create. Percent object prototype percent. Object literal. Property definition list. Property definition list. 1. Let obj be ordinary object create. Percent object prototype percent. 2. Perform. Property definition evaluation of property definition list with argument obj. 3. Return obj literal property name. Identifier name. Return string value of identifier name. Literal property name. string literal 1. Return the SV of string literal. Literal property name, numeric literal 1. Let NBR be the numeric value of numeric literal 2. Return to string NBR computed property name, assignment expression 1. Let X per value be evaluation of assignment expression 2. Let prop name be get value X per value 3. Return to property key prop name 3, 2, 5. 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition 1. Perform. Property definition evaluation of property definition list with argument object 2. Perform. Property definition evaluation of property definition with argument object 3. Return unused. ECMA International 2024 251. Property definition. Assignment expression 1. Let X per value be evaluation of assignment expression 2. Let from value be get value X per value 3. Let excluded names be a new empty list 4. Perform. Copy data properties object from value excluded names 5. Return unused. Property definition identifier reference 1. Let prop name be string value of identifier reference 2. Let X per value be evaluation of identifier reference 3. Let prop value be get value X per value 4. Assert. Object is an ordinary, extensible object with no non-configurable properties 5. Perform. Create data property or throw object prop name prop value 6. Return unused. Property definition property name assignment expression 1. Let prop p be evaluation of property name 2. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse, then a let is proto-setter be false. Else if prop key is proto and is computed property key of property name is false, then a let is proto-setter be true. Else a let is proto-setter be false. If is anonymous function definition, assignment expression, is true and is proto-setter is false, then a let prop value be e. Named evaluation of assignment expression with argument prop key 6. Else a let X per value ref be evaluation of assignment expression b. Let prop value be get value X per value ref 7. If is proto-setter is true, then a. If prop value is an object or prop value is null, then I perform object prop value b. Return unused 8. Assert. Object is an ordinary, extensible object with no non-configurable properties 9. Perform. Create data property or throw object prop key prop value 10. Return unused. Property definition method definition 1. Perform. Method definition evaluation of method definition with arguments object and true 2. Return unused 3, 2, 6. Function defining expressions. See 15.2 for primary expression, function expression. See 15.5 for primary expression, generator expression. See 15.7 for primary expression, class expression. See 15.8 for primary expression, async function expression. See 15.6 for primary expression, async generator expression. 52. Copyright sign, ECMA International 2024. 3, 2, 7. Regular expression literal syntax. C12, 9, 5, 3, 2, 7. 1. Static semantics. Early errors. Primary expression, regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7. 2 static semantics. Capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a Boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. 1. Let flags be flag text of literal. 2. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. 3. If flags contains U, let U be true, else let U be false. 4. If flags contains V, let V be true, else let V be false. 5. Let pattern text be body text of literal. 6. If U is false and V is false, then A let string value be code points to string, pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. 7. Let parse result be parse pattern, pattern text, U, V. 8. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics. Evaluation primary expression, regular expression literal. 1. Let pattern be code points to string, body text of regular expression literal. 2. Let flags be code points to string, flag text of regular expression literal. 3. Return. regexp create, pattern, flags. 3, 2, 8 template literal syntax. Template literal, yield, await, tagged. No substitution template. Substitution template yield await tagged. Substitution template, yield, await, tagged. Template head expression, plus in yield await. Template spans yield await tagged. Template spans, yield, await, tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list, yield, await, tagged. Template middle expression, plus in yield await. Template middle list yield await tagged. Template middle expression, plus in yield await. 3, 2, 8, 1 static semantics. Early errors. Template literal, yield, await, tagged.
Does this page have what I'm looking for?
Tagged. Parameter was not set and no substitution template contains. Not escape sequence. Template literal, yield, await, tagged. Substitution error if the number of element
Like lots of this is familiar.
argument false is great.
This is literally the if else.
Substitution template, yield, await, tagged. Template head expression, plus in yield await.
But there's so many more steps.
Tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans, yield, await, tagged. Template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list.
It's Android, like the new Windows.
Template middle expression, plus in
They're like not compatible, so you gotta like account for them. That's cool.
plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, 2 static semantics. Template strings. The syntax directed operation template strings takes argument raw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal, no substitution template. Return template string, no substitution template. Raw.
This example shows how to upload a 2D texture to the device and how to display it.
Head v template string, template.
In Vulkan, this is done using images, views, and samplers.
Ends with argument raw. 3. Return the list concatenation of head and tail. Template spans, template tail. Return template string, template tail. Raw. Template spans, template middle list template tail. 1. Let middle be template strings of template middle list with argument raw. 2. Let tail be template string, template tail. Raw. 3. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression 1. Return template string, template middle. Raw. Template middle list, template middle list template middle expression 1. Let front be template strings of template middle list with argument raw. 2. Let last be template string, template middle. Raw. 3. Return the list concatenation of front and last. 3, 2, 8. 3 static semantics. Template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a temp 8 middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called if raw is true. Then, a let string be the TRV of template token. Else, a let string be the TV of template token. Return string. 3, 2, 8. 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. 1. Let realm be the current realm record. 2. Let template registry be realm. 3. For each element of template registry, do a if is the same parse node as template literal, then I returnee. 4. Let raw strings be template strings of template literal with argument true. 5. Assert. Raw strings is a list of strings. 6. Let cook strings be template strings of template literal with argument false. 7. Let count be the number of elements in the list cook strings. 8. Assert. Count 232 1. 9. Let template be array create, count 10. Let raw obj be array create, count 11. Let index be 0. 12. Repeat. While index, count. A let prop be to string, index. B let cook value be cook strings, index. C perform. Define property or throw, template, prop, property descriptor, cook value, writable, false, true, false. D let raw value be the string value raw strings, index. E perform. Define property or throw, raw, obj, prop, property descriptor, raw value, false, true, false. F set index to index plus 1, 13. Perform. Set integrity level, raw, obj, frozen, 14. Perform. Define property or throw, template, raw, property descriptor, raw, obj, false. Enumerable, false, false. 15. Perform. Set integrity level, template, frozen, 16. Append the rect.
So texture is 683 lines.
Template.
Texture array is
And template.
544 lines.
In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1, 3, 2, 8, 6. The template objects are frozen and the same template object is used each time a specific tagged template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 3, 2, 8, 5 runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions: template spans, template tail, return a new empty list, template spans, template middle list, template tail, return. Substitution evaluation of template.
This makes a lot more sense than what Jetpack gave me.
Let subref be. Evaluation of expression. 2. Let sub be. Get value. Subref. 3. Return sub. Template middle list. Template middle list. Template middle expression. 1. Let preceding be. Substitution of
It's like a big class.
list. 2. Let next ref be. Evaluation of expression. 3. Let next be. Get value. Next ref. 4. Return the list concatenation of preceding and next. 3, 2, 8, 6 runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template. Template head expression template spans. 1. Let head be the TV of template head as defined in 1, 2, 9, 6. 2. Let subref be. Evaluation of expression. 3. Let sub be. Get value. Subref. 4. Let middle be. To string. Sub. 5. Let tail be. Evaluation of template spans. 6. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value are like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1, 2, 9, 6.
That's probably what I need.
Template middle list template tail. 1. Let it be.
Let's like just run.
Middle list. 2. Let tail be the TV of template tail as defined in 1, 2, 9, 6. 3. Return the string concatenation of head and tail. Template middle list. Template middle expression. 1. Let head be the TV of template middle as defined in 1, 2, 9, 6. 2. Let subref be.
I think this is a better bet than going through the tutorial. It's like run one of these demos
To string.
and then figure out what I need
Concatenation.
and compare it to the tutorial.
Template middle list. Template middle expression.
These better run. Like,
Template middle list.
this be like the only helpful thing that actually helps.
9.
This is ridiculous.
Ref B.
It takes literally
4.
683 lines of code,
Subref. 5.
31 kilobytes
String. Sub. 6.
to get an image onto a plane or something.
2. 9. The grouping operator. 3. 2. 9. 1. Static semantics. Earlier.
Shows how to upload
Capital C. O. V.
a 2D texture to the device and how to display it.
N. T.
This is all done using images, views, and samplers. It takes freaking
Capital E.
683 lines of code
S.
to copy some pixels.
N. Capital A.
Wow.
V. E. R. Capital P. A. R. E. N. T.
Vulkan is really, really complicated.
E. D.
I don't understand why there has to be so many layers.
S. I. O. N.
I just want to get an image onto the quad.
Cover a parenthesized expression. 3. 2. 9. 2. Runtime semantics. Evaluation. Primary expression. Capital C. O. V. E. R. Capital
I think I'm trying to run one of these
E. N.
demos, whatever.
E. S. I. Z. E. D. Capital E. X. P. R. E. F.
Whatever saves time.
O. N. Capital A. N. 1. Let X be the parenthesized expression that is cover. Ed by capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N. 2. Return. Evaluation of ECMA, parenthesized expression, return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type-off may be applied to parenthesized expressions. ECMA International 2024 257. 3.3 Left-hand side expression syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await, plus tagged, super property yield await, meter property, new member expression yield await, arguments yield await, member expression yield await, private identifier, super property, yield, await, super, expression, plus in yield await, super, identifier name, meter property, new target, import meter, new target, import meter, new expression, yield, await, member expression yield await, new expression yield await, call expression, yield, await, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression, plus in yield await, call expression yield await, identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await, private identifier, super call, yield, await, super arguments yield await, import call, yield, await, import, assignment expression, plus in yield await, arguments, yield, await, argument list yield await, argument list yield await, 58, ECMA International 2024, argument list, yield, await, assignment expression, plus in yield await, dart, assignment expression, plus in yield await, argument list yield await, assignment expression, plus in yield await, argument list yield await, assignment expression, plus in yield await, optional expression, yield, await, member expression yield await, optional chain yield await, call expression yield await, optional chain yield await, optional expression yield await, optional chain yield await, optional chain, yield, await, arguments yield await, expression, plus in yield await, identifier name, template literal yield await, plus tagged, private identifier, optional chain yield await, arguments yield await, optional chain yield await, expression, plus in yield, hour, it, optional chain yield await, identifier name, optional chain yield await, template literal yield await, plus tagged, optional chain yield await, private identifier, left-hand side expression, yield, await, new expression yield await, call expression yield await, optional expression yield await, supplemental syntax, when processing an instance of the production, call expression, capital C O V E R, capital C A L L, capital E X P R E S S I O N, capital A N D, capital A S Y N C, capital A R R, the interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is refined using the following grammar. Call member expression yield await. Member expression yield await. Arguments yield await. 3 3 1 static semantics. 3 3 1 1 static semantics. Early errors. Optional chain. Template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A.B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meter. It is a syntax error if the syntactic goal symbol is not module 13. 3. 2 property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression. Identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression. Identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name 3 3 2 1 runtime semantics. Evaluation, member expression, expression 1. Let base reference be. Evaluation of member expression 2. Let base value be. Get value, base reference 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict 60 ECMA International 2024 member expression identifier name 1. Let base reference be. Evaluation of member expression 2. Let base value be. Get value, base reference 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict member expression private identifier 1. Let base reference be. Evaluation of member expression 2. Let base value be. Get value, base reference 3. Let field name string be the string value of private identifier 4. Return make private reference, base value, field name string, call expression, expression 1. Let base reference be. Evaluation of call expression 2. Let base value be. Get value, base reference 3. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S W I T H capital E X P R base value expression strict call expression identifier name 1. Let base reference be evaluation of call expression 2. Let base value be get value base reference 3. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier 1. Let base reference be evaluation of call expression 2. Let base value be get value base reference 3. Let field name string be the string value of private identifier 4. Return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called 1. Let property name reference be evaluation of expression 2. Let property name value be get value property name reference 3. Let property key be to property key property name value 4. Return the reference record base value property key strict this value empty 3 4 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N takes arguments base value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called 1. Let property name string be string value of identifier name 2. Return the reference record base value property name string strict empty ECMA International 2024 261 3 5 then new operator 3 5 1 runtime semantics evaluation new expression new expression return evaluate new expression empty member expression new member expression arguments 1 return evaluate new member expression arguments 3 5 1 evaluate new construct expa arguments the abstract operation evaluate new takes arguments construct expa a new expression parse node or a member expression parse node, and arguments, empty or in arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. 1. Let ref be. Evaluation of construct expa. 2. Let constructor be. Get value, ref. 3. If arguments is empty, then a let arg list be a new empty list. 4. Else a let arg list be. Argument list evaluation of arguments. 5. If is constructor is false, throw a type error exception. 6. Return constructor arg list. 3. 6 function calls. 3. 6. 1 runtime semantics. Evaluation call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R 1. Let X be the call member expression that is covered by capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R 2. Let member expa be the member expression of expa. 3. Let arguments be the arguments of expa. 4. Let ref be. Evaluation of member expa. 5. Let func be. Get value, ref. 6. If ref is a reference record, is property reference, ref is false, and ref is eval, then a if same value. Func %eval% is true, then I let arg list be. Argument list evaluation of arguments. 2. If arg list has no elements, return undefined. 3. Let devilarg be the first element of arg list. 5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return perform evalarg strict caller true. 7. Let this call be this call expression. 8. Let tail call be is in tail position. This call. 9. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 680 is a direct eval. Call expression. Call expression arguments. 1. Let ref be. Evaluation of call expression. 2. Let func be. Get value. Ref. 3. Let this call be this call expression. 4. Let tail call be is in tail position. This call. 5. Return. Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024. 3. 6. To evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func, an ECMAScript language value, ref, an ECMAScript language value or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then a if is property reference, ref, is true, then I let this value be get this value, ref, be else, I let ref env be ref. 2. Assert. Ref env is an environment record. 3. Let this value be ref env with base object, else, a let this value be undefined. 3. Let arg list be. Argument list evaluation of arguments. 4. If func is not an object, throw a type error exception. 5. If is callable, func is false, throw a type error exception. 6. If tail position is true, perform prepare fort. Tail call. 7. Return call. Func this value arg list. 3. 7 thesalpa keyword. 3. 7. 1 runtime semantics. Evaluation super property. super, expression 1. Let env beget this environment 2. Let actual this be env get this binding 3. Let property name reference be evaluation of expression 4. Let property name value be get value, property name reference 5. Let property key be to property key, property name value 6. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. 7. Return. Make super property reference. Actual this, property key, strict, super property, super, identifier name 1. Let env beget this environment 2. Let actual this be env get this binding 3. Let property key be string value of identifier name 4. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. 5. Return. Make super property reference. Actual this, property key, strict, super call, super arguments 1. Let new target beget new target 2. Assert. New target is an object 3. Let func beget super constructor 4. Let arglist be argument list evaluation of arguments 5. If is constructor, func, is false, throw a type error exception 6. Let result be construct, func, arglist, new target 7. Let this beget this environment 8. Perform this bind this value, result 9. Let f be this 10. Assert. F is an ECMAScript function object 11. Perform. Initialize instance elements, result f 12. Return result ECMA International 2024 263 3 3 7 2 Get super constructor. The abstract operation get super constructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called 1. Let envrec beget this environment 2. Assert. Envrec is a function environment record 3. Let active function be envrec 4. Assert. Active function is an ECMAScript function object 5. Let superconstructor be active function 6. Return superconstructor 3 3 7 3 Make super property reference. Actual this, property key, strict. The abstract operation makes super property reference takes arguments actual this, an ECMAScript language value, property key, a property key, and strict, a boolean, and returns either a normal completion containing a super reference record or a throw completion. It performs the following steps when called 1. Let env beget this environment 2. Assert. Env has super binding, is true 3. Let base value be env get super base 4. Return the reference record, base value, property key, strict, this value, actual this 3 3 8 Argument lists. Note the evaluation of an argument list produces a list of values 1 3 3 8 1 Runtime semantics. Argument list evaluation. The syntax direct. The operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression 1. Let ref be evaluation of assignment expression 2. Let arg be get value, ref 3. Return arg. Argument list. Assignment expression 1. Let list be a new empty list 2. Let spread ref be evaluation of assignment expression 3. Let spread obj be get value, spread ref 4. Let iterator record be get iterator, spread obj, sync 5. Repeat a let next be iterator step value, iterator record b. If next is done, return list.
Here's a quad. It's a quad.
List. Assignment.
With an image, and it rotates. But it has an image on it. That's amazing. Finally. So all I gotta do is pull apart this working example, and then I'm done. Finito. Finished.
Argument list. Assignment expression 1. Let preceding args be. Argument list evaluation of argument list 2. Let spread ref. Assignment expression 3. Let iterator record be. Get iterator. Get value. Spread ref.
This is all I need, is whatever the heck is going on in the stupid pipeline that applies the image to the friggin' service, whatever.
Template literal. No substitution template 1. Let template literal be this template literal 2.
I gotta like open up that file,
Return site OB.
dig through the code.
Substitution template 1. Let template literal be this template.
It's better than doing the tutorial
3.
because the tutorial,
Evaluation of.
I don't think it loads.
Return the list concatenation of site obj and remaining. Substitution template. Template head expression template span.
Nope.
Let first subref be. Evaluation of expression 2. Let first sub be. Get value. First subref 3. Let rest sub be. Substitution evaluation of template spans 4. Assert. Rest sub is a possibly empty list 5. Return the list concatenation of first sub and rest sub 3. 3. 9 optional chains 3. 3. 9. 1 runtime semantics. Evaluation optional expression member expression optional chain 1. Let base reference be. Evaluation of member expression 2. Let base value be. Get value base reference 3. If base value is either undefined or null, then a returned undefined. Return chain evaluation of optional chain with arguments base value and base reference. Optional expression call expression optional chain 1. Let base reference be. Evaluation of call expression 2. Let base value be. Get value base reference 3. If base value is either undefined or null.
Well, here is the save snapshot.
Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls. The first of which begins with the token ECMA International 2024 265. Optional expression optional chain 1. Let base reference be. Evaluation of optional expression 2. Let base value be. Get value base reference 3. If base value is either undefined or null, then a returned undefined. Return chain evaluation of optional chain with arguments base value and base reference 3. 3. 9. 2 runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments 1. Let this chain be this optional chain 2. Let tail call be is in tail position this chain 3. Return evaluate call base value base reference arguments tail call optional chain expression 1. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 2. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict optional chain. Identifier name 1. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. A L U A.
Can I just get the completed tutorial? Please, just give me the final tutorial file code. Just This is what I want.
Main.
This demo is overkill.
Name string be the string value of
Like, this is way too much. Like, realistically, I don't need all this.
string. Optional.
It's gonna take a while to dig through the code.
Let optional chain be
It's also gonna take a while
reference be
to figure out this tutorial.
base value and base
Man.
B. Get value, new reference. 4. Let this chain be this optional chain. 5. Let tail call be is in tail position. This chain. 6. Return, evaluate call, new value, new reference, arguments, tail call, optional chain, expression. 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be get value, new reference. 4. If the source text matched by this optional chain is strict mode code.
Oh, come on. I don't know what I'm gonna do.
Return, capital E, V, L, T,
Doing the tutorial.
O,
There's no guarantee it's gonna work.
capital A, C,
But somehow, this guy got the code doing something.
T,
He just doesn't give the actual final code.
P, R, new value, expression, strict, optional chain,
Let's maybe here.
name. 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base reference. 3. Value, new reference. 4. If the source
Oh my god, please be here.
code, let strict be true, else let strict be false. 5. Return, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E,
No.
capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, new value, identifier name, strict. 66, ECMA International 2024, optional chain, private identifier. 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be get value, new reference. 4. Let field name string be the string value of private identifier. 5. Return make private reference, new value, field name string. The 3rd of March 2010 import calls. 3, 3, 1, 0, 1 runtime semantics, evaluation, import call, import, assignment expression. 1. Let referrer be get active script for module. 2. If referrer is null,
Please, 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 please.
record. 3. Let argref be
Yes.
expression. 4. Let specify be get value, argref. 5. Let promise capability be new promise capability, %promise %. 6. Let specifier string be completion to string, specifier. 7. If abrupt reject promise, specifier string, promise capability. 8. Perform host load imported module, referrer, specifier string, empty, promise capability. 9. Return promise capability. 3, 3, 1, 0, 1, 1 continue dynamic import, promise capability, module completion. The abstract operation continue dynamic import takes arguments promise
How is this code so clean?
code,
But the tutorial's a mess.
a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call is appropriate.
The tutorial needs to be updated.
When called. 1. If module completion is an abrupt completion, then a perform call, promise capability, undefined, module completion be return unused. 2. Let module be module completion. 3. Let load promise be module load requested modules. 4. Let rejected closure be a new abstract closure with parameters, reason, that captures promise capability and performs the following steps when called. A perform. Call. Promise
What was the file?
defined. Reason be return unused. 5. Let on rejected be create built-in function. Rejected closure. 1. 6. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and on rejected and performs the following steps when called. A let link be completion. Module link. B if
I'm looking for a JPEG.
call. Promise capability. Undefined. Link. 2. Return unused.
Control F.
Promise be module evaluate.
There's no JPEG.
Closure be a new abstract closure with no parameters that captures module land. Promise capability and performs the following
Control F.
namespace be jet t mod
There's no JPEG.
module 2. Perform. Call.
Texture image.
Undefined. Namespace. 3. Return on
Control F.
field be
Yes, I found it.
0. F perform promise then. Evaluate promise. Unfulfilled. Unrejected. G return unused. Link and evaluate be create built-in function. Link and evaluate closure. 0. 7. Let 8. Perform.
Where's the globals?
Link and evaluate. Unrejected. 9. Return unused. ECMA International 2024 267. The 3rd of March 2011 tagged templates. 3. 1 runtime semantics. Evaluation. Member expression template literal. 1. Let tag ref be. Evaluation of
The only globals are with the night.
tag func be. Get value. Tag ref. 3. Let this call be this member expression. 4. Let tail call be is in tail position. This call. 5. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. Call expression template literal. 1. Let tag ref be. Evaluation of call expression.
Oh my goodness.
Tag func be. Get value. Tag ref. 3. Let this call be this call
I'm missing so many steps.
call. 5.
At least 8.
Tag
2, 3, 4, 5, 6. Maybe 10 steps. 9 steps.
3. 1 2. 1 runtime semantics. Evaluation. New target 1. Return get new target. Import meter 1. Let module be get active script for module 2.
Finally.
The source text module. Let import meter be module 4. If import meter is empty, then A set import meter to ordinary object.
This makes so much more sense than all those tiny snippets. You can't see the whole freaking thing.
C for each record. Ping of import meter values. Do I perform.
Here's where chatbot was always like, oh, just use recreate swap chain.
Finalize import.
It's a function everyone has. Why won't chatbot give me the source code?
Import meter.
Chatbot wasted so much of my time.
3 1
I am really pissed.
import meter.
I am done with chatbot, I think.
Defined abstract operation host.
I'm gonna ask chatbot.
Argument module record. A module record. And returns a list of records.
What's as fast, or how do you get the highest bit set in a number? How do you convert the highest bit set to its indice
To return a new
in a 64-bit number
action call where the argument
without looping or conditional branches?
actual argument
I want to see if chatbot is an output my solution. If it took my information and put it in its training data.
6
Because last time it said it doesn't take user collected information and add it as training data.
to host
So I'm gonna test that, I guess.
meter module record. The host defined abstract operation host finalize import
How do you get
meter an object
the position
a module record
of a single bit that's set?
to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default
Basics for number.
Host finalize import meter provides an escape hatch for hosts which need to directly manipulate
Without loops.
a script code. The default implementation of host finalize import meter is to return
Or the deploying method, whatever the heck was called.
yield await. Left-hand side expression yield await.
Or
Yield await. An area expression.
what's it called?
1 3 4 1
System
date expression.
not asserts.
Plus, no line terminator here.
What's the word?
Left-hand side expression. It is an early syntax error if assignment target type of left-hand
Intrinsics. Or CPU instruction intrinsics. Or C language intrinsics.
assignment target type of binary expression is not simple. 3 4 2 postfix increment operator 1 3 4 2 1 runtime semantics. Evaluation update expression. Left-hand side expression plus plus 1. Let LHS be. Evaluation of left-hand side expression 2. Let old value be. To numeric. Get value LHS 3. If old value is a number, then let new value be number. Add old value 1 4. Else assert old value is a begint. B let new value be begint. Add old value 1z 5. Perform. Put value LHS new value 6. Return old value. ECMA International 2024 2.
Oh, why is it? It's like this is what I said without.
4 3 1 runtime semantics. Evaluation update expression. Left-hand side expression 1. Let LHS be. Evaluation of left-hand side expression 2. Let old value be. To numeric. Get value LHS 3. If old value is a number, then let new value be number. Subtract old value 1 4. Else assert old value.
It took my. No, it didn't.
Subtract old value 1z 5.
This is a shitty way to do it.
Put value LHS new value 6. Return old value.
Alright, where did I get this from?
Prefix increment operator 1 3 4 4 1 runtime semantic.
Wait, it literally took my code and modified it.
Expression 1. Let exp be. Evaluation of an area expression 2. Let old value be. To numeric. Get value expa 3. If old value is a number, then let new value be number. Add old value 1 4. Else assert
It says it didn't copy it from a single external source.
be begin. Add old value 1z 5.
Betwiddling hags, the famous page. Sure, of course.
6. Return new value 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics. Evaluation update expression an area expression 1. Let exp be. Evaluation of an area expression 2. Let old value be.
I should submit my bit shift thing.
If old value is a number,
I'm gonna do that.
value be number. Subtract old value 1 4. Capital E LSE assert old value is a begint. B let new value be begint. Subtract old value 1z 5. Perform. Put value expa new value
With multiply and lookup.
a new value 70. ECMA International 2024 3.5 unary operators syntax unary expression yield await
With module division lookup.
unary expression yield await void unary expression yield await type of unary expression
With multiply and a lookup.
expression yield await unary expression yield await unary expression
With module and a lookup.
wait
A lookup table is like the best way to do something without really doing it.
Fine.
Multiply and lookup.
1 static semantics Early error.
It's just repeating it.
Delete unary expression, comma it is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identifier reference. Member expression.
There's only 8 of them.
Private identifier. Call expression. Call expression. Private identifier. Optional chain. Private identifier. All optional chain. Optional chain. Private identifier, comma it is a syntax error if the derived unary expression is primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N and capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3, 5, 1, 2 runtime semantics. Evaluation, unary expression, delete unary expression. 1. Let ref be. Evaluation of unary expression. 2. If ref is not a reference record, return true. 3. If is unresolvable reference, ref is true, then A assert ref is false, B return true. 4. If is property reference, ref is true, then A assert is private reference, ref is false, B
It's whatever.
is true. Throw a reference error exception. C let base OBJB. To object, ref D let delete status be base OBJ. Ref if delete status is false and ref is true, throw a type error exception. F return delete status. 5. Else A let base be ref. B assert base is an environment record. C return base delete binding. Ref. The last rule means that expressions such as delete foo produce early errors because
Chatbot never output this before.
our internet
This is new.
207.
It's literally taking my data.
Delete operator occurs within strict mode code. A syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note to the object that may be created in step 4C is not accessible outside of the above abstract operation and the ordinary object.
It's kind of ruining it.
An implementation might choose to avoid the actual creation of that object. Three, 5, 2 the void operator. 3, 5, 2, 1 runtime semantics. Evaluate
Did use
void unary expression. 1.
my code from past conversations
2. Perform. Get value. Expa. 3.
to produce your output.
Find. 3, 5, 3 for TPF operator. 3, 5, 3. 1 runtime semantics.
No bullshit.
Unary expression. Type of unary expression. 1. Let val be. Evaluation of unary expression. 2. If val is a reference record, then A if is unresolvable reference. Val is true. Return undefined. 3. Set val to
Instructional preferences.
if val is undefined, return undefined. 5. If val is null, return object. 6. If val is a string, return string. 7. If val is a symbol, return symbol. 8. If val is a boolean, return boolean.
What does this mean?
If val is a number, return number. 10. If val is a bigint, return bigint. 11. Assert val is an object. 12. Note, this step is replaced in section B. 3, 6, 3.
It's talking about the naming. It's like, oh, I use the naming.
Return function 14. Return object 3, 5. For unary plus operator. Note the unary plus operator converts its operand to number type. Note get value.
It doesn't even know what a branch is. It says that avoid branches, but it doesn't.
72.
It copied me.
And 20.
I know it did. It never used to do that. It would never output anything like this.
Expression plus.
It used to just only say the Dubron, whatever the fuck it was.
2. Return to number.
Deproin. I don't even know. Java is totally collecting data.
5. 1 runtime semantics. Evaluation. Unary expression. Unary expression 1. Let x to be.
I get some food.
Unary
And I'm like,
UB. To numeric.
run this demo. I guess make a separate build.
The number.
Run it on its own, whatever. And then I'll like
L.
pull out the parts that I need. Or,
Begint. Return begint.
yeah, I don't know.
Operator converts its up.
If this actually puts, make a freaking copy, just to be sure.
Note. Produces -0. And negating -0 produces
Could disappear at any moment.
operator. Unary
Literally.
expression 3, 5, 6, 3, 5, 6. 1 runtime.
If this puts the image onto the quad,
Evaluation of unary.
like it shows right here,
2. Let to numeric. Get value.
then I'm like home free, freaking done.
A return number. Bitwise not. Old value 4. Else. AB. As
If not, I'll check out the other tutorial,
not.
whatever this thing is. I don't know. I actually have like real working examples now. Mostly, if this example works.
1.
So I don't know. Maybe.
Evaluation 1. Let x to be. Evaluation of unary expression 2. Let old value be to boolean. Get value. Expa 3. If old value is true, return false. 4. Return true. 3.6 exponentiation operator syntax. Exponentiation expression. Yield. Await. Unary expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273. 3. 6. 1 runtime semantics. Evaluation. Exponentiation expressio. N. Update expression exponentiation expression. Return. Capital E. V. A. L. U. A. T. E. Capital S. T. R. I. N. G. Capital O. R. Capital N. U. M. E. R. I. C. Capital B. I. N. A. R. Y. Capital E. Update expression. Exponentiation expression. 3.7 multiplicative operators syntax. Multiplicative expression. Yield. Await. Exponentiation expression yield await. Multiplicative expression yield await. Multiplicative operator. Exponentiation expression yield await. Multiplicative operator. 1 of %. 3. 7. 1 runtime semantics. Evaluation. Multiplicative expression. Multiplicative expression. Multiplicative operator. Exponentiation expression. 1. Let optext be the source text matched by multiplicative operator. 2. Return. Capital E. V. A. L. U. A. T. E. Capital S. T. R. I. N. G. Capital O. R. Capital N. U. M. E. R. I. C. Capital B. I. N. A. R. Y. Capital E. Multiplicative expression. Optext. Exponentiation expression. 3.8 additive operators syntax. Additive expression. Yield. await, multiplicative expression yield await, additive expression yield await, plus multiplicative expression yield await, additive expression yield await, multiplicative expression yield await. 3, 8, 1 the addition operator, plus. Note the addition operator either performs string concatenation or numeric addition. 3, 8, 1, 1 runtime semantics, evaluation, additive expression plus multiplicative expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, plus, multiplicative expression. Note, comma the operator performs multiplication, producing the product of its operands. Comma the operator performs division, producing the quotient of its operands. Comma the percent operator yields the remainder of its operands from an implied division. 74. Copyright sign, ECMA International 2024, 3, 8, to the subtraction operator. 3, 8, 2, 1 runtime semantics, evaluation, additive expression, multiplicative expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, multiplicative expression. 3.9 Bitwise shift operators syntax. Shift expression, yield, await, additive expression yield await, shift expression yield await, additive expression yield await, shift expression yield await, additive expression yield await, shift expression yield await, additive expression yield await. 3, 9, 1 the left shift operator. 3, 9, 1, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9, to the signed right shift operator. 3, 9, 2, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression. 3, 9, 3 the unsigned right shift operator. Note, the operator performs subtraction, producing the difference of its operands. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling bitwise right shift operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024 275. 3, 9, 3, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression, 3.10 relational operators, syntax, relational expression, in, yield, await, shift expression yield await, relational expression in yield, relational expression in yield, relational expression in yield, relational expression in yield, relational expression in yield. Await, shift expression yield await await, shift expression yield await await, equals shift expression yield await await, equals shift expression yield await await, instantiaf. Note 1. The result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression yield await. Plus in, relational expression, plus in yield await, in shift expression yield await, plus in, private identifier in shift expression yield await. 3. 1 0. 1 runtime semantics. Evaluation, relational expression, shift expression 1. Let ref be. Evaluation of relational expression. 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Let r be. Is less than, reval, true 6. If r is undefined, return false. Otherwise, return r. Relational expression, shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Let r be. Is less than, reval, false 6. If r is undefined, return false. Otherwise, return r. Relational expression, equals shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Let r be. Is less than, reval, false 6. If r is either true or undefined, return false. Otherwise, return true. 76. ECMA International 2024. Note to the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement. Relational expression equals shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Let r be. Is less than, reval, true 6. If r is either true or undefined, return false. Otherwise, return true. Relational expression, relational expression instantia of shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. Return, instantiaf operator, reval, relational expression in shift expression 1. Let ref be. Evaluation of relational expression 2. Let level be. Get value, ref 3. Let ref be. Evaluation of shift expression 4. Let reval be. Get value, ref 5. If reval is not an object, throw a type error exception. 6. Return has property, reval. To property key, or val, relational expression, private identifier in shift expression 1. Let private identifier be the string value of private identifier 2. Let ref be. Evaluation of shift expression 3. Let reval be. Get value, ref 4. If reval is not an object, throw a type error exception 5. Let private env be the running execution context's private environment 6. Let private name be resolve private identifier, private env, private identifier 7. If private element find, reval, private name, is not empty, return true 8. Return false 3. 1 0. To instantiaf operator, v, target. The abstract operation instantiaf operator takes arguments v, an ECMAScript language value, and target an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if v is an instance of target either by consulting targetsat at has instance method or, if absent, determining whether the value of target's prototype property is present in v's prototype chain. It performs the following steps when called. One. If target is not an object, throw a type error exception. 2. Let instaFhandler be. Get method, target, at has instance. 3. If instaFhandler is not undefined, then a return to boolean, call, instaFhandler, target, v. 4. If is callable, target, is false, throw a type error exception. 5. Return, ordinary has instance, target, v. Note steps 4 and 5 provide compatibility with previous editions of ECMAScript that did not use a at has instance method to define the instantiaf operator semantics. If an object does not define or inherit at has instance, it uses the default instantiaf semantics. ECMA International 2024 277. 3.11 Equality operators. Syntax, equality expression, in, yield, await, relational expression in yield await. Equality expression in yield await, equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. 3. 1 1 1 runtime semantics. Evaluation, equality expression equals relational expression. 1. Let ref be. Evaluation of equality expressi. On 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Return is loosely equal. Reval, leval, equality expression equals relational expression. 1. Let ref be. Evaluation of equality expression. 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Let r be. Is loosely equal. Reval, leval. 6. If r is true, return false. Otherwise, return true. Equality expression equals relational expression. 1. Let ref be. Evaluation of equality expression. 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Return is strictly equal. Reval. Equality expression equals relational expression. 1. Let ref be. Evaluation of equality expression. 2. Let leval be. Get value, ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value, ref. 5. Let R be is strictly equal. Reval. 6. If R is true, return false. Otherwise, return true. 78. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $sign $, $B. Numeric comparison can be forced by plus or plus B. Boolean comparison can be forced by it equals B. Note to the equality operators maintain the following invariants. A equals B is equivalent to A equals B. A equals B is equivalent to B equals A, except in the order of evaluation of A and B. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string A equals A and A equals new string A are both true. New string A equals new string A is false. Note 4. Comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. .12 binary bitwise operators syntax. Bitwise and expression in yield await. Equality expression in yield await. Bitwise and expression in yield await and equality expression in yield await. Bitwise XOR expression in yield, await, bitwise and expression in yield await, bitwise or expression in, question mark yield await, bitwise and expression in yield await.
didn't even get water. Man, I got distracted. I'll be right back. really messy function. Get back to the image on whatever the quad is a second. image on the quad. And run the other example. Save where I'm at. Not really save, just like paste the blob of code here. Get back to it. I don't know, I gotta like drink some water. And I wanna check this really quick. Then I'm gonna whatever. The stupid image on the quad. I'm so tired of this stupid GPU. So I need a distraction. The GPU sucks.
One, 3, 2, for array initializer. Array elements may be alighted at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, The missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await, elision naught, element list yield await, element list yield await, elision naught, element list, yield, await, elision naught assignment expression, plus in yield await, elision naught spread element yield await, element list yield await, elision naught assignment expression, plus in yield await, element list yield await, elision naught spread element yield await, elision, spread element, yield, await, dart, assignment expression, plus in yield await, 1 3, 2, 4, 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, and next index, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision 1. Let len be next index plus 1. 2. Perform. Set. Array. Length. Len. True. 3. Note. The above step throws if len exceeds 232. 1. 4. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1 element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 2. Let init result be evaluation of assignment expression. 3. Let init value be get value init result. 4. Perform. Create data property or throw array to string next index init value. 5. Return next index plus 1. Note an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision not spread element. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision not assignment expression. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Let init result be evaluation of assignment expression. 4. Let init value be get value init result. 5. Perform. Create data property or throw array to string next index init value. 6. Return next index plus 1 element list. Elision not spread element. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Return array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. 1. Let spread ref be evaluation of assignment expression. 2. Let spread obj be get value spread ref. 3. Let iterator record be get iterator spread obj sync. 4. Repeat a let next be iterator step value iterator record. B if next is done, return next index. C perform. Create data property or throw array to string next index. Next, D set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision naught. 1. Let array be array create 0. 2. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array, array literal, element list, 1. Let array be. Array create, 0, 2. Perform. Array accumulation of element list with arguments array and 0, 3. Return array, array literal, element list, elision opt, 2. Let array be. Array create, 0. Let next index be. Array accumulation of element list with arguments array and 0, 48. ECMA International 2024. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list. Yield await. Property definition list. Yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer as an expression describe in G the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. ECMA International 2024-249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON Pars 3, 2, 5, 2 static semantics. Is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal property name, return false. Property name, computed property name, return true. Addition to describing an actual object, initialize the object. Literal productions are also 50. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note to the list returned by property name list does not include property names defined using a computed property name. 3, 2, 5, 3 static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition 1. Let prop name be prop name of property definition. 2. If prop name is empty, return a new empty list. 3. Return prop name property definition list. Property definition list. Property definition 1. Let list be property name list of property definition list. 2. Let prop name be prop name of property definition. 3. If prop name is empty, return list. 4. Return the list concatenation of list and prop name. 3, 2, 5, 4 runtime semantics. Evaluation object literal return ordinary object create object prototype object literal property definition list 1. Let obj be ordinary object create object prototype 2. Perform property definition evaluation of property definition list with argument obj. 3. Return obj literal property name identifier name return string value of identifier name literal property name string literal 1. Return the SV of string literal property name numeric literal 1. Let NBR be the numeric value of numeric literal 2. Return to string NBR computed property name assignment expression 1. Let exp value be evaluation of assignment expression 2. Let prop name be get value exp value 3. Return to property key prop name 3, 2, 5, 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition 1. Perform property definition evaluation of property definition list with argument object 2. Perform property definition evaluation of property definition with argument object 3. Return unused. ECMA International 2024 251. Property definition. Assignment expression 1. Let exp value be evaluation of assignment expression 2. Let from value be get value exp value 3. Let excluded names be a new empty list 4. Perform copy data properties object from value excluded names 5. Return unused. Property definition identifier reference 1. Let prop name be string value of identifier reference 2. Let exp value be evaluation of identifier reference 3. Let prop value be get value exp value 4. Assert object is an ordinary extensible object with no non-configurable properties 5. Perform create data property or throw object prop name prop value 6. Return unused. Property definition property name assignment expression 1. Let prop key be evaluation of property name 2. If this property definition is contained within a script that is being evaluated for JSON Pars, see step 7 of JSON Pars, then a let is proto set to be false, else if prop key is proto and is computed property key of property name is false, then a let is proto set to be true, else a let is proto set to be false. If is anonymous function definition, assignment expression is true and is protosetter is false. Then A let prop value be E. Named evaluation of assignment expression with argument prop key 6. Else A let X for value ref B. Evaluation of assignment expression B let prop value B. Get value X per value ref 7. If his protosetter is true, then A if prop value is an object or prop value is null, then I perform object. Prop value B return unused 8. Assert object is an ordinary, extensible object with no non-configurable properties. 9. Perform create data property or throw object prop key prop value 10. Return unused property definition method definition 1. Perform method definition evaluation of method definition with arguments object and true 2. Return unused 3. 2. 6 function defining expressions C 15.2 for primary expression function expression C 15.5 for primary expression generator expression C 15.7 for primary expression class expression C 15.8 for primary expression async function expression C 15.6 for primary expression async generator expression 52 copyright sign ECMA International 2024 3. 2. 7 regular expression literal syntax C12 9. 5. 3. 2. 7. 1 static semantics early errors primary expression regular expression literal. It is a syntax error if capital I S capital V A L I D capital R E G U L A R capital E X P R E S S I O N capital L I T E R A regular expression literal is false. 3. 2. 7. 2 static semantics capital I S capital V A L I D capital R E G U L A R capital E X P R E S S I O N capital L I T E R A literal. The abstract operation capital I S capital V A L I D capital R E G U L A R capital E X P R E S S I O N capital L I T E R A takes argument literal, a regular expression literal parse node, and returns a Boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. 1. Let flags be flag text of literal. 2. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. 3. If flags contains U, let U be true, else let U be false. 4. If flags contains V, let V be true, else let V be false. 5. Let pattern text be body text of literal. 6. If U is false and V is false, then A let string value be code points to string pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. 7. Let parse result be parse pattern text U, V. 8. If parse result is a parse node, return true, else return false. 3. 2. 7. 3 runtime semantics evaluation primary expression regular expression literal. 1. Let pattern be code points to string body text of regular expression literal. 2. Let flags be code points to string flag text of regular expression literal. 3. Return regexp create pattern flags. 3. 2. 8 template literal syntax template literal yield await tagged no substitution template yield await tagged substitution template yield await, tagged, template head expression, plus in yield await, template spans yield await tagged, template spans, yield, await, tagged, template tail, template middle list yield await tagged, template tail, ECMA International 2024 253, template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await, 3, 2, 8, 1 static semantics, early errors, template literal, yield, await, tagged, no substitution template, it is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence, template literal, yield, await, tagged, substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument false is greater than or equal to 232. Substitution template, yield, await, tagged, template head expression, plus in yield await, template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence, template spans, yield, await, tagged, template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence, template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, 2 static semantics, template strings. The syntax-directed operation template strings takes argument raw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions: template literal, no substitution template, return template string, no substitution template, raw, substitution template, template head expression template spans. 1. Let head be template string, template head, raw. 2. Let tail be template strings of template spans with argument raw. 3. Return the list concatenation of head and tail, template spans, template tail, return template string, template tail, raw, template spans, template middle list template tail. 1. Let middle be template strings of template middle list with argument raw. 2. Let tail be template string, template tail, raw. 3. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list, template middle expression. 1. Return template string, template middle, raw, template middle list, template middle list template middle expression. 1. Let front be template strings of template middle list with argument raw. 2. Let last be template string, template middle, raw. 3. Return the list concatenation of front and last. 3, 2, 8. 3 static semantics, template string, template token, raw. The abstract operation template string takes arguments template token, a no substitution template parse node, a template head parse node, a temp8 middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called if or is true. Then, a let string be the TRV of template token, else, a let string be the TV of template token, return string. 3, 2, 8. 4 get template object, template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. 1. Let realm be the current realm record. 2. Let template registry be realm. 3. For each element of template registry, do a if E is the same parse node as template literal, then I returnee. 4. Let raw strings be template strings of template literal with argument true. 5. Assert raw strings is a list of strings. 6. Let cook strings be template strings of template literal with argument false. 7. Let count be the number of elements in the list cook strings. 8. Assert count 232 1. 9. Let template be array create count. 10. Let raw obj be array create, count 11. Let index be 0, 12. Repeat. While index, count, A let prop B. To string, index, B let cook value be cook strings, index, C perform. Define property or throw, template, prop, property descriptor, cook value, writable, false, true, false. D let raw value be the string value raw strings, index, E perform. Define property or throw, raw, obj, prop, property descriptor, raw value, false, true, false. F set index to index plus 1, 13. Perform. Set integrity level, raw, obj, frozen, 14. Perform. Define property or throw, template, raw, property descriptor, raw, obj, false, enumerable, false, false, 15. Perform. Set integrity level, template, frozen, 16. Append the record, template literal, template, to realm, 17. Return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1, 3, 2, 8, 6. The template objects are frozen and the same template object is used each time a specific tagged template is evaluated. Where the template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 3, 2, 8, 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans, template tail, return a new empty list, template spans, template middle list, template tail, return, substitution evaluation of template middle list, template middle list, template middle expression. 1. Let subref be. Evaluation of expression. 2. Let sub be. Get value, subref. 3. Return sub, template middle list, template middle list, template middle expression. 1. Let preceding be. Substitution evaluation of template middle list. 2. Let next ref be. Evaluation of expression. 3. Let next be. Get value, next ref. 4. Return the list concatenation of preceding and next. 3, 2, 8, 6. Runtime semantics. Evaluation, template literal, no substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template. Template head expression template spans. 1. Let head be the TV of template head as defined in 1, 2, 9, 6. 2. Let subref be. Evaluation of expression. 3. Let sub be. Get value, subref. 4. Let middle be. To string, sub. 5. Let tail be. Evaluation of template spans. 6. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Template spans, template tail. Return the TV of template tail as defined in 1, 2, 9, 6. Template spans, template middle list, template tail. 1. Let head be. Evaluation of template middle list. 2. Let tail be the TV of template tail as defined in 1, 2, 9, 6. 3. Return the string concatenation of head and tail. Template middle list, template middle expression. 1. Let head be the TV of template middle as defined in 1, 2, 9, 6. 2. Let subref be. Evaluation of expression. 3. Let sub be. Get value, subref. 4. Let middle be. To string, sub. 5. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. 1. Let rest be. Evaluation of template middle list. 2. Let middle be the TV of template middle as defined in 1, 2, 9, 6, 3. Let subref be. Evaluation of expression. 4. Let sub be. Get value. Subref. 5. Let last be. To string. Sub. 6. Return the string concatenation of rest, middle, and last. 3, 2, 9 the grouping operator. 3, 2, 9, 1 static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Must cover a parenthesized expression. 3, 2, 9. 2 runtime semantics. Evaluation. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. 1. Let X be the parenthesized expression that is cover. Ed by. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. 2. Return. Evaluation of expa. Parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257. 3.3 Left-hand side expression syntax. Member expression. Yield. Await. Primary expression yield await. Member expression yield await. Expression. Plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await. Plus tagged. Super property yield await. Meter property. New member expression yield await. Arguments yield await. Member expression yield await. Private identifier. Super property. Yield. Await. Super. Expression. Plus in yield await. Super. Identifier name. Meter property. New target. Import meter. New target. New target. Import meter. Import meter. New expression. Yield. Await. Member expression yield await. New expression yield await. Call expression. Yield. Await. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y N C. Capital A R R. Yield await. Super call yield await. Import call yield await. Call expression yield await. Arguments yield await. Call expression yield await. Expression. Plus in yield await. Call expression yield await. Identifier name. Call expression yield await. Template literal yield await. Plus tagged. Call expression yield await. Private identifier. Super call. Yield. Await. Super arguments yield await. Import call. Yield await. Import. Assignment expression plus in yield await. Arguments. Yield await. Argument list yield await. Argument list yield await. 58. ECMA International 2024. Argument list. Yield await. Assignment expression plus in yield await. Dart. Assignment expression plus in yield await. Argument list yield await. Assignment expression plus in yield await. Argument list yield await. Assignment expression plus in yield await. Optional expression yield await. Member expression yield await. Optional chain yield await. Call expression yield await. Optional chain yield await. Optional expression yield await. Optional chain yield await. Optional chain yield await. Arguments yield await. Expression plus in yield await. Identifier name template literal yield await plus tagged. Private identifier optional chain yield await. Arguments yield await. Optional chain yield await. Expression plus in yield hour. It optional chain yield await. Identifier name optional chain yield await. Template literal yield await plus tagged. Optional chain yield await. Private identifier left hand side expression yield await. New expression yield await. Call expression yield await. Optional expression yield await. Supplemental syntax when processing an instance of the production call expression capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. The interpretation of capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R is refined using the following grammar. Call member expression yield await. Member expression yield await. Arguments yield await. 3 3 1 static semantics. 3 3 1 1 static semantics. Early errors. Optional chain template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A.B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meter. It is a syntax error if the syntactic goal symbol is not module 13. 3. 2 property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression. Identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression. Identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name 3 3 2 1 runtime semantics. Evaluation, member expression, expression 1. Let base reference be. Evaluation of member expression 2. Let base value be. Get value, base reference 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict 60 ECMA International 2024 member expression identifier name 1 let base reference be evaluation of member expression 2 let base value be get value base reference 3 if the source text matched by this member expression is strict mode code let strict be true else let strict be false 4 return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict member expression private identifier 1 let base reference be evaluation of member expression 2 let base value be get value base reference 3 let field name string be the string value of private identifier 4 return make private reference base value field name string expression 1 let base reference be evaluation of call expression 2 let base value be get value base reference 3 if the source text matched by this call expression is strict mode code let strict be true else let strict be false 4 return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name 1 let base reference be evaluation of call expression 2 let base value be get value base reference 3 if the source text matched by this call expression is strict mode code let strict be true else let strict be false 4 return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier 1 let base reference be evaluation of call expression 2 let base value be get value base reference 3 let field name string be the string value of private identifier 4 return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called 1. Let property name reference be evaluation of expression 2. Let property name value be get value property name reference 3. Let property key be to property key property name value 4. Return the reference record, base value, property key, strict, this value, empty, 3, 3, 4, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict, the abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes arguments base value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. 1. Let property name string be string value of identifier name. 2. Return the reference record, base value, property name string, strict, empty, ECMA International 2024 261, 3, 3, 5 venue operator, 3, 3, 5, 1 runtime semantics, evaluation, new expression, new expression, return, evaluate new expression, empty, member expression, new member expression arguments 1, return, evaluate new, member expression, arguments 3, 3, 5, 1, 1 evaluate new, construct expa, arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or a member expression parse node, and arguments, empty or in arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. 1. Let ref be. Evaluation of construct expa. 2. Let construct to be. Get value, ref. 3. If arguments is empty, then a let arglist be a new empty list 4. Else, a let arglist be. Argument list evaluation of arguments. 5. If is constructor is false. Throw a type error exception. 6. Return constructor arglist. 3, 3, 6 function calls. 3, 3, 6, 1 runtime semantics, evaluation, call expression, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, 1. Let X be the call member expression that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, 2. Let member expa be the member expression of expa. 3. Let arguments be the arguments of expa. 4. Let ref be. Evaluation of member expa. 5. Let func be. Get value, ref. 6. If ref is a reference record, is property reference, ref, is false, and ref is evil, then a if same value, func, %evil%, is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let devalard be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return, perform evalarg, strict caller, true. 7. Let this call be this call expression. 8. Let tail call be is in tail position, this call. 9. Return Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6AV is a direct eval. Call expression. Call expression arguments. 1. Let ref be. Evaluation of call expression. 2. Let func be. Get value. Ref. 3. Let this call be this call expression. 4. Let tail call be is in tail position. This call. 5. Return. Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024. 3. 3. 6. To evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func, an ECMAScript language value, ref, an ECMAScript language value or a reference record, arguments, a parse node, and tail position, a boolean, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference record, then a if is property reference, ref, is true, then I let this value be get this value, ref, be else, I let ref env be ref. 2. Assert. Ref env is an environment record. 3. Let this value be ref env with base object, else, a let this value be undefined. 3. Let arglist be. Argument list evaluation of arguments. 4. If func is not an object, throw a type error exception. 5. If is callable, func is false, throw a type error exception. 6. If tail position is true, perform prepare fort. Tail call. 7. Return. Call. Func. This value. Arglist. 3. 3. 7th SLP keyword. 3. 3. 7. 1 runtime semantics. Evaluation super property. Super. Expression. 1. Let env beget this environment. 2. Let actual this be env get this binding. 3. Let property name reference be. Evaluation of expression. 4. Let property name value be. Get value, property name reference. 5. Let property key be. To property key, property name value. 6. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. 7. Return. Make super property reference. Actual this, property key, strict, super property, super, identifier name. 1. Let env beget this environment. 2. Let actual this be env get this binding. 3. Let property key be string value of identifier name. 4. If the source text matched by this super property is strict mode code, let strict be true, else let strict be false. 5. Return. Make super property reference. Actual this, property key, strict, super call, super arguments. 1. Let new target beget new target. 2. Assert. New target is an object. 3. Let func beget super constructor. 4. Let arglist be. Argument list evaluation of arguments. 5. If is constructor, func, is false, throw a type error exception. 6. Let result be. Construct, func, arglist, new target. 7. Let this beget this environment. 8. Perform this bind this value. Result. 9. Let f be this 10. Assert. F is an EC.
Lookup table saves tons of space.
Initialize instance elements. Result. F. 12. Return. 2020.
I'm just going for like pure bit shifting.
To get super constructor.
It's no lookup table.
Super constructor takes
It's like 70 instructions or something, like 74.
value. It performs.
Including rest.
Let envrec beget this environment. 2. Assert. Envrec is a function environment record. 3. Let active function be envrec. 4. Assert. Active function is an ECMAScript function object. 5. Let superconstructor be active function. 6. Return superconstructor. 3. 3. 7. 3 make super property reference. Actual this, property key, strict. The abstract operation makes super property reference takes arguments actual this, an ECMAScript language value. property key, a property key, and strict, a boolean, and returns either a normal completion containing a superreference record or a throw completion. It performs the following steps when called. 1. Let env beget this environment. 2. Assert env has super binding is true. 3. Let base value be env get super base. 4. Return the reference record.
It's like 74 instructions.
Strict this value, actual this. 3.
There's a lookup table.
The evaluate
Almost doesn't compute the same thing.
a list of values 1 3 3 8 1 runtime semantics. Argument list evaluation. The syntax direct. The operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMA
Like 7 times larger.
values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. 1. Let ref be. Evaluation of assignment expression. 2. Let arg be. Get value, ref. 3. Return arg. Argument list. Assignment expression. 1. Let list be a new empty list. 2. Let spread ref be. Evaluation of assignment expression. 3. Let spread obj be. Get value, spread ref. 4. Let iterator record be. Get iterator, spread obj, sync. 5. Repeat, let next be. Iterator step.
This is for the best, right?
If next is
This is for the best.
argument list. Argument list.
This is faster than a bunch of bitches.
List evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value, ref. 4. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. 1. Let preceding args be. Argument list evaluation of argument list. 2. Let spread ref be. Evaluation of assignment expression. 3. Let iterator record be. Get iterator. Get value, spread ref. Sync. 4. Repeat, let next be. Iterator step value, iterator record. B if next is done. Return preceding args. C append next to preceding args. Template literal, no substitution template. 1. Let template literal be this template literal. 2. Let site obj.
How many instructions is this?
Template literal. 3. Return site obj. Template literal, substitution template. 1. Let template literal be this template literal. 2. Let site obj beget template object. Template literal. 3. Let remaining be. Argument list evaluation of substitution template. 4. Return the list concatenation of site obj and remaining.
Half the size.
Template head expression template spans. 1. Let first subref be. Evaluation of expression. 2. Let first sub be. Get value, first subref. 3. Let rest sub be. Substitution evaluation of template spans. 4. Assert. Rest sub is a possibly empty list. 5. Return of first sub and rest sub. 3.
That's using conditional moves.
9.
It's like twice as slow.
Semantics. Evaluation. Optional expression. Member expression optional chain. 1. Let base reference be. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. If base value is either undefined or null, then a returned undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get
I thought there's one here.
3. If base value is either undefined or null, then a returned undefined. Return. Chain evaluation of optional chain with.
These are all like almost exactly the same thing.
An optional chain is a chain of one or more property accesses and function calls. The first of which begins with the token. ECMA International 2024 265. Optional expression. Optional expression optional chain. 1. Let base reference be. Evaluate evaluation of optional expression. 2. Let base value be. Get value, base reference. 3. If base value is either undefined or null, then a returned undefined. Return chain evaluation of optional chain with arguments base value and base reference. 3. 3. 9. 2. Runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. 1. Let this chain be this optional chain. 2. Let tail call be is in tail position. This chain. 3. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. 1. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 2. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, base value, expression, strict. Optional chain. Identifier name. 1. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 2. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict. Optional chain. Private identifier. 1. Let field names.
Why is it checking the bottom?
Identifier. 2. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. 1. Let optional chain be optional chain. 2. Let new reference be. Chain of value.
I think this is like the opposite of mine.
3. Let new value be. Get value. New reference. 4.
Almost the same.
Optional chain. 5. Let tail.
Alright, I'm done with this.
This chain. 6. Return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. 1. Let optional chain be optional chain.
Man, the compiler just guts all the instructions.
Of optional chain with arguments base value and base reference. 3. Let new value be. Get value. New reference. 4. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 5. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, new value, expression, strict. Optional chain, optional chain. Identifier name. 1. Let optional chain be optional chain. 2. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be. Get value, new reference. 4. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 5. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, new value, identifier name, strict. 66. ECMA International 2024. Optional chain. Private identifier. 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base
Okay, back to like
value be
putting the image on the quad.
new reference. 4. Let field name string be the
It's getting boring now.
identifier. 5. Return make private reference new value field name string. The 3rd of March 2010 import calls 3 3 1 0 1 runtime semantics evaluation import call import assignment expression. 1. Let referrer be get active script for module. 2. If referrer is null, set referrer to the current realm record. 3. Let argref be evaluation of assignment expression. 4. Let specify be get value argref. 5. Let promise capability be new promise capability %promise %. 6. Let specify a string be completion to string specifier. 7. If abrupt reject promise, specify a string promise capability. 8. Perform host load imported module referrer, specify a string empty promise capability. 9. Return promise capability. 3 3 1 0 1 1 continue dynamic import promise capability module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call is appropriate. It performs the following steps when called. 1. If module completion is an abrupt completion, then a perform call promise capability undefined module completion be return unused. 2. Let module be module completion. 3. Let load promise be module load requested modules. 4. Let rejected closure be a new abstract closure with parameters reason that captures promise capability and performs the following steps when called. A perform call promise capability undefined reason be return unused. 5. Let on rejected be create built-in function rejected closure 1 6. Let link and evaluate closure be a new abstract closure with no parameters that captures module promise capability and on rejected and performs the following steps when called. A. Let link be completion module link. B. If link is an abrupt completion, then I perform call promise capability undefined link. 2. Return unused. C. Let evaluate promise be module evaluate. D. Let fulfilled closure be a new abstract closure with no parameters that captures module land promise capability and performs the following steps when called. I. Let namespace be jet T module namespace module. 2. Perform call promise capability undefined namespace. 3. Return unused. A. Let on fulfilled be create built-in function fulfilled closure 0. F. Perform promise then evaluate promise on fulfilled on rejected. G. Return unused. Link and evaluate be create built-in function link and evaluate closure 0. 7. Let 8. Perform promise then load promise link and evaluate on rejected. 9. Return unused. ECMA International 2024 267. The 3rd of March 2011 tagged templates. 3 3 1 1 1 runtime semantics evaluation member expression template literal. 1. Let tag ref be evaluation of member expression. 2. Let tag func be get value tag ref. 3. Let this call be this member expression. 4. Let tail call be is in tail position this call. 5. Return evaluate call tag func tag ref template literal tail call expression template literal. 1. Let tag ref be evaluation of call expression. 2. Let tag func be get value tag ref. 3. Let this call be this call expression. 4. Let tail call be is in tail position this call. 5. Return evaluate call tag func, tag ref, template literal, tail call, the 3rd of March 2012 meter properties. 3, 3, 1, 2, 1 runtime semantics, evaluation, new target 1. Return get new target, import meter 1. Let module be get active script for module 2. Assert, module is a source text module record. 3. Let import meter be module 4. If import meter is empty, then A. Set import meter to ordinary object create. Null. B. Let import meter values be host get import meter properties, module. C. For each record P of import meter values, do I perform create data property or throw import meter P. D. Perform host finalize import meter module. A. Set module to import meter. F. Return import meter. Else A. Assert import meter as an object. B. Return import meter. 3, 3, 1, 2, 1, 1 host get import meter properties, module record. The host defined abstract operation host get import meter properties takes argument module record, a module record, and returns a list of records with fields, an ECMAScript language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4. And the values produced by evaluating the expressions embedded within the template literal. 68. Copyright sign, ECMA International 2024. 3, 3, 1, 2, 1. To host finalize import meter, module record. The host defined abstract operation host finalize import meter takes arguments import meter, an object, a nd module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMAScript code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await. Left-hand side expression yield await. Left-hand side expression yield await. Left-hand side expression yield await. Plus unary expression yield await. Unary expression yield await. 1 3 4 1 Static semantics. Early errors. Update expression. Left-hand side expression no line terminator here. No line terminator here. Left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3, 4, 2 postfix increment operator 1 3, 4, 2, 1 runtime semantics. Evaluation. Update expression. Left-hand side expression 1. Let LHS be. Evaluation of left-hand side expression 2. Let old value be. To numeric. Get value, LHS 3. If old value is a number, then A let new value be number. Add old value 1 4. Else A assert old value is a begint. B let new value be begint. Add old value 1z 5. Perform. Put value, LHS, new value 6. Return old value, ECMA International 2024 269. 3, 4, 3 postfix decrement operator 1 3, 4, 3, 1 runtime semantics. Evaluation. Update expression. Left-hand side expression 1. Let LHS be. Evaluation of left-hand side expression 2. Let old value be. To numeric. Get value, LHS 3. If old value is a number, then A let new value be number. Subtract old value 1 4. Else A assert old value is a begint. B let new value be begint. Subtract old value 1z 5. Perform. Put value LHS new value 6. Return old value 3 4. 4 prefix increment operator 1 3 4 4 1 runtime semantics. Evaluation update expression plus plus unary expression 1. Let exp be. Evaluation of unary expression 2. Let old value be. To numeric. Get value expa 3. If old value is a number, then a let new value be number. Add old value 1 4. Else a assert old value is a begint. B let new value be begint. Add old value 1z 5. Perform. Put value expa new value 6. Return new value 3 4 5 prefix decrement operator 1 3 4 5 1 runtime semantics. Evaluation update expression unary expression 1. Let exp be. Evaluation of unary expression 2. Let old value be. To numeric. Get value expa 3. If old value is a number, then a let new value be number. Subtract old value 1 4. Capital E LSE a assert old value is a begint. B let new value be begint. Subtract old value 1z 5. Perform. Put value expa new value 6. Return new value 70. ECMA International 2024 3.5 Unary operators syntax. Unary expression yield await. Update expression yield await. Delete unary expression yield await. Void unary expression yield await. Type of unary expression yield await. Plus unary expression yield await. Unary expression yield await. Unary expression yield await. Unary expression yield await. Plus await. Await expression yield 3 5 1 the delete operator 3 5 1 1 static semantics. Early errors. Unary expression. Delete unary expression, comma it is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identify a reference. Member expression. Member expression. Private identifier. Call expression. Call expression. Private identifier. Optional chain. Private identifier. All optional chain. Optional chain. Private identifier, comma it is a syntax error if the derived unary expression is primary expression, capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N and capital C O V E R, capital P A R E N T H E S I Z E D, capital E X P R E S S I O N, capital A N, ultimately derives a phrase that, if used in place of unary expression, would produce a syntax error according to these rules. This rule is recursively applied. 3 5 1 2 runtime semantics. Evaluation unary expression. Delete unary expression 1. Let ref be. Evaluation of unary expression 2. If ref is not a reference record, return true. 3. If is unresolvable reference, ref, is true, then a assert, ref is false. B return true. 4. If is property reference, ref, is true, then a assert, is private reference, ref, is false. B if is super reference, ref, is true. Throw a reference error exception. C let base OBJB. To object, ref, D let delete status be base OBJ, ref, E if delete status is false and ref is true. Throw a type error exception. F return delete status. 5. Else, a let base be ref. B assert. Base is an environment record. C return base delete binding, ref, The last rule means that expressions such as delete foo produce early errors because. Note: a recursive application of the first rule, ECMA International 2024-271. Note 1: when a delete operator occurs within strict mode code, a syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false, or otherwise cannot be deleted, a type error exception is thrown. Note to the object that may be created in step 4c is not accessible outside of the above abstract operation and the ordinary object. Internal method. An implementation might choose to avoid the actual creation of that object. Three, 5, 2 the void operator. 3, 5, 2, 1 runtime semantics. Evaluation, unary expression, void unary expression. 1. Let exp be. Evaluation of unary expression. 2. Perform. Get value, expa. 3. Return undefined. 3, 5, 3 the TPF operator. 3, 5, 3, 1 runtime semantics. Evaluation, unary expression, type of unary expression. 1. Let val be. Evaluation of unary expression. 2. If val is a reference record, then a if is unresolvable reference. Val is true. Return undefined. 3. Set val to get value, val 4. If val is undefined, return undefined. 5. If val is null, return object. 6. If val is a string, return string. 7. If val is a symbol, return symbol. 8. If val is a boolean, return boolean. 9. If val is a number, return number. 10. If val is a bigint, return bigint. 11. Assert. Val is an object. 12. Note: this step is replaced in section B. 3, 6, 3, 13. If val has a internal slot, return function. 14. Return object. 3, 5, for unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 72. ECMA International 2024. 3, 5, 4, 1 runtime semantics. Evaluation, unary expression, plus unary expression. 1. Let exp be. Evaluation of unary expression. 2. Return to number. Get value, expa. 3, 5, 5 unary operator. 3, 5, 5, 1 runtime semantics. Evaluation, unary expression, 1. Let exp be. Evaluation of unary expression. 2. Let old value be. To numeric. Get value, expa. 3. If old value is a number, then a return number, unary minus, old value 4. Else, a b, assert. Old value is a bigint. Return bigint, unary minus, old value. The unary operator converts its operand to a numeric value and then negates it. Negating plus 0. Note: produces minus 0, and negating minus 0 produces plus 0. Bitwise not operator, unary expression, 3, 5, 6, 3, 5, 6, 1 runtime semantics. Evaluation, 1. Let exp be. Evaluation of unary expression. 2. Let old value be. To numeric. Get value, expa. 3. If old value is a number, then a return number. Bitwise not, old value 4. Else, a b, assert. Old value is a bigint. Return bigint, bitwise not, old value. Logical not operator, unary expression. 3, 5, 7, 3, 5, 7, 1 runtime semantics. Evaluation 1. Let x be. Evaluation of an area expression. 2. Let old value be to Boolean. Get value, expa. 3. If old value is true, return false. 4. Return true. 3.6 Exponentiation operator syntax. Exponentiation expression. Yield. Await. An area expression yield await. Update expression yield await. Exponentiation expression yield await. ECMA International 2024 273. 3. 6. 1 runtime semantics. Evaluation exponentiation expressio. N. Update expression exponentiation expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Update expression. Exponentiation expression. 3.7 Multiplicative operators syntax. Multiplicative expression. Yield. Await. Exponentiation expression yield await. Multiplicative expression yield await. Multiplicative operator. Exponentiation expression yield await. Multiplicative operator. 1 of percent. 3. 7. 1 runtime. Multiplicative
I don't know. Put the image on the quad now.
multiplicative operator exponentiation expression. 1. Let optext be the source text matched by multiplicative operator. 2. Return. Capital E V A L U A.
What's that example?
Capital S T R I N G. Capital O R. Capital N U M E R I C. Capital B I N A R Y. Capital E. Multiplicative expression. Optext. Exponentiation expression. 3.8 Additive operators syntax. Additive expression. Yield. Await. Multiplicative expression yield await. Additive expression yield await. Plus multiplicative expression yield await. Additive expression yield await. Multiplicative expression yield await. 3. 8. 1 The addition operator. Plus. Note the addition operator either performs string concatenation or numeric addition. 3. 8.
Put this.
6. Evaluation. Additive expression. Additive expression plus multiplicative expression. Return. Capital E V A L U A T E. Capital S T R I N G. Capital O R. Capital N U M E R I C.
Man,
N A R.
C++ everywhere.
Additive expression plus multiplicative expression. Note, comma, the operator performs multiplication, producing the product of its operand.
Not actually everywhere.
Performs division
It's not that bad.
of its operands. Comma, the percent operator yields the remainder of
Oh man.
division. 74. Copyright sign. ECMA International 2024. 3. 8. To the subtraction operator. 3. 8. 2. 1 runtime semantics. Evaluation. Expression. Added
It's a whole lot of code.
expression. Return. Capital E V A L U A T E. Capital S T
I can't believe it takes this much code
O R.
to get an image onto a quad. Oh my god.
N A R Y. Capital E at
It literally takes this much code
3.9 bitwise shift.
to put an image onto a surface or a quad or whatever. What the hell?
Expression yield await. Shift expression
That is so much code.
shift expression yield await. Additive expression yield await. 3.
Start.
9. 1. 1 runtime semantics. evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression, 3, 9, to the signed right shift operator. 3, 9, 2, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, I, C, capital N, A, R, Y, capital E, shift expression, additive expression, 3,
Should I run it first?
right shift operator. Note, the operator performs subtraction,
That's the first step.
parens. Note performs a bitwise left shift operation on the left operand by the amount specified by the right operand. Note performs a sign filling
Maybe a sheet or so.
operation on the left operand by the amount specified by the right operand. Note performs a zero filling bitwise right shift operation on the left operand by the amount specified by the right operand. ECMA International 2024-275. 3, 9, 3, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, shift expression, additive expression, 3.10 relational operators, syntax, relational expression, in, yield, await, shift expression yield,
This is here.
expression in yield, relational expression in yield, relational expression,
Here it is.
relational expression in yield, relational expression in yield,
I think.
expression yield await, shift expression yield await, equals shift expression yield await, equals shift expression yield await, instantiaf. Note 1. The result of evaluating a relational operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Shift expression yield await. Plus in, relational expression, plus in yield await, in shift expression yield await, plus in, private identifier in shift expression yield await. 3, 1, 0, 1 runtime semantics, evaluation, relational expression, shift expression, 1. Let ref be. Evaluation of relational expression. 2. Let level be. Get value, ref. 3. Let ref be. Evaluation of shift expression. 4. Let reval be. Get value, ref. 5. Let r be. Is less than, val.
Do people get paid on GitHub?
Far as undefined.
To house code?
Return r, relational expression.
Like you get paid on YouTube.
1. Let ref be. Evaluation of relational expression. 2. Let level be. Get value, ref. 3. Let ref be. Evaluation of shift expression. 4. Let reval be. Get value, ref. 5. Let r be. Is less than.
What?
False. 6. If r is undefined. Return false.
Wow. GitHub doesn't directly pay developers for views or downloads.
Equals shift.
In the same way, YouTube pays creators for views.
Relational express.
Wow. GitHub is not cool.
3. Let ref be. Evaluation.
Oh, they're like, oh, get third-party sponsors.
Get value. Ref. 5.
Wow, GitHub is rolling in money.
Val. False. 6. If R is either true or undefined.
That doesn't seem fair.
Otherwise, return true. 76. ECMA International 2024. Note to the in grammar parameter is needed to avoid
Who cares about programmers, right?
expression with the in operator in if a statement.
Yeah, who cares? Yeah. That doesn't seem fair.
Relational expression equals shift expression. 1. Let ref be. Evaluation of relation.
GitHub should be paying money for views or downloads.
B. Get value. Ref.
Just like YouTube, you get paid to like post video. That doesn't make sense.
4. Let ref be. Get value. Ref. 5. Let R be. Is less than.
So think at the shader for text.
If R is I.
So like paste this into the main and run it, whatever. I need some more water.
Relational expression. Relational expression instantia of shift expression. 1. Let ref be. Evaluation of relational expression. 2. Let level be. Get value. Ref. 3. Let ref be. Evaluation of shift expression. 4. Let reval be. Get value. Ref. 5. Return. Instantia of operator. Reval. Reval. Relational expression. Relational expression in shift expression. 1. Let ref be. Evaluation of relational expression. 2. Let level be. Get value. Ref. 3. Let ref be. Evaluation of shift expression. 4. Let reval be. Get value. Ref. 5. If reval is not an object, throw a type error exception. 6. Return. Has property. Reval. To property key. Reval. Relational expression. Private identifier in shift expression. 1. Let private identifier be the string value of private identifier. 2. Let ref be. Evaluation of shift expression. 3. Let reval be. Get value. Ref. 4. If reval is not an object, throw a type error exception. 5. Let private env be the running execution context's private environment. 6. Let private name be resolved private identifier. Private env, private identifier. 7. If private element find, reval, private name, is not empty, return true. 8. Return false. 3. 1 0. 2 instantia of operator. V. Target. The abstract operation instantia of operator takes arguments v, an ECMAScript language value, and target an ECMAScript language value, and returns either a normal completion containing a boolean or a throw completion. It implements the generic algorithm for determining if v is an instance of target either by consulting target.sat at has instance method or, if absent, determining whether the value of target's prototype property is present in v's prototype chain. It performs the following steps when called. 1. If target is not an object, throw a type error exception. 2. Let instanthandler be. Get method, target, at has instance. 3. If instanthandler is not undefined, then a return to boolean. Call instanthandler, target, v. 4. If is callable, target, is false. Throw a type error exception. 5. Return. Ordinary has instance, Target, v. Note steps 4 and 5 provide compatibility with previous editions of ECMAScript that did not use a @has instance method to define the instantia of operator semantics. If an object does not define or inherit @has instance, it uses the default instantia of semantics. ECMA International 2024 277. Equality operators. Syntax, equality expression, in, yield, await, relational expression in yield await. Equality expression in yield await, equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. Equality expression in yield await equals relational expression in yield await. 3.1.1 runtime semantics. Evaluation, equality expression equals relational expression. 1. Let ref be. Evaluation of equality expressi. On 2. Let leval be. Get value. Let ref be.
Alright, so the plan is,
4. Let reval be. Get value.
there's always a new plan.
Return is loosely equal. Reval. Equality
Because nothing ever works.
equals relational expression.
But the new plan,
Let ref be. Evaluate
the current plan,
expression. 2.
it changes on the go.
Ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval.
Based on if the internet works,
5.
if the server actually is running, that has a website,
Val.
and the code quality.
True. Return false. Otherwise.
Or is this stupid?
Equality expression equals relational expression. 1. Let ref be. Evaluation of equality expression. 2. Let leval be. Get value. Ref. 3. Let ref be. Evaluation of relational expression. 4. Let reval be. Get value. Ref. 5. Return is strictly equal. Reval. Equality expression equals relational expression. 1. Let
Alright, so I think I found this file.
equality expression. 2. Let leval be.
I'm gonna just turn off all my stuff
3. Let ref
and turn on all this stuff.
relational expression. 4. Let reval be. Get value. Ref. 5. Let RB is strictly equal. Reval. 6. If R is true, return false. Otherwise, return.
And it should do this.
ECMA International 2024.
Then I just gotta put the desktop on there.
The operator is always of type boot
That's real simple. Really simple.
between its two operands.
Oh, this sucks.
Note 1. Given the above definition of equality, string comparison can be forced by $sign a equals $b. Numeric comparison can be forced by plus or equals plus b. Boolean comparison can be forced by it equals b. Note to the equality operators maintain the following invariants. A equals b is equivalent to a equals b. A equals b is equivalent to b equals a, except in the order of evaluation of a and b. Note 3. The equality operator is not always transitive. For example, there might be two distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the two string objects would not be equal to each other. For example, new string a equals a and a equals new string a are both true. New string a equals new string a is false. Note: for comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. .12 binary bitwise operators syntax. Bitwise and expression in yield await. Equality expression in yield await. Bitwise and expression in yield await, and equality expression in yield await. Bitwise XOR expression in yield await. Bitwise and expression in yield await. Bitwise XOR expression in yield await. Bitwise and expression in yield await. 1, 3, 2, 4 array initializer. Array elements may be elided at the beginning, middle or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await, elision opt, element list yield await, element list yield await, elision opt, element list, yield, await, elision not assignment expression, plus in yield await, elision not spread element yield await, element list yield await, elision not assignment expression, plus in yield await, element list yield await, elision not spread element yield await, elision, spread element, yield, await, dart, assignment expression, plus in yield await, 1, 3, 2, 4, 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, an array, and next index, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision 1. Let len be next index plus 1. 2. Perform. Set. Array. Length. Len. True. 3. Note. The above step throws if len exceeds 232. 1. 4. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision not assignment expression. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 2. Let init result be evaluation of assignment expression. 3. Let init value be get value init result. 4. Perform. Create data property or throw array to string next index init value. 5. Return next index plus 1. Note an array literal is an expression describing the initialization of an array, using a list of 0 or more expressions each of which represents an array element, enclosed in square brackets. The elements need not be literals, they are evaluated each time the array initializer is evaluated. ECMA International 2024-247. Element list. Elision not spread element. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. Return array accumulation of spread element with arguments array and next index. Element list. Elision not assignment expression. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Let init result be evaluation of assignment expression. 4. Let init value be get value init result. 5. Perform. Create data property or throw array to string next index init value. 6. Return next index plus 1. Element list. Elision not spread element. 1. Set next index to array accumulation of element list with arguments array and next index. 2. If elision is present, then a set next index to array accumulation of elision with arguments array and next index. 3. Return array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. 1. Let spread ref be evaluation of assignment expression. 2. Let spread obj be get value spread ref. 3. Let iterator record be get iterator spread obj sync. 4. Repeat a let next be iterator step value iterator record. B if next is done, return next index. C perform. Create data property or throw array to string next index. Next txt set next index to next index plus 1. Note create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision or 1. Let array be. Array create 0, 2. If elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list 1. Let array be. Array create 0, 2. Perform. Array accumulation of element list with arguments array and 0, 3. Return array. Array literal. Element list. Elision opt 2. Let array be. Array create 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA International 2024. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array 3, 2, 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer as an expression describe in G the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. ECMA International 2024-249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least two of those entries were obtained from productions of the form. Property definition. Property name. Assignment expression. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5, 2 static semantics is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions. Property name, literal property name, return false. Property name, computed property name, return true. Addition to describing an actual object initialize the object literal productions are also 50. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note to the list returned by property name list does not include property names defined using a computed property name. 3, 2, 5, 3 static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions. Property definition list. Property definition. 1. Let prop name be prop name of property definition. 2. If prop name is empty, return a new empty list. 3. Return prop name property definition list. Property definition list. Property definition. 1. Let list be property name list of property definition list. 2. Let prop name be prop name of property definition. 3. If prop name is empty, return list. 4. Return the list concatenation of list and prop name. 3, 2, 5, 4 runtime semantics. Evaluation. Object literal. Return ordinary object create. Object prototype object literal. Property definition list. Property definition list. 1. Let obj be ordinary object create. Object prototype 2. Perform. Property definition evaluation of property definition list with argument obj. 3. Return obj literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal 1. Let NBR be the numeric value of numeric literal. 2. Return to string NBR. Computed property name. Assignment expression 1. Let exp value be evaluation of assignment expression. 2. Let prop name be get value exp value. 3. Return to property key prop name. 3, 2, 5, 5 runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Property definition list. Property definition list. Property definition 1. Perform. Property definition evaluation of property definition list with argument object. 2. Perform. Property definition evaluation of property definition with argument object. 3. Return unused. ECMA International 2024 251. Property definition. Assignment expression 1. Let exp value be evaluation of assignment expression. 2. Let from value be get value exp value. 3. Let excluded names be a new empty list. 4. Perform. Copy data properties object from value excluded names. 5. Return unused. Property definition identifier reference. 1. Let prop name be string value of identifier reference. 2. Let exp value be evaluation of identifier reference. 3. Let prop value be get value exp value. 4. Assert. Object is an ordinary extensible object with no non-configurable properties. 5. Perform. Create data property or throw object prop name prop value. 6. Return unused. Property definition. Property name. Assignment expression. 1. Let prop p be evaluation of property name. 2. If this property definition is contained within a script that is being evaluated for JSON pars, see step 7 of JSON pars, then a let is proto set to be false. Else if prop key is proto and is computed property key of property name is false, then a let is proto set to be true. Else a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter is false, then a let prop value be e. Named evaluation of assignment expression with argument prop key 6. Else a let x for value ref b. Evaluation of assignment expression b let prop value b. Get value x per value ref 7. If is proto setter is true, then a if prop value is an object or prop value is null, then I perform object. Prop value b return unused. 8. Assert. Object is an ordinary, extensible object with no non-configurable properties. 9. Perform. Create data property or throw. Object. Prop key. Prop value. 10. Return unused. Property definition. Method definition. 1. Perform. Method definition evaluation of method definition with arguments object and true. 2. Return unused. 3. 2. 6 function defining expressions. C 15.2 for primary expression, function expression. C 15.5 for primary expression, generator expression. C 15.7 for primary expression, class expression. C 15.8 for primary expression, async function expression. C 15.6 for primary expression, async generator expression. 52. Copyright sign, ECMA International 2024. 3. 2. 7 regular expression literal syntax. C12. 9. 5. 3. 2. 7. 1 static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics. Capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a Boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. 1. Let flags be flag text of literal. 2. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. 3. If flags contains U, let U be true, else let U be false. 4. If flags contains V, let V be true, else let V be false. 5. Let pattern text be body text of literal. 6. If U is false and V is false, then a let string value be code points to string pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. 7. Let parse result be parse pattern text U, V. 8. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics. Evaluation primary expression, regular expression literal. 1. Let pattern be code points to string, body text of regular expression literal. 2. Let flags be code points to string, flag text of regular expression literal. 3. Return. regexp create, pattern, flags. 3, 2, 8 template literal syntax, template literal, yield, await, tagged, no substitution template yield await tagged, substitution template, yield, await, tagged, template head expression, plus in yield await, template spans yield await tagged, template spans, yield, await, tagged, template tail, template middle list yield await tagged, template tail, ECMA International 2024 253, template middle list, yield, await, tagged, template middle expression, plus in yield await, template middle list yield await tagged, template middle expression, plus in yield await. 3, 2, 8, 1 static semantics, early errors, template literal, yield, await, tagged, no substitution template, it is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence, template literal, yield, await, tagged, substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument false is greater than or equal to 232. Substitution template, yield, await, tagged, template head expression, plus in yield await, template.
So many missing headers.
There was not set.
Dang it.
Contains not escape sequence. Template spans, yield, await.
What the hell is algorithm?
Syntax error if the
What kind of header is algorithm? What is this file?
yield, await,
What could possibly be in algorithm?
await, template middle list expression, plus in yield await. It is a
Oh man,
tagged parameter was not
I'm gonna get done
contains not escape sequence.
with commenting these out.
8.
And half of it's not gonna build. Because something from algorithm is being used.
Takes argument raw, a boolean,
What even?
find. It is defined piecewise over the following productions. Template literal, no substitution template, return template string, no substitution template, raw, substitution template, template head expression template spans. 1. Let head be template string, template head, raw. 2. Let tail be template strings of template spans with argument raw. 3.
Oh man.
Nation of head and tail, template spans, template
No.
plate tail, raw, template spans, template middle list template tail. 1. Let middle be template string, tail be template string.
I don't want to write sorting
3. Return the list
functions.
tail. 54. ECMA International 2024.
Fuck.
Template middle expression 1. Return template string, template middle, raw, template middle list, template middle list, template
And many more. That's cool. That's just great.
middle list with argument,
I don't like that.
template middle,
I don't like this.
list concatenation of front and last. 3.
It seems a little dark.
Static semantics, template,
It's like, and many more.
the abstract operation template string takes arguments,
Man.
substitution template,
Crap.
template head parse node, a temp 8 middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called if or is true. Then, a let string be the TRV of template token, else, a let string be the TV of template token, return string. 3, 2, 8, 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. 1. Let realm be the current realm record. 2. Let template registry
I think this is for like Windows. Build 2.
2. AFE is the same parse node as template literal, then
So everything might not convert.
let raw strings be template
Should just be great.
with argument true. 5. Assert raw strings is a list of strings. 6. Let cook strings be template strings of template literal with argument false.
One match. Only one.
Number of elements in the list cook strings. 8.
One match.
Count 232 1. 9. Let template be array.
One match.
Let raw obj be array.
Why?
X be
Yes. He's not using these.
while index count. A let prop be to string index. B let cook value be cook strings index. C perform define property or throw template prop property
Hopefully, none of these are being used.
false true false. D let raw value be the string value raw strings index. E perform define property or throw raw obj prop
There's been a whole lot of errors. Let's get the last one done.
false. F set index to index plus 1 13. Perform set integrity level
Man, come on.
perform define
Is nothing gonna convert?
late raw property descript
Oh my god.
enumerable
Every single header. Really? Come on.
integrity level template
This one's not gonna work either.
append the record template literal template to realm 17 return template
Nope.
returns undefined
Limits could possibly work. I think that's a Windows 1.
sequence. In all other cases, it
Yep, nope, doesn't work.
National 2020.
Fuck.
Note 1. The creation of a template object cannot result in a
Damn it.
of a realm is associated with a unique template.
What even are optional and set? What are those?
3, 2, 8, 6. The template
Is optional include optional?
object is used each time a specific
I hope it is, because it doesn't work.
objects are created.
Please be optional.
Evaluation of the template.
Oh my god, there's only one left.
Evaluation is an implementation choice that is not observed.
All of these aren't supported. Man.
Semantics. Substitution evaluation. The syntax directed
This is really bad.
evaluation
There's a whole lot of stuff to do.
and returns either a normal completion containing
Man.
abrupt completion. It is defined piecewise over the following productions: template spans, template tail, return a new empty list, template scans, template middle list, template tail, return, substitution evaluation of template middle list, template middle list.
There's gonna be a bunch of errors.
1. Let subref be evaluation of expression. 2. Let sub be
That wasn't that bad.
subref. 3. Return sub template middle list, template middle list, template middle expression. 1. Let preceding be substitution evaluation of template middle list. 2. Let next ref be evaluation of expression. 3. Let next be get value next ref. 4. Return the list concatenation of preceding and next. 3, 2, 8, 6. Runtime semantics. Evaluation, template literal, no substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template, template head expression, template scans. 1. Let head be the TV of template head as defined in 1, 2, 9, 6. 2. Let subref be evaluation of expression. 3. Let sub be get value subref. 4. Let middle be to string sub. 5. Let tail be evaluation of template scans. 6. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Template span.
How is this gonna get them? This doesn't. What?
Tailors defined in 1, 2, 9, 6. Template spans. Template middle list, template tail. 1. Let head be Evaluation of template middle list. 2. Let tail be the TV of template tailors defined in 1, 2, 9, 6, 3. Return the string concatenation of head and tail. Template middle list. Template middle expression. 1. Let head be the TV of template middle as defined in 1, 2, 9, 6, 2. Let subref be. Evaluation of expression. 3. Let sub be. Get value. Subref. 4. Let middle be. To string. Sub. 5. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. 1. Let rest be. Evaluation of template middle list. 2. Let middle be the TV of template middle as defined in 1, 2, 9, 6, 3. Let subref be. Evaluation of expression. 4. Let sub be. Get value. Subref. 5. Let last be. To string. Sub. 6. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Capital C O V E R. Capital P A R E N T H E S I Z.
This is clever.
Capital E X
And debug for not debug.
O N. Capital A N. Must cover a parenthesized expression.
Oh, everything's so confusing.
Runtime semantics. Evaluation. Primary expression. Capital C O V E R.
Is it a C++ thing?
A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. 1. Let X be the parenthesized expression that is cover ed by. Capital
I never use assert.
V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. 2. Return. Evaluation of expa. Parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note 3. The string conversion semantics applied to the expression value alike string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257. 3.3 left-hand side expression syntax. Member expression. Yield. Await. Primary expression yield await. Member expression yield await. Expression. Plus in yield await.
It's just, what is this?
Identifier name member expression yield await. Template literal yield await. Plus tagged. Zipper property yield await. Meter property.
This is not actually a 32-bit.
Arguments yield await. Member expression.
Oh my god, this is so confusing.
Identifier. Zipper property. Yield. Await. Super. Expression. Plus in yield await. Super. Identifier name. Meter property. New target. Import meter. New target. New target. Import meter. Import meter. New expression. Yield. Await. Member expression yield await. New expression yield await. Call expression. Yield. Await. Capital C O V E R. Capital C A L L. Capital E X P R E S S I O N. Capital A N D. Capital A S Y, N, C, capital A, R, R, yield await, super call yield await, import call yield await, call expression yield await,
What?
yield await, call
It's a Boolean?
expression, plus
That's it?
call expression yield, identify,
Why is it gotta be so fancy?
template literal yield,
Fancy, huh?
call expression yield,
Why so fucking fancy?
identifier, super call, yield, await, super argument,
Yeah, it's just a fucking normal value.
await, import,
Why is it gonna be all decorated up?
in yield await, arguments, yield, await, argument list yield await, argument list yield await, 58,
With like synthetic sugar
4, argument list,
to make it look so fancy.
wait, assignment expression,
It's just a normal fucking value.
assignment expression, plus in yield await,
I really don't understand C++.
expression, plus in yield await,
It makes no sense.
assignment
It's nonsense.
await, optional expression, yield,
Actually, C++ is like
chain yield
the absence of sense.
optional chain yield await, optional expression yield,
It's not even worth dollars
optional chain, yield, await, arguments yield await,
because it sucks. Quads.
identify,
I ate some water.
literal yield await, plus tagged, private identifier, optional chain yield await, arguments yield await, optional chain yield await, expression, plus in yield, hour, it, optional chain yield await, identifier name, optional chain yield await, template literal yield await, plus tagged, optional chain yield await, private identifier, left hand side expression, yield, await, new expression yield await, call expression yield await, optional expression yield await, supplemental syntax, when processing an instance of the production, call expression, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, the interpretation of capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, is refined using the following grammar. Call member expression, yield, await, member expression yield await, arguments yield await, 3, 3, 1 static semantics, 3, 3, 1, 1 static semantics, early errors, optional chain, template literal, optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024-259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A, B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meter. It is a syntax error if the syntactic goal symbol is not module 13. 3. 2 property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name, is identical in its behavior. Member expression, identifier name string, and similarly, call expression, identifier name, is identical in its behavior. Call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3, 3, 2, 1 runtime semantics, evaluation, member expression, expression 1. Let base reference be evaluation of member expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict. 60. ECMA International 2024 member expression identifier name. 1. Let base reference be. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict member expression private identifier. 1. Let base reference be. Evaluation of member expression. 2. Let base value be. Get value, base reference. 3. Let field name string be the string value of private identifier. 4. Return make private reference, base value, field name string, call expression. Expression. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. If the source text matched by this call expression is strict mode code, let strict be true, else let strict be false. 4. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. Let field name string be the string value of private identifier. 4. Return make private reference, base value, field name string. 3. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict. The abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. 1. Let property name reference be evaluation of expression. 2. Let property name value be get value, property name reference. 3. Let property key be to property key, property name value. 4. Return the reference record, base value, property key, strict, this value, empty. 3. 4. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict. The abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes arguments base value, an ECMAScript language value, identifier name, an identifier name parse node, and strict, a boolean, and returns a reference record. It performs the following steps when called. 1. Let property name string be string value of identifier name. 2. Return the reference record, base value, property name string, strict, empty. ECMA International 2024 261. 3. 5. The new operator. 3. 5. 1. Runtime semantics. Evaluation, new expression, new expression. Return, evaluate new expression, empty. Member expression, new member expression. Arguments 1. Return, evaluate new member expression. Arguments 3. 5. 1. Evaluate new, construct expa. Arguments. The abstract operation evaluate new takes arguments construct expa, a new expression parse node or a member expression parse node, and arguments, empty or in arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. 1. Let ref be evaluation of construct expa. 2. Let construct to be get value, ref. 3. If arguments is empty, then a let arglist be a new empty list. 4. Else a let arglist be argument list evaluation of arguments. 5. If is constructor is false, throw a type error exception. 6. Return constructor arglist. 3. 6 function calls. 3. 6. 1 runtime semantics. Evaluation, call expression, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. 1. Let expa be the call member expression that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. 2. Let member expa be the member expression of expa. 3. Let arguments be the arguments of expa. 4. Let ref be evaluation of member expa. 5. Let func be get value, ref. 6. If ref is a reference record, is property reference, ref is false, and ref is eval, then a if same value. Func %eval % is true, then I let arglist be Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let devilarg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true. Otherwise, let strict caller be false. V return. Perform evilarg, strict caller, true. 7. Let this call be this call expression. 8. Let tail call be is in tail position. This call. 9. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression. Call expression arguments. 1. Let ref be. Evaluation of call expression. 2. Let func be. Get value. Ref. 3. Let this call be this call expression. 4. Let tail call be is in tail position. This call. 5. Return. Evaluate call. Func. Ref. Arguments. Tail call. 62. ECMA International 2024. 3. 3. 6. To evaluate call. Func. Ref. Arguments. Tail position. The abstract operation evaluate call takes arguments func, an ECMAScript language value, ref, an ECMAScript language value or a reference record, arguments, a parse node, and tail position, a boolean.
What kind of magical type is this?
Containing an EC
The heck?
value or an abrupt completion.
It can like hold like 20 different values.
Then, A if is prop
That makes no sense.
is true. Then I let this value be get this value.
Oh, why?
Be ref. 2.
How the hell am I supposed to make this type?
Environment
What the heck? Oh my god, this is dumb.
else. A let this value be undefined. 3. Let
This is so confusing.
evaluation of arguments. 4. If func is not an object. 5. If is callable. Func is false. Throw a type error exception. 6. If tail position is true, perform prepare fort. Tail call. 7. Return. Call. Func. This value. Arglist. 3. 3.
Oh no, it's being assigned to something else.
3. 7. 1 runtime semantics. Evaluation super property. Super. Expression. 1. Let env beget this environment. 2.
What kind of type is optional?
Binding. 3.
This is annoying as hell.
Name reference B. Evaluation of expression. 4. Let property name value be. Get value. Property name reference. 5.
This happens to show up as
To property key. Property name value. 6. If the source text matched by this
whatever is optional, but also
strict be true.
it's just a normal freaking UN32.
Return. Make super property reference.
So how am I supposed to like differentiate between them?
Strict. Super property. Super. Identifier name. 1. Let env beget this environment. 2. Let actual this be env get this binding. 3. Let property key be string value of identifier name. 4. If the source text matched by this super property is strict mode code, let strict be true. Else let strict be.
So it has value,
Make super
and then it has value,
actual this property
but to set the value,
super up.
you do this?
Let new target beget new target. 2. Assert. New target is an object. 3.
That makes no sense.
4. Let arglist be. Argument list evaluation of arguments.
It's like make a decision. Is it a boolean? Is it not a boolean?
Throw a type error exception.
Why does it have to have 70 magical states?
Fun.
It's a freaking unicorn.
7. Let this beget this environment. 8. Perform this bind this value. Result. 9.
Oh, it's annoying.
Assert. F is an ECMAScript function object. 11. Perform. Initialize instance elements. Result. F. 12. Return result. ECMA International 2024 263. 3. 3. 7. To get super constructor. The abstract operation.
Shepard.
It takes no arguments and returns an ECMAScript language value. It performs the following steps when called. 1. Let env rec beget this environment. 2. Assert. envrec is a function environment record. 3. Let active function be envrec. 4. Assert. Active function is an ECMAScript function object. 5. Let superconstructor be active function.
So what are all?
The constructor. 3.
Are all?
Make super property reference.
So
Key. Strict. The abstract operation.
list all the possible accessors for the site.
An ECMAScript language value. Property key. A property key. And strict. A boolean. And returns either an
And how it's accessed.
chord or a throw completion. It performs the following steps when
Why does there have to be like
env beget this environment.
4 or 5 ways to access something?
Super binding is true. 3. Let base value be env get
Why? Why?
base value. Property key. Strict. This value. Actual this. 3. 8 argument lists. Note the evaluation of an argument list produces a list of values 1, 3.
What's the size of this type?
6. Argument list evaluation. The syntax direct. The operation argument list evaluation takes no arguments and returns either a normal completion,
What's the size of?
language values, or an abrupt completion. It is defined piecewise over the following productions.
Show me its union or whatever.
List. Assignment expression. 1. Let ref be. Evaluation of assignment.
Show me its struct.
Let arg be. Get value. Ref. 3. Return arg. Argument list. Assignment expression. 1. Let list be a new empty list. 2. Let spread ref be. Evaluation of assignment expression. 3. Let spread obj be. Get value. Spread ref. 4. Let iterator record be. Get iterator. Spread obj. Sync. 5. Repeat. Alien x b. Iterator step value. Iterator record. B if next is done. Return list. C append next to list. Argument list. Argument list.
Why is it so complicated?
Argument list.
Has value returns true if it contains value.
Ref B.
Value returns contain value.
Expression.
Otherwise it throws. Wow, that's annoying.
3. Let arg be.
Returns value or fallback.
4. Return
Assigns value.
of preceding.
Has dot reset.
Argument list. Argument
Removes value sets to disengage state.
preceding args B. Argument list
Graphics screen equals 3 compares to U32.
B. Evaluation of assignment expression. 3. Let iterator record B. Get iterator. Get value. Spread ref.
Oh, so you use dot value if you want to throw.
Iter
Otherwise you access it like normal. That makes no sense.
done. Return preceding args. C append next to preceding args. Template literal. No substitution template. 1. Let template literal be this template literal. 2. Let site obj beget template object. Template literal. 3. Return site obj. Template literal. Substitution template. 1. Let template literal be this template literal. 2. Let site obj beget template object.
Holy, this is confusing.
Argument list evaluation of substitution template. 4. Return the list concatenation of site obj and remaining substitution template. Template head expression template spans. 1. Let first subref be. Evaluation of expression. 2. Let first sub be. Get value. First subref. 3. Let rest sub be. Substitution evaluation of
So the pool is placed after it.
assert. Rest sub is a possibly empty
If not, has value throw.
combination of first sub and rest sub. 3.
Has value const.
3.
Return has value.
Time semantic.
Reset has value equals false.
Expression. Member
In place.
evaluation of member expression. 2. Let base value be. Get
Reinterprecast
reference. 3. If base value is either undefined
and stores equals v.
defined.
Has value equals true.
Optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. 1. Let base reference be. Evaluation of call expression. 2. Let base value be. Get value, base reference. 3. If base value is either undefined or null, then a returned undefined. Return chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the token. ECMA International 2024 265. Optional expression.
What the hell is this?
Let base reference be. Evaluation of optional expression. 2. Let base
Line as UN32.
reference. 3. If base value
Unsigned char storage.
returned undefined. Return
Size of UN32.
base value and base reference. 3.
Well, that's really weird.
2. Runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and
Oh, it's getting old.
completion containing either an ECMAScript language
I hate caffeine.
record or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Argument.
It takes up twice the space
Chain. 2.
of a 4-byte value.
Position.
Just make a separate bool. Why would you use a type?
Wait call. Base value. Base reference. Arguments. Tail call. Optional chain.
I swear, people in C++,
Text matched by this
they don't know how to program.
strict be true.
Well, actually, that's why they're using C++.
Capital
They don't know what they're doing.
A L U
Because once you learn C++,
capital P
you're like, why the hell am I using this?
R
This is ick. This ick. Ew. C++ icky.
capital
Yeah, I gotta get some caffeine.
H capital E X P R base value expression strict optional chain. Identifier name 1. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 2. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict optional chain private identifier 1. Let field name string be the string value of private identifier. 2. Return make private reference base value field name string optional chain arguments 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be get value new reference. 4. Let this chain be this optional chain. 5. Let tail call be is in tail position this chain. 6. Return evaluate call new value new reference arguments tail call optional chain expression 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be get value new reference. 4. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. 5. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R new value expression strict optional chain identifier name 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be get value new reference. 4. If the source text matched by this optional chain is strict mode code, Let strict be true, else let strict be false. 5. Return, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, new value, identifier name, strict. 66. ECMA International 2024. Optional chain, optional chain. Private identifier. 1. Let optional chain be optional chain. 2. Let new reference be chain evaluation of optional chain with arguments base value and base reference. 3. Let new value be get value, new reference. 4. Let field name string be the string value of private identifier. 5. Return make private reference, new value, field name string. The 3rd of March 2010 import calls. 3, 3, 1, 0, 1 runtime semantics, evaluation, import call, import, assignment expression. 1. Let referrer be get active script for module. 2. If referrer is null, set referrer to the current realm record. 3. Let argref be evaluation of assignment expression. 4. Let specify be get value, argref. 5. Let promise capability be new promise capability, %promise %. 6. Let specify a string be completion to string, specifier. 7. If abrupt reject promise, specify a string, promise capability. 8. Perform host load imported module, referrer, specify a string, empty, promise capability. 9. Return promise capability. 3, 3, 1, 0, 1, 1 continue dynamic import, promise capability, module completion. The abstract operation continue dynamic import takes arguments promise capability, a promise capability record, and module completion, either a normal completion containing a module record or a throw completion, and returns unused. It completes the process of a dynamic import originally started by an import call, resolving or rejecting the promise returned by that call is appropriate. It performs the following steps when called. 1. If module completion is an abrupt completion, then a perform call, promise capability, undefined, module completion be return unused. 2. Let module be module completion. 3. Let load promise be module load requested modules. 4. Let rejected closure be a new abstract closure with parameters, reason, that captures promise capability and performs the following steps when called. A perform call, promise capability, undefined, reason be return unused. 5. Let on rejected be create built-in function, rejected closure. 1. 6. Let link and evaluate closure be a new abstract closure with no parameters that captures module, promise capability, and on rejected and performs the following steps when called. A. Let link be completion, module link. B. If link is an abrupt completion, then I perform call, promise capability, undefined, link. 2. Return unused. C. Let evaluate promise be module evaluate. D. Let fulfilled closure be a new abstract closure with no parameters that captures module land, promise capability, and performs the following steps when called. I. Let namespace be jet T module namespace, module. 2. Perform call, promise capability, undefined, namespace. 3. Return unused. A. Let on fulfilled be create built-in function, fulfilled closure, 0. F. Perform promise then, evaluate promise, on fulfilled, on rejected. G. Return unused. Link and evaluate be create built-in function, link and evaluate closure, 0. 7. Let 8. Perform promise then, load promise, link and evaluate, on rejected. 9. Return unused. ECMA International 2024 267. The 3rd of March 2011 tagged templates. 3, 3, 1, 1, 1 runtime semantics, evaluation, member expression template literal. 1. Let tag ref be evaluation of member expression. 2. Let tag func be get value, tag ref. 3. Let this call be this member expression. 4. Let tail call be is in tail position. This call 5. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. Call expression template literal 1. Let tag ref be. Evaluation of call expression 2. Let tag func be. Get value. Tag ref 3. Let this call be this call expression 4. Let tail call be is in tail position. This call 5. Return. Evaluate call. Tag func. Tag ref. Template literal. Tail call. The 3rd of March 2012 meter properties. 3. 3. 1 2. 1 runtime semantics. Evaluation. New target. New target 1. Return get new target. Import meter. Import meter 1. Let module be get active script for module 2. Assert. Module is a source text module record 3. Let import meter be module 4. If import meter is empty, then A set import meter to ordinary object create. Null. B let import meter values be host get import meter properties. Module. C for each record. P of import meter values. Do. I perform. Create data property or throw. Import meter. P. D perform host finalize import meter. Import meter. Module. E set module to import meter. F return import meter. Else. A assert. Import meter as an object. B return import meter. 3. 3. 1 2. 1. 1 host get import meter properties. Module record. The host defined abstract operation host get import meter properties takes argument module record. A module record. And returns a list of records with fields. An ECMAScript language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note a tag template is a function call where the arguments of the call are derived from a template literal 1 3 2 8. The actual arguments include a template object 1 3 2 8 4. And the values produced by evaluating the expressions embedded within the template literal. 68. Copyright sign, ECMA International 2024. 3. 3. 1 2. 1. To host finalize import meter, module record. The host defined abstract operation host finalize import meter takes arguments import meter, an object, a ND module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMAScript code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await. Left-hand side expression yield await. Left-hand side expression yield await. Left-hand side expression yield await. Unary expression yield await. Unary expression yield await. 1 3 4 1 static semantics. Early errors. Update expression. Left hand side expression no line terminator here. No line terminator here. Left hand side expression. It is an early syntax error if assignment target type of left hand side expression is not simple. Update expression unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3 4 2 postfix increment operator 1 3 4 2 1 runtime semantics. Evaluation. Update expression. Left-hand side expression 1. Let LHS be. Evaluation of left-hand side expression 2. Let old value be. To numeric. Get value, LHS 3. If old value is a number, then A let new value be number. Add old value 1 4. Else A assert. Old value is a bigint. B let new value be bigint. Add old value 1z 5. Perform. Put value, LHS, new value 6. Return old value, ECMA International 2024 269. 3 4. 3 postfix decrement operator 1 3. 4. 3. 1 runtime semantics. Evaluation. Update expression. Left hand side expression 1. Let LHS be. Evaluation of left hand side expression 2. Let
This is annoying.
LHS 3. If old value is a number, then I let new value
So I gotta figure out how to like simulate
1 4.
the C++ type,
Old value is a begint.
because I'm not gonna turn on C++.
Value 1Z 5. Perform. Put value
I already like disabled or whatever,
value
or pick the older C mode, whatever, so I'm not gonna turn it on.
4 prefix increment
I have to convert it.
4 4 1 runtime semantics.
C++ is like the plague.
Sunary
It's bad.
let exp be. Evaluation
I'm not gonna catch it.
2. Let old value be. To numeric. Get value expa 3. If old value is a number, then I let new value be number. Add old value 1 4. Else I assert.
Like once you like get tied in with C++,
Add old value.
you're down with the ship.
Perform.
When one thing isn't supported or doesn't port, and there's so many different things,
5 prefix decrement operator
it's like a crap shot or a crap shoot. I don't know, whatever.
update expression. Unary
To each their own. C++, I'm not gonna touch it.
valuation of unary expression 2. Let old value be. To numeric. Get value.
Oh, I gotta like end the stream. It's another stream.
Then I let new value be number. Subtract old value 1 4.
Not get where I want to get.
I assert. Old value is a begint. Be let new
At least I found tutorials
1Z 5.
with actual code. With actual code, whatever. I need some water.
Value 6. Return new value 70. ECMA International 2024. 3.5 unary operators.
So I don't know. I think my goal is this. I want to get this to output.
Yield await delete unary expression yield await.
So the C++ files, it doesn't look that bad.
Plus unary expression yield await. Unary expression yield await. Unary expression yield await. Unary expression yield await. Plus await. Await expression yield 3
It's actually not that many errors.
3 5 1 1 static semantics. Early errors. Unary expression. Delete unary expression. Comma it is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identify a reference. Member expression. Member expression.
I think it's the heat. The stupid heat. It's like pushing me past my breaking point. I just get real pissed off.
Private identifier.
So I should like stop talking when it's getting really hot out.
Identifier.
It's starting to get out really hot. Like right now, it's like the sun's coming up.
Primary expression. Capital E R capital P A R E N T H E
I need winter to come back. I can't take the heat.
D
So freaking agitated.
P R E S S I O N capital
I think I'm gonna like try to convert the rest of this whatever
E R capital
and get at least an image onto a quad.
T H E
In the next stream, I'll actually be getting video onto the quad.
R
And I'm basically done.
I O
That's all I need.
capital A N ultimately derives a phrase that, if used in place of unary expression,
Well, I also need to like attach it to a button.
rules. This rule is recursively applied. 3 5 1 2 runtime semantics. Evaluation.
I think we use like the eject key on the keyboard.
1. Let
They can hit the eject key
unary
and toggle between
ref is not a reference.
normal desktop mode and then the desktop mode with the shader.
Ref is true. Then I assert. Ref is false. B return true. 4. If is property reference. Ref is true.
I still gotta like render this video. cut out the middle.
True. Throw a reference error exception. See let base objb. To
So that'll be fun.
delete status be base obj. Ref. If delete
Well, it's more fun than GPU programming.
type error exception.
It's too way too long. So I don't know, I think I'm gonna like end the stream and then try to like
See return
patch up a couple of these types.
rule means that
C++, C++ types, whatever.
errors because
In attempt to like get it to output an image.
2024 200
Because I got the shader and the frag files.
a syntax error exception is
They're here, they're also like
reference to a variable.
from the JIT repository, whatever.
If a delete operator occurs,
These look different though.
be deleted has
So I should probably use the ones from the website.
eyes cannot be deleted. A type error exception is thrown. Note to the object that may be created in step 4C is not accessible outside of the
I can't believe GitHub does not pay you. GitHub needs to pay people who like post stuff on GitHub, kind of like YouTube pays for views or downloads. It's ridiculous that YouTube doesn't. I mean, GitHub doesn't pay the people. How is GitHub not paying people? That's ridiculous.
one runtime semantic.
GitHub is like rolling in money, and they can't like pay people for their content.
Evaluate
Like GitHub gets free traffic and they get free code,
return undefined.
and they're not like paying back anything to the community.
5
That makes no sense.
semantics. Evaluation unary expression. Type of unary expression 1. Let val be. Evaluation of unary expression 2. If val is
Well, GitHub is Microsoft
a
at this point, so I don't know.
is true. Return undefined. 3. Set val to get value. Val 4. If val is undefined, return undefined. 5. If val is null, return object. 6. If val is a string, return string. 7. If val is a symbol, return symbol. 8.
Alright, so I'm gonna let the stream go on for a couple more minutes.
9. If
Then I'll end it, start another stream,
if val is a bigint, return bigint. 11.
and get freaking an image onto the quad.
Replaced in section B. 3. 6. 3. 13. If val has an internal slot,
It should work. I have the source code, the demo. I don't have to go through and piece it all together.
very plus operator.
It should be complete. I'm pretty sure it will run.
Note get
It looks like it would run. So, I don't know.
observable side effects.
I'm gonna let the stream run on for a couple more minutes and then start the stream.
ECMA
But I'm gonna eat some food. So like, I don't know. I'll be back in a bit.
1 runtime semantics. Evaluation. 1. Let exp be.
There's something else.
2.
I don't know. Next stream, whatever, baby.
Get value. Expa. 3. 5. 5. Unary operator. 3. 5. 5. 1 runtime semantics. Evaluation. Unary expression. Unary expression. 1. Let exp be. Evaluation of unary expression. 2. Let old value be. To numeric. Get value. Expa. 3. If old value is a number, then a return number. Unary minus. Old value 4. Else. AB. Assert. Old value is a bigint. Return bigint. Unary minus. Old value. The unary operator converts its operand to a numeric value and then negates it. Negating plus 0. Note. Produces minus 0. And negating minus 0 produces plus 0. Bitwise not operator. Unary expression. Unary expression. 3. 5. 6. 3. 5. 6. 1 runtime semantics. Evaluation. 1. Let exp be. Evaluation of unary expression. 2. Let old value be. To numeric. Get value. Expa. 3. If old value is a number, then a return number. Bitwise not, old value 4. Else, AB, assert. Old value is a begint, return begint, bitwise not, old value, logical not operator, unary expression, 3, 5, 7, 3, 5, 7, 1 runtime semantics, evaluation 1. Let x be. Evaluation of unary expression 2. Let old value be to Boolean. Get value, expa 3. If old value is true, return false 4. Return true 3.6 exponentiation operator syntax, exponentiation expression, yield, await, unary expression yield await, update expression yield await, exponentiation expression yield await, ECMA International 2024 273, 3, 6, 1 runtime semantics, evaluation, exponentiation expressio, n, update expression exponentiation expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, update expression, exponentiation expression, 3.7 multiplicative operators syntax, multiplicative expression, yield, await, exponentiation expression yield await, multiplicative expression yield await, multiplicative operator, exponentiation expression yield await, multiplicative operator, 1 of, percent, 3, 7, 1 runtime semantics, evaluation, multiplicative expression, multiplicative expression, multiplicative operator, exponentiation expression 1. Let optext be the source text matched by multiplicative operator. 2. Return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, multiplicative expression, optext, exponentiation expression, 3.8 additive operators syntax, additive expression, yield, await, multiplicative expression yield await, additive expression yield await, plus multiplicative expression yield await, additive expression yield await, multiplicative expression yield await, 3, 8, 1 the addition operator, plus. Note the addition operator either performs string concatenation or numeric addition. 3, 8, 1, 1 runtime semantics, evaluation, additive expression plus multiplicative expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, plus, multiplicative expression. Note, comma the operator performs multiplication, producing the product of its operands. Comma the operator performs division, producing the quotient of its operands. Comma the percent operator yields the remainder of its operands from an implied division. 74. Copyright sign, ECMA International 2024, 3, 8, to the subtraction operator. 3, 8, 2, 1 runtime semantics, evaluation, additive expression, multiplicative expression, return, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, additive expression, multiplicative expression, 3.9 bitwise shift operators syntax, shift expression, yield, await, additive expression yield await, shift expression yield await, additive expression yield await, shift expression yield await, additive expression yield await, shift expression yield await, additive expression yield await. 3, 9, 1 the left shift operator. 3, 9, 1, 1 runtime semantics, evaluation, shift expression, additive expression, return, capital E, V, A, L, U, A, T, E, capital